Good morning, everyone. Welcome to Paris. Welcome to the Wireless Global Congress 2023. My name is Thiago Rodrigues. I'm the CEO of the Wireless Broadband Alliance. A pleasure to have you all on our Congress here in Paris. We have a terrific agenda for the day. I will start just by giving an update on the Wireless Broadband Alliance, some of our achievements of 2023, and then we'll go through the agenda for the day. First of all, I want to thank you all the sponsors of the Wireless Global Congress. Without the support of all these companies, we could not set up these events and run these type of sessions. Like I said, this first part of the morning, we have a terrific agenda with speakers from Orange, Intel, Cisco, and Boeing Wireless that will cover quite relevant topics between Wi-Fi 7, residential Wi-Fi, open roaming, and wireless convergence. I want to start by sharing with all of you that 2023 is a special year for WBA. So it's our anniversary, so it's our 20th anniversary. So WBA was founded back in March 2003 by a group of carriers that joined forces to create this alliance to address interoperability and roaming between Wi-Fi networks. You could see that last June, on the 20th of June, we celebrate our 20th anniversary. The 20th of June is as well the World Wi-Fi Day that we celebrate all together, this special occasion and a big milestone for the Alliance. You can see that we had a lot of fun and we enjoyed a lot this opportunity. During the 20th anniversary celebrations, we took the opportunity to recognize some of the key companies and the key individuals that have been contributing to the Alliance. So these are some of the companies that have dedicated either more time, resources, and contributions to the Alliance, companies like KT, BT, AT&T, Intel, Boeing Wireless, Cisco, and Single Digits. You can see as well some of the individuals that have been more active for longer, some of the board members that have been having longer board terms, and as well the individuals that have contributed more to the Alliance in terms of technical groups. We launched as well the Hall of Honor to recognize some of the key individuals that throughout these 20 years have been contributing to WBA. In particular, we recognize the previous CEO, Shrikant Chenwai. He was the CEO until 2019. We recognize as well the collaboration with Wi-Fi Alliance, with the former CEO, Edgar Figueroa, and as well Nigel Bird from Orange, that was one of the biggest contributors for more than 12 years on the work groups of WBA. So I think it's good to recognize all those contributions from the members, because without the members, WBA could not exist and we could not perform the work that we do today. But we took as well the opportunity in 2023, for the first time in the history of WBA, we updated our branding, we update our logo. So at the management level, at the board, we agreed that was the perfect moment to do that refresh of our image. So that was done. I think has been very successful, very well received within the industry. At the same time, as a wonderful coincidence, we have been very successful on the membership. For the first time on our history, you overpassed the 200 members. We are today way over the 200 members. It's very positive to see the number of companies that join the Alliance, get active on the work groups, and they contribute to the Alliance. And that is confirmed on the work items that we do. So this year we are going to have more than 18 deliverables. We see an increased participation of the members on the work items, both in terms of number of meetings, but as well the number of individuals on the meetings. We increase our extranet users more than 20%. We overpassed the 2,000 participants on our extranet. So it's been a very successful evolution of the Alliance, as well from a work item perspective. Then, one of the emblematic programs of WBA, as all of you that are members know, so the Open Roaming Passport initiatives have been seeing a tremendous adoption by the industry. I can share that every week I receive several emails, several requests from members and non-member companies looking into knowing more about Passport, more about open roaming, how to deploy, what are the benefits. And the numbers that we have accessed can show that we see more than 3 million networks with Passport open roaming active. We have issued more than 1,500 certificates for open roaming. And within the WBA team, we run more than 200 POCs on open roaming, and that number is growing, and the number of requests continues to increase. But we did some extra novelties. So we launched the Asia Pacific Forum. So I have to recognize that for many of our members from the Asia Pacific region, sometimes it's very complex to participate on our meetings because normally they are US morning time. So we wanted to make something special to embrace and give an opportunity for our members in Asia to be more active. So we launched the Asia Pacific Forum. We want to create this platform to get more participation from our members and companies from the Asia region, that they can be exposed to the different technical groups and create as well a platform where we can share ideas, concerns, and achievements. We have today more than 20 companies involved. You can see some of the leadership companies, including HFCL, Telstra, CDOT, and CityRoam. They have been leading this group, and we have been having quite a lot participation across the different market segments. Another novelty is the Enterprise Connectivity Forum. So this is a new platform that we are going to launch tomorrow. So our goal is, let's bring the enterprise community and expose them to the work that we have been doing in WBA. So we want to create a bridge and a direct dialogue with the enterprises that somehow they provide public and guest Wi-Fi services. And we want to create an agile way to exchange information and address requirements and concerns. So if you are interested on enterprise Wi-Fi, guest Wi-Fi, I invite you tomorrow on this room in the afternoon. We'll be launching the Enterprise Connectivity Forum. We'll have some participants from companies like Adidas and Carrefour will be here participating and having a dialogue with us about their requirements for Wi-Fi. Enough of WBA. I want just to give one slide about some trends that we saw in WBA. So for those of you that are not aware, we every year in WBA, we run an industry survey. So we go to the market and we provide a series of questions to collect information. This is a high-level summary of that survey. That survey will be incorporated on our annual industry report that will be released by mid-November. You can see that 76% of the respondents of the survey are more confident to invest in Wi-Fi, and that represents a 50% increase comparing with the previous year. So a significant growth on the confidence to invest more on Wi-Fi. Then we have as well a 68% looking to invest and deploy open roaming and Passport, and that represents as well an increase of 10% comparing with the previous year. So another very positive evolution from the survey results. 88% of respondents, they consider 6 gigahertz critical or important. So that shows as well a continuous growth of the relevance of the 6 gigahertz for Wi-Fi. And you saw as well that almost a big majority of the respondents are looking to AI and Wi-Fi sensing solutions to implement on their networks, portfolio of services, and incorporate those new technologies. At the same time, you can see for the residential Wi-Fi, in-home Wi-Fi, the top 3 drivers for investing on the residential Wi-Fi. You can see QoS, Wi-Fi mesh, multi-AP solutions, and end-to-end security has been the top 3 feedback that we got from the respondents. And the top 3 drivers for open roaming pass points has been the automatic experience, security, and QoS, the QoE and QoS as the top 3 requirements. So I think these are quite interesting. These are, to be honest, very aligned with the work that many of you are driving in WBA. So I think this can create a very good insights and information that we can use to drive our technical programs. And just to finish, I just want to share our vision. So we want to create this seamless and interoperable Wi-Fi services experience. We'll continue to drive open roaming pass point adoption. We want to continue to drive the conversion and coexistence of cellular and Wi-Fi and even other wireless technologies. And we want to accelerate as much as possible any innovation on the wireless space under the umbrella of WBA. And if you are not member yet of WBA, please consider to become a member and join the group and be part of this community. Thank you. Okay, and with this, I would like to invite the next speaker. So Rida Zawawi, so he's the head of new businesses strategy at Orange France. Rida, welcome.
Good morning, everyone. First of all, thanks for having me here, the WBA Network X. It's an honor to be here and share with you our insights from Orange. So let's get into the discussion today. What I wanted to do is to have a slight different focus where you will have during the whole session in different sessions of these conferences. For sure, you will hear of nice topics on seamless. You talked about seamless things, innovations around networks and convergence and technologies. These things are very essentials. But I would like to propose you to have an understanding why we do this. And why we do this is to better serve consumers. And in order to better serve consumers, we would like to understand them first. So what we did at Orange, recently, we had started a survey, a research. It's more than a survey, it's a research throughout Europe. And during this research, we asked different countries, different consumers, not only Orange consumers, it's across operators, I would say. What is for you Wi-Fi? What does it mean? And if you get the answers, you will, I'm sure, I mean, you can expect what they get, but if you look at what they answered, the answer is very basic. For them, Wi-Fi is just a wireless network. Simple as this. It's a service that can give them access to internet. So they don't talk about specific technology, they don't talk about bit rates, they don't talk about performance. All they talk is to get access to their service. And that's very basic. But that's very important. And I think it's important to understand that. So when we define our services, our technology, we have to keep this in mind, because this will define the way we'll serve this. Okay? So what this research told us is that, and I think you know that, for the consumers, Wi-Fi is becoming more and more important, even more than before COVID. The reason is that, of course, there is a lot of entertainment that they use at home, but work is also becoming an important part of it. So because they use Wi-Fi, because they love Wi-Fi more than before, there is a, how do you say, an emotional attachment to Wi-Fi. And sometimes we, as tech-oriented people, we kind of forget this kind of human feelings and attachment to objects and technology. So, and I think it's important to know that. Why is it important? Because you will see, I will give you two examples. You will see through the two examples why is it important to keep this in mind. Because when we try to introduce a new technology or we try to improve their experience, we have to bear this in mind, that sometimes the change, the new things, bring some stress to them. So what we're trying to do, and Thiago, you just mentioned this, we're trying to make it things seamless, easy, transparent, with no burden for them. And that's really important. That's especially important because they have this emotional relationship with Wi-Fi. And even more, since now we have remote working, if they lost Wi-Fi, they kind of fear of losing their job, basically, somehow. Imagine. So, as I said, I will give you two examples to understand what we will do from this research, from this understanding, and how we will implement that. And we did actually implement that into our home network Wi-Fi services. Number one is they want to use Wi-Fi in an easy way. So the one thing which they struggle still today is the setup of the network or the phone or whatever to connect to Wi-Fi, the first connections. So the first connection until today is still a problem, or still a challenge, let's put it this way. Of course, in the enterprise world, there is this roaming, open roaming, which helps to facilitate that. But for home, we still have this PIN approach and the first login attempt. And these things has yet to be simplified. And that's a clear demand from the consumers. So my request here for the industry is, when we define a new technology for the upcoming Wi-Fi or even existing Wi-Fi technology, I think one of the main focus we will need to do is to simplify this first connection. This will accelerate tremendously the Wi-Fi adoption even further. So that's one thing you should probably keep in your bucket list. How can we make Wi-Fi connected with zero touch? Let's go for it, zero touch. Number two, when they talk about Wi-Fi, they don't talk about really the performance. They don't talk about the generations. They don't talk about the technologies. It's something different. It's something far from their knowledge. Not because they don't understand. It's just don't want to bother. They don't want to deal with that. But when we ask them, okay, what is a good Wi-Fi for you? A good Wi-Fi for them is something where they can get access everywhere, anytime they need it. Meaning, if they're in the living room, if they're in the hotel, if they're in the garden, maybe, backyard, they want to have access to their Wi-Fi seamlessly without to wonder whether I need to put a repeater there or I need to get a new access point there, whatever. So I think the other, what do you say, the other movement we need to do is to have a broader technology that get access to a broader space, okay? So the point behind this is that throughput is not the ultimate thing, okay? Coverage and, most of all, stability. For the same reason I just said before, stability is really important. Okay, so that was the first example. Second point is the sustainability. You know, many, if not all, major operators in Europe and probably beyond Europe have shared their views on the neutral carbon footprint. At Orange, we also expressed that, and we said by 2014 we'll get to net zero on our scope 1, 2, and 3. Scope 1, 2, and 3 meaning that our, how do you say, our vendors, all the manufacturers, the OEMs, has to take this into account when they produce and when they define the technology. The definition of in the co-design approach is really important, and this is what we did internally when we defined the new Livebox, the new home gateways, Livebox 6 and Livebox 7. It was designed from a sustainable approach, from the material up to the service. Okay. What does it mean? We realized that we made a short comparison, and I'm sure you know these numbers. We compared a consumption of a battery for a phone compared to our CPEs. And over a year, we can see like we are 24 times higher consuming. A group like Orange operates around 18 million home gateways. For 1 year, if we save 2 watts by reducing some Wi-Fi consumptions, I say Wi-Fi because I will come back to this why. If we reduce by 2 watts only, we can save up to 11 or 12 kiloton of CO2 per year. That's quite a huge number. Only by switching off some of the Wi-Fi signal when it's not needed. And that's what I said. The important thing is to deliver Wi-Fi when it's needed and with the full capacity. And when it's not needed, we just don't have to produce the signal and so on. So here are some of the thoughts we have in terms of sustainability. First of all is, as I said, the power functions. So we believe we can save a lot of our consumption in home gateways by shutting down the Wi-Fi signal when it's not needed, for instance, at night or when there is little numbers of users in home, for instance. And guess what? That I'm going to share with you. We actually launched this in our Livebox, and when we shared this with our customers, said, would you be happy to just reduce the consumptions? They told us, isn't it just working already? So it's just to give you the information that for them, they don't ask themselves how to make it work. For them, it should be working, and it's not. It's not because we don't do it, it's because they have to have an action to do it. So they have to go in their GUI, they have to select, they have to say, okay, I'm going to switch off Wi-Fi from A to Z, blah, blah, blah. So all this customer journey doesn't work. So what we're trying to say here, in order to make those progress, things has to be done automatically, seamlessly. I think seamless and automatic is a really important word, but complicated to put in place. But unless it's automated, it's not going to happen. Just take it for granted. Unless things are done in the network with the devices, nothing will happen. The other thing we believe that Wi-Fi could play a role with the sustainability. Oh, before I move on, the Wi-Fi offload is, so in order to do that, we need the standards. So we need you guys to talk to each other. We need you guys to join us on this work to find a standard solution for that. So that's really important, and I hope with WBA and the WFIC here, they are present in the room. I hope with the organizations like this and IEEE and others, we could find some automatic fashions of doing things. That's really important. So the other role that Wi-Fi could play in the sustainability is the mobile offload. I think this topic has become a kind of usual thing, but Now with the energy crisis we had in Europe and may come up, we never know, at Orange we decided to use Wi-Fi as a kind of sustainable approach. What I mean by that is that we realized that 80% of the traffic is going through home gateways and Wi-Fi traffic. So definitely people are used to use Wi-Fi at home, that's not a question. Now, in case of emergent need of reducing the power, we believe that Wi-Fi could help shutting down some part of the mobile network and making Wi-Fi coping with this. But the other side of the coin, what is it, is that Wi-Fi has to be, again, as I said, really strong and stable. That's why we need it's really time for a carrier Wi-Fi. I think this is a thing we've been talking in this forum many times, but carrier Wi-Fi needs really to be a thing now. It's just not a keyword anymore. We need to have a serious implementation of those technologies so we maintain the stability to offer this continuity of service at home. That's really important. And of course, one last thing is the life cycle of the generations of Wi-Fi. As I said earlier, the reason I introduced you to the consumers' views of Wi-Fi is to understand that people, they attach to their Wi-Fi network, and they also attach the Wi-Fi devices. So the lifetime of a Wi-Fi devices lasts much longer than a mobile device. So we have to cope. The problem with that is that we have to cope with old devices in home networks. And that's a data we have to deal with. It's not a choice from our side. I'm not sure it's a choice from anybody of us here. But the consumers, they tend to extend the usage of their old generations of Wi-Fi, and they actually don't understand what's the difference between the new and the oldest generation. So when we introduce a new generation Wi-Fi, we have to take this into account. So we have to take this transition phase between the old and the newer versions. And also, one request I would have maybe is to make sure that when we introduce a new version, new generation, is kind of mature enough so we don't push the market to adopt new technologies just for the sake of this new, these new features that we love to implement on standard level, but we're not sure whether the consumer will figure out whether there is a need for that or not. I hope those messages, you will keep this in mind. I'm sure they will resonate to you throughout the conference. Again, thank you for listening to me, and if you have any questions, feel free.
Thank you, Rida. Thank you for your presentation. Before you go, I have one question, and you mentioned we have Wi-Fi Alliance as well in the room. Do you believe we industry bodies, we should have some kind of programs to educate the consumers about Wi-Fi? Because these type of surveys present us a completely different view of whatever we do on our technical programs. So do you believe we industry bodies leading this technology, we should have that type of consumer education approach?
Okay, is the education to whom? I mean, WBA educates the consumers about what we do?
Yeah, having a program directly to consumers, somehow to agree on a set of key elements that we should educate consumers. So
definitely.
Please don't put your Wi-Fi antenna on the bottom of, I don't know, of the sofa,
so.
behind the sofa or something.
I think so. I think this is, part of the picture, yeah. Education is really important, but as I said, it's not the ultimate thing. It's part of the picture. Okay. So we have to have indeed some education to do. When it comes to security, it's important. When it comes to usage, how we install things, when it comes to all these things. So education is part of it, definitely.
Okay, thank you. Any questions from the audience? There is one question here. We take one. I know that we are running late, but we'll take one or two questions.
Hi, Dean Bubbly. Thank you for the presentation, and it's good to have the perception from the consumer. There's another stakeholder group I'm curious, does the government here pay enough attention to Wi-Fi? Or does it only look at the fibre to the front door and everything else beyond that is someone else's problem?
That's a good question. I don't have the exact answer, but I have my feelings, is that with the same point as Thiago just said, I think we need more education for the government to understand the effect, the importance of Wi-Fi. I think they understand it globally at European level because there is a lot of, they understand that Wi-Fi can help at some point to minimize the digital, how do you say?
Digital divide,
exactly, connectivity. But I think there is further education work needs to be done as well. I agree.
Okay. Thank you, Rita.
Thank you.
Thank you. Okay, so I want to propose that we move on the agenda. So I would like to invite Ryan Grandschleck, General Manager for Intel for the Wi-Fi and Bluetooth products. Welcome, Ryan. Thank you.
Good morning, everybody. Thank you so much for joining us today. My name is Ryan Grandschleck. We're going to be talking a little bit about wireless innovation at a torrid pace, really focusing on the PC section. But to get us started today, I want to give a little preview of what we're going to talk about, and my team helped pull together a video. So without further ado, let's see if it works. Okay, so as you can see at Intel, we are extremely focused on Wi-Fi 7 and the user experience it's going to be able to deliver to our PC client customers. As this is my first time joining you today with the WBA, I thought I'd take a quick moment to introduce myself. As Thiago mentioned, my name is Ryan Grandschleck, and I have the pleasure of managing our Wi-Fi and Bluetooth team at Intel. When I think about my journey that kind of got me into this role, it really started about 20 years ago with Intel Centrino, when we launched really those first marketing messages and promotion to end customers on home wireless. Yep, that was me 20 years ago, Best Buy service technician in La Crosse, Wisconsin, which I don't know if anybody knows where that is. Any good Midwest people here? Yeah, now we're talking. But I started this role, and I was fixing TVs, VCRs, and all of a sudden Intel launched Centrino. and really transformed what people were looking for in terms of home wireless. And I found myself all of a sudden on service calls 3-4 times a week trying to get people a wireless signal that'll last more than 10 or 15 feet away from their access point, which was life-changing for these customers. And so when I kind of think about my journey that led me here, I've really been fighting to improve that overall wireless experience for our end consumers for about the last 20 years. And that's what I want to talk with you about today. So we're going to have some fun. We're going to have some time for questions because I talk too fast. But I want to talk about the importance of wireless, why Intel cares so deeply about the advancements, the technology, the standards. We're going to touch a little bit on what we're doing at Intel, and then we're going to wrap up with some of the innovations we're doing kind of beyond the standard and some of the partnership opportunities that we see. So at Intel, we love data. We love surveys. We are very similar to our friends at Orange that we are constantly trying to better understand our customers. So we spend a lot of time looking at the market, understanding refresh cycles, really trying to get a handle on customer pain points. And when I say customers, for us, it's a multi-leg journey. So it's our MNC, our OEM customers, it's you and me, it's employees, it's IT DMs. All of those people within the purchase funnel are critical to understand and what their pain points are. I don't think it's going to come as a surprise to anybody here that one of the top 3 pain points continues to be bad wireless. And this is a huge, huge issue for IT DMs and their calls that they're continually getting on how do they improve this, how do they measure it, how do they understand what's happening. And it's also part of the reason Intel is so front-footed on investing in wireless, is because it's also one of the top 5 features that motivate that refresh and that new PC. And so when we start looking at this and kind of peeling that onion back, it really helps us understand our customer better to solve their pain points and their user experiences. Wi-Fi 7, as we kind of introduced, we think is a great foray into that. And when we talk about Wi-Fi 7, one of the reasons we're so excited about it is that it is what we would call revolutionary, not evolutionary. You know, this is an opportunity for us to leap ahead in throughput, in stability, in latency, and it really has value for not only your enterprise customer, but also your consumers. It's always interesting when I go and talk to enterprise, like IT DMs or our MNCs, you know, the first thing they tell me when I pitch Wi-Fi 7 is like, Ryan, I don't care about 320 megahertz. We're not going to implement that in enterprise. Why are you talking to me about it? And then I politely ask them if you're ever going to allow your employees to go home. Because at the end of the day, over 70% of the world's enterprise workers are going to be hybrid workers. And that is still what we're projecting for the foreseeable future. And so we have to change the way we think about marketing, selling to our traditional enterprise and MNC customers to make sure we're taking into consideration the new hybrid world. The other big thing we're excited about here, and it was touched on a little bit by Tiago, was the 6 gigahertz and the new technologies, the new spectrum. What we're able to do here in advancing the overall experience is going to be one of those motivating factors that helps drive that refresh for our consumers. So Intel launched our BE200, this little guy right here. We launched this pretty quietly about 3-4 weeks ago with our Raptor Lake S desktop processors. It's part of a family of 3 processors that we're launching to really bring Wi-Fi 7 to the market. Right now, we're sitting at around 140 design wins as of last week, and that amount of designs is increasing every single day. There is a ton of momentum behind what is happening with Wi-Fi 7, and what is fascinating to me is when you look at a historic kind of refresh cycle and how fast people adopt, it's always a consumer first. You know, consumers are jumping on board, they're your early adopters. And I think that's still going to be the case. We're just starting to see our first Wi-Fi 7 access points for enterprise coming out, and we traditionally see them lag about a year. But when you talk about what to expect from the clients, by 2025, if you take that full year, we're expecting almost a third of all new PC clients shipping out the door to be running Wi-Fi 7, which is a pretty big increase if you compare it to Wi-Fi 6E or some of the other transition points that we've had over the last decade. What we're seeing on the enterprise is there's some really good tailwinds to help motivate this and help drive faster adoption. It's the end of service for Windows 10. You're seeing that MLO, you're seeing the RU puncturing for ITDMs, and you're seeing it come at a time when you think about your average PC refresh cycle, majority of people are corporations, keep me honest here, 4 to 5 years for people in here. You think about what happened during the pandemic in 2021, that amount of refresh exploded exponentially. PC TAM went up 100 million units. Those people are coming up for refresh in 2025, and they're going to want to jump on kind of that Wi-Fi 7 bandwagon. So that's why we're projecting such a nice uptick in 2025. I want to spend a couple of minutes, and I know I'm talking too fast, so you can slow me down at the question section here. But I want to spend a couple of minutes talking about enterprise wireless. So when you think about enterprise user experience, we talked about this earlier, we spend a lot of time really trying to dissect our customers and figure out what their pain points are and what they expect from the next generation of systems. I tried to break it down into basically 5 major points for the enterprise wireless subset of that. Hybrid work continues to define everything we're doing. Multi-devices, excuse me, I'm losing my voice because I've been talking too much. Multi-devices is continuing to be more and more important. Being able to grab your tablet, being able to grab your phone, switch between Apple, switch between Android, Windows, Chrome, having that ubiquitous, being able to cross platforms, cross systems. This is the future of what our customers are demanding and what they're looking for. I think I'm a nightmare to our IT department because I switch PCs probably every 2 to 3 weeks, because depending on what customer I'm meeting with, I'm not going to be the idiot that shows up with a Dell system at HP or an HP system at IBM. You know, it just doesn't go over well with your customer. And so I want a seamless experience across all of my devices. Wi-Fi, private cellular networks, location security is table stakes when you roll into, you know, the enterprise wireless networks. And last but not least, that spectrum sharing that was touched on earlier is so critical to those advanced features and capabilities. So at Intel, what we tried to do is we took these 5 experiences and we said, how do we map them to solutions for our customers? And so when we start looking at this, ICPS, or Intel Connectivity Performance Suite, was an acquisition we did a couple of years ago, really targeted at consumers, and we actually recreated a much more hands-free version targeted at enterprise. So ICPS handles AP selection, packet prioritization. The idea behind it is when you're on your Zoom call, when you're on your Teams call, you prioritize those packets versus your Windows download, and so you have a better experience. Because a lot of people don't understand why their bandwidth is constrained or why they're on a weak access point in a college campus and there's 15 of them all around them. This helps solve some of those real pain points. And the spirit behind it is, to the same point the gentleman at Orange highlighted, is consumers don't want to have to do that. You know, they want that done seamlessly in the background, and the AI algorithms that enhance this help create that for us. Intel Bluetooth. Now, I know this is the Wi-Fi group, but I think it is important to talk about, particularly in light of spectrum sharing. If anybody has a 4 or 5-year-old PC and you've tried to use your Bluetooth on it, can we all agree it sucks? You know? Yep. Thank you. It's not a good experience, and it's super, super frustrating, and you're like, why the hell is this not as good as what I have on my cell phone? And so at Intel, what we've really been trying to do is we're doubling down on Bluetooth and really enhancing that experience with LE audio, increased range. We're trying to solve a lot of the real pain points that our customers have told us, and our OEMs have told us. I think HP was the one who told me, they're like, we want to ditch the dongle. And I'm like, that is the best tagline ever. I want to use that on my marketing promotion. Because the Bluetooth experience needs to be better, and I'm very, very excited that with LE Audio, what we're launching with our new Wi-Fi 7, you're going to see 2x range from what you had before on Bluetooth. You know, before I couldn't walk from my office to the kitchen when I was pretending to work and getting my coffee. Now I can seamlessly do that. It's a completely different experience when you're not worried and you're not tethered to your PC. Intel Unison. So we talked a little bit about that multi-device experience. And so Intel Unison is Intel's solution for that. It's, again, creating that ubiquitous solution across Android, Apple, and Windows. Future rollouts, we're hoping to add Chrome in there as well. I would say right now the solution is really good. It's not great yet. By the end of this year, it's going to be great. I'm super excited about our next gen. I just saw the preview version of it. This allows you to seamlessly do your messaging, your file sharing, your photo sharing across this platform with a whole list of innovations planned to go above and beyond. ICA, so Intel Connectivity Analytics. This one's cool because it was actually born out of the ideas from our customers and some of our partnerships with Cisco and some of the other access partners. And it was a quest for data and intelligence and real-time data and intelligence to be able to adjust on the fly to what the customer was experiencing and kind of solve those quality of service problems. ICA launched about 6 months ago, give or take, with kind of our first big partnership with Cisco. And the initial data and the initial results we're seeing from it are outstanding. We just had a big meeting with Lenovo. We were talking with them on how can you incorporate things like this into a smart engine? How can you overall get this insight faster to your IT DMs so that they can solve problems without having to be on site, without having to go to an individual user? This one has a ton of on-tap potential because of all of the insights and data that we're able to capture real time and how it's interacting with your access points. And last but not least, Intel Sensing. So Tiago touched on this really well. You know, Wi-Fi sensing to me is pretty exciting because what I get constantly yelled at about from my customer is BOM cost. And you know, they're always coming and saying, hey, you're bringing these great features and advancements, but we love them, we just don't want to pay for them. Wi-Fi sensing has the potential to actually reduce the BOM and take out sensors and other applications that they're using in the platforms today to create a better experience. We've got a couple out in market with MSI and a few other folks. By the end of 2024, we have a pretty robust pipeline plan for our next generation of Wi-Fi sensing. But this is going to provide new levels of security, new levels of interaction and how you kind of interact with your PC. And then as we progress down in the standard and we get some more precise into millimeter wave, you'll have gesture control. And so this is kind of the beginning. I look at it as a revolution of how you interact with your PC and being able to do it without burdening your system with another $10, $20 worth of BOM. If you take one thing out of the conversation today, my hope is that you recognize the PC continues to be that primary enterprise hub. It's kind of that first point of contact where people are either going to be delighted or disappointed. And having those connections reliable, having them stable, and creating new experiences that innovate kind of beyond the standard is really the goal of what Intel's wireless team is working on for the next 10 years, and what we're really trying to define how we solve those customer pain points. So I know that was a lot. I do just have 3 quick takeaways. So hopefully you took away from this, and it was not a surprise to anybody on here. Wi-Fi is really important. I mean, this is critical to your customers, to my customers, and it has a direct correlation to your employee satisfaction. Like, it's crazy. Whenever we lose service in our neighborhood, we're a little more rural, my neighbors are freaking out. And they're just like, are you down? I'm down. Where do I go? What do I have? Having a reliable, stable, fast wireless connection is so paramount to a good experience for your customers. The advancements that we're making in the technologies, in the standards, in the spectrum, in the channels, this is going to drive that next level of innovation. And last but not least, we need your help. In preparing for this, again, never had a chance to be here today, I talked to a lot of people. I was like, okay, so what's the WBA focused on? What do they care about? What do they do? And one of the best things is it was described to me as a group of people who tend to leave their company badges at the table and come in and try to solve real experience problems for their customers, and to really try to get themselves in the mind of those folks and solve real issues, real pain points that we're all experiencing. So thank you. Help us continue to do that and help us really drive that next level of innovation forward. So.
Thank you, Ryan. Congratulations for the presentation. By the way, after 20 years, you look exactly the same. You need to share with us what is the secret.
Lots of alcohol.
I wanted to touch on one point that you mentioned, that you see on 2025 the refresh of the PC portfolio of users. Do you see? Is there anything that we can do as well on the network side? How can we accelerate the refresh on the network side somehow to maximize the benefit? Because if I have a Wi-Fi 7 laptop, but the network doesn't have Wi-Fi 7, so there is always a gap. So how can we minimize that gap?
So that's a good one. I think there's a couple of different things that we need to look at, and it really depends if you're looking at it from an enterprise standpoint or a consumer, because how we refresh is slightly different. I'm going to take consumer first because it's easier. So from the consumer standpoint, when we launched Wi-Fi 6E, we went super hard and aggressive with bundling, with activities, with Fnac, with Dixon's, with Best Buy, all of your retail players to help educate them on the values and benefits of it. Now, I think there's more that we can be doing there. Intel obviously is very vested in trying to do those types of refreshes. On the enterprise side, I think it's a little different. They're going to stand back a little bit. They're going to want to wait. But the good news is, from an enterprise standpoint, is particularly to me, MLO, the RU puncturing, being able to manage their channels, being able to actually, you can reduce the amount of access points needed with the better quality Wi-Fi on client devices. And so that's part of our sales pitch when we're going into ITDMs. We're like, hey, let's optimize the heck out of your network. Okay. There isn't a single golden answer.
Correct.
But to me, it's really partnering and going in hand by hand with access point vendors, with telecoms, with people, and saying, hey, how do we just create a better solution? And this is your intercept. This is why you want to have it ready to go in 2025. Beyond that, there are things I would love to have that I'm fighting, like Windows. Anybody have an Android phone that says Wi-Fi 6E or Wi-Fi 6 or stuff like that? I would kill to have that in Windows, where we have our meetings with Microsoft and we're pushing them any way we can to add that type of thing. We had a great conversation with Google on making those types of advancements so people understand what network they're on. It's also kind of the spirit behind what we're doing with ICPS, is that actually shows you, hey, this is a Wi-Fi 6 network, this is a Wi-Fi 5. And so people understand why they're not getting the full capabilities. So it's just that education is probably the first step.
Very good. Thank you, Ryan.
Yep.
Any question from the audience? Ryan. There is Dean has another question. Okay, microphone is coming.
Thank you. As you probably guessed, I'm an industry analyst, so I'm always asking complicated questions. So
I love it.
It was good to have the insight into the attach rate of Wi-Fi 7 you expect over time. You mentioned private cellular. My take is at the moment that most laptops still do not, or a tiny percentage, have cellular integral. Do you see that changing much, or is it going from 3% to 4% or something like that?
It's a good question. So I don't pretend to be the expert on it, but when I look at the analyst reports, we talk to our customers and what they are trying to do. Majority of them expected to maintain a single digit. Europe has always been the outlier. They've always had a higher cellular attach than majority of any other region. And part of that, I think, has played back into some of the strength of the Wi-Fi networks in other regions. At this point, I don't see that. We did a 5-year projection on it before we decided to kind of shut down our wireless WAN division, and we saw it as relatively flat for the next kind of full range.
Okay.
That's really cool. Thanks.
Thank you.
Yep.
Thank you,
sir.
Ryan. Thank you so
Appreciate
much.
it.
Okay, so I will move on the agenda. So I'd like to invite my good friend Matthew McPherson, wireless CTO at Cisco, and my colleague at the board of WBA. Welcome, Matt.
So happy to be here. I think if you're attending this session, you probably have heard about open roaming. It's one of those topics that the WBA likes to spend a lot of time talking about. But what I wanted to do is to talk a little bit about why open roaming. And, you know, so look, if a lot of people, they look at Wi-Fi and they say, you know what, automatically connecting to Wi-Fi in a secure fashion, that would be great. So can we solve that? Can we just automatically connect to Wi-Fi? But I would say there's a little more to it than that. So what I want to do is I want to take a step back and walk through a few things that have happened over the years. So 2003 in Hawaii, 3GPP did its first work item on how to converge UMTS and WLAN networks. Now, some of you that are as gray as me might actually remember this. But this was a work item, and it's a good idea, right? I mean, why not? I mean, it would be great. The network can manage the path. The network can manage mobility, right? You could get a carrier class experience. This would be a great thing to do. You could optimize based on the number of users, and you could use all the spectrum. So this sounded like a really good idea. So over the years, we put together a few different architectures on how to solve this tightly coupled model of integrating these things together. Now, some of you might actually remember some of these architectures. How many of these have seen dominant adoption? Oops. So if I look at this entire diagram, the evolved PDG. Now what does the evolved PDG do? And I think we all experience, you know what that does? That does Wi-Fi calling. It does Wi-Fi calling because the Wi-Fi calling terminates in the network and it starts what? It starts with your dialer on the phone. So it's something that can be completely controlled end to end by the service provider. So in this one case, we've actually applied some of this architecture. Now, I don't know about you, but I looked at my phone the other day, and I had over 220 applications on my phone. One uses this, the dialer, right? So, enter the next generation. So how is this really working? So what's really happening is what I would call a loosely coupled architecture where you have Wi-Fi networks And Wi-Fi networks can take you all the way through. It can take you from the access. It can take you through the switch fabric. It can take you into the SD-WAN. It can take you out to the network and get to your application servers. And you have 5G networks. And guess what? 5G networks can do the same thing. So I would propose that this is the dominant technology today. In fact, when you go through a portal, what you're doing is you're logging into a loosely coupled network. Now the devices know how to connect to both, right? So we have these devices that are connecting to both sides of this network. And so this is really the problem we have to solve. Now, if you implement the technology this way, the advantage that we had when we were talking about tightly coupled models is that it could manage the handoff. It could actually manage that experience on where you were going. When you're doing something like this, what happens is that the indoor network may not be owned by the same entity as the outdoor network. So how are you going to converge these two networks together? But the problem is that in our experience today is that everything that goes into 5G, it's pretty much an automatic connection. When's the last time when you went into 5G, you went into the connection manager and you selected which 5G network to connect to? And you had to look for the little lock to say, is this a secure network or is this an insecure network? Oh, and if I pick this network, I got to go to this portal and put in my email address. You don't do that in 5G because all of those negotiations have been done in the background. They've all been done as B2B negotiations. So those roaming relationships exist, and you can just connect to 5G anywhere in the world. But in Wi-Fi, that's not the case. In fact, I call it portal pain. Portal pain. Now, there's some good things about portals, right? If you do a portal, well, you can advertise. It's a good place to put that little checkbox, hey, I accept the T's and C's for going on this, Maybe, in fact, you asked me, do they still do this? Do they still advertise? I experienced this when I came here. I got on my airline. My airline, what did it do? I wanted to get on Wi-Fi because in all honesty, I was still working on these slides. I wanted to get on Wi-Fi, and it took me to a portal, and what did I have to do? I had to watch a little 30-second video, right? All of these things. So portals give you some capability to do that. In fact, portals can actually implement what you're trying to do when it comes to billing and things like that. But I would propose that portals are actually a problem. Now the bad, I carry multiple devices. Do you guys get a consistent portal experience on all these different devices? In fact, do you get a portal? Sometimes. Sometimes you don't get a portal. Sometimes you have to go to your web browser. And so this is quite painful. So it doesn't work consistently. There's also this problem of black holing. And I travel a lot, and this happens to me a lot. I get out of the cab or the Uber, and I go to run into the airport. What happens? It discovers the Wi-Fi, and it kind of connects to the Wi-Fi, but it didn't really connect to the Wi-Fi because at the lower layer it's connected, but you didn't go to the portal, and so you're not approved to get through the internet. So what happens? You get this little message, if you go look at your connection manager, well, you're connected, but you don't have access to the internet. Now, typically, when I'm running in the airport, what I want to do is just get my daggone boarding pass so I can get through security. I go to pick up, I go to get my boarding pass, and doggone it, not connected to the internet. So it produces this other problem, right? Not only are you black holed, but now you just want to get your boarding pass. So what do? You turn Wi-Fi off. Now that's not what we want, is it? We don't want people just turning it off. So we don't want this black hole. And I skipped one. Users hate portals. So I'll just do a little survey right now. Who loves their portals? Okay. I'm actually getting a thumbs down from Dean. Users just don't like portals, and it affects attach. There's so much pain associated to going through a portal. They won't connect to the network a large percentage of the time. So let's talk about the ugly. All right, now if I don't go through the portal, then I don't have both paths really available to me. And if I don't have both paths really available to me, then I can't do mobility across the Wi-Fi network and the 5G network. So now I'm broke. It's not a seamless experience. And so we want to make sure we don't lose that seamless experience. I already talked about not connecting at all and turning off the Wi-Fi. Now, I couldn't help myself, so I looked this up. The Zapier guys do a great guide on this, and they tell you all these technical ways of actually addressing, well, if you're not getting a portal, you can try these things. And it's actually a very accurate guide. But here's the first thing. Turn off alternate DNS servers. So my wife called me once. She said, I'm at the airport. I can't get on the Wi-Fi. I'm pretty sure if I told her to turn off the alternate DNS servers, that wouldn't have been the answer she was looking for. You know, try to open the router's default page. Open a non-HTTPS site in incognito. Now these, if you try these actually work. And you know, I'm not taking a shot at Zapier. This is actually a useful guide, right? So here's one that most people can do. You know, restart your device. Now, was that seamless? Was that a seamless experience? Reboot your device? Yeah, I'm on a WebEx call in my Uber. I go to run into the airport. It kind of half attaches to Wi-Fi. And, oh, hang on a second. I'm losing the connection. Let me go to my portal. I got to reconfigure my DNS server. So this is just too painful. And this is the result. So here, this is a place, a healthcare hospital actually, where we turned on open roaming. And you can see exactly when we did it. So on the left-hand side of this chart, this was the attach rate. This was putting people through portals, right? And you're getting like 25% attach rate, right? Look at what happened when you turned on open roaming. And you automatically connected securely, right? You bypass the portal, you just connect. It increases by 3 to 4 times, 80–90% attach rate. Now, what does that mean? That means that we have both paths available to us. So we've got to attach. That's the first problem we have to solve. That's why we did Passpoint. That's why we did open roaming. Open roaming is a scalable way to implement Passpoint. That's what we're doing. And we want to make it so that it scales up and down. So we come back loosely couple wins. And so what we do is we combine the ability to do a loosely coupled architecture where you can actually have access networks that would have many different owners. Because when you go to different Wi-Fi networks, what's the likelihood that the different Wi-Fi networks that you're attaching to are owned by the same company? Pretty daggone low, right? This year, we're crossing 600 million guest Wi-Fi access networks around the planet. So that's a lot of different companies implementing a lot of different Wi-Fi. So this is something that has to scale. You want to be able to use multiple different identities. You want to be able to use the identities that are already on your device. And so I'm going to talk a little bit about this scale thing here. So what happens in mobility, and we took a hard look at this when we first started designing, even way back in the days of Passpoint, because I remember when we were first writing the specs for Passpoint, we looked at this and we said, you know what, we really can't do roaming like 3GPP did roaming, because they have these lawyers and they work on these roaming agreements. The average service provider, the MNO, typically has somewhere shy of around 700 roaming agreements. And if you have that many roaming agreements, then you can go anywhere in the world, get off the plane, and it'll authenticate into that network. And this takes a lot of manpower, takes a lot of time, takes a lot of negotiating. You have to negotiate the different rates and things like that. Now, I just said, now the problem that we have with Wi-Fi is that we've got over 600 million of them. And you may have heard me say this before, but you know, there's a lot of lawyers that would like to be involved in 600 million contract negotiations. But you know, look, we're adding Wi-Fi networks faster than we're graduating lawyers. And I don't know if there's any lawyers in the audience, but most of us aren't really looking to graduate more lawyers. We're trying to make these things simpler, right? So, and we want to go from this mobility that I would call homogeneous, where it's like access networks. So you're going from LTE to LTE, or 5G to 5G, or even Wi-Fi to Wi-Fi. What's a good example of a Wi-Fi to Wi-Fi homogeneous roaming network? Take EduRoam. EduRoam, you can go to pretty much any university, and you can go Wi-Fi to Wi-Fi, and it'll roam, right? So we want to go from these homogeneous type roaming to heterogeneous roaming. We want to be able to do multiple different identities with multiple different kinds of access networks that are owned by multiple different companies or entities. Because if we can connect that investment of network deployments together, then we can digitize countries, and we can provide access all the time, anywhere. So this is what we're getting to in open roaming. So does open roaming solve the problem of a convenient, easy connection with security? The answer is yes, but it's bigger than that. It's how we're going to crawl across all these different networks so that you can seamlessly have access and move your sessions as you go. So this shows a little bit of an example of that, is some of the things that I'm talking about. Now, because is it possible that the roaming relationship isn't just taking a service provider ID and using that service provider ID into a Wi-Fi access network? We used to call that SP Wi-Fi. Is it possible that an enterprise would like to roam to home with its policy? Yeah. Is it possible that an enterprise would like to roam into a hotel? Yeah. So actually, roaming is a multidimensional thing. So as we're developing a technology for doing this, we want to make sure that we can handle this many-to-many relationship, and we can solve not only the user onboarding problem, but the network onboarding problem. How do you onboard all of these networks so that they can work together? And that's what open roaming does through its federation. We call it federated roaming. So you have a federation. If you're an identity provider, you can join that federation. If you're an access network, you can join that federation. You can do that, Thiago, in about 30 minutes. You can join that federation. And now any access network can use any credential anywhere in the world. And now we're unifying these networks together. So that's what we're trying to do. Now, are there new business models associated with this? I would say that there are. I couldn't help myself. I was looking at the Cisco network, and you look at enterprise network. Cisco's got some 60 buildings, I've lost track, over in San Jose, and of course we have a guest Wi-Fi network. So I asked the IT department, I said, well, how many connections on that network are guest? And what they told me was, what they told me is about 6%. About 6%. We have a lot of guests that come to Cisco. We like our customers, you know, they come see us. And if you look at what is the typical over-provisioning that we do on those networks. Now in enterprise networks, you typically over-provision somewhere between 10 to 100 times. You might find that surprising, but if you look at the overall traffic through a day, first off, there's like no traffic happening at night, right? So what you're doing is you're designing the network for these bursts, and you're designing networks for bursts that might happen in a particular location because there's an event happening in this particular piece of the building. But what you find, so if you apply a little math, right, 6% of the connections were guessed in those 60 buildings of carpeted enterprise, right? If you're 10x oversubscribed, and I'm being conservative, if open roaming gives a 4 times attach rate than what you get if you're doing a portal, then worst case, service provider would consume about 2.4% of the capacity of a typical enterprise network. It's already there. It's already there. It makes sense to combine these networks together because much of the capacity is already there. So why wouldn't we use it? Why wouldn't we build these relationships between these access networks so that we can digitize countries connect people, things, and the next generation that we're seeing in the demands. So why would enterprise do this? People often ask me, why would enterprise do that? Well, I mean, you're not asking a lot for 2.4%, but why would they do it? Well, it's the same reason enterprise does anything. Productivity. So we run an executive briefing center. We have customers come in all the time. Before open roaming, you know what happened? The customer would come in and they'd spend the first 15 to 30 minutes. Well, how do I get on the Wi-Fi? Well, let me set you up this account and password. You know, what is that? It's lost productivity. So you want to produce an environment that's as productive as possible. And by the way, when you start to connect these consortiums together, what do your employees get? Well, when your employees are visiting another company, another partner, another customer, guess what? Your employees connect to that network too. So everybody's benefiting here. It works both directions. So this is, this is the thing. So scale, make it easy, and offer new business models. And I'm pretty confident, I look out at this audience and I'm pretty confident that if you offer these capabilities in an easy way, will the industry build services on top of it? Of course they will. Of course they will. How could you not? It's too ripe. So this is some data that the 2022 data hasn't quite rolled in yet. I often use this slide when I'm talking about 6 gigahertz and spectrum and things like that, but what I wanted to show here is that if you look at, and I have here Germany, so I wanted to take some examples in Europe. So I have Germany, well, I've got Portugal, I've got the UK, and what you can see if you look over on the left-hand side here is the growth in fixed traffic. And it turns out that Wi-Fi relays 92.3% of all traffic going into and off of the internet. Now, the 5G guys, they have a problem because the demand in 5G is definitely going up too. And you can see, in 2021, it was considerably more demand than there was in 2020. So these are big growth numbers for the 5G guys too. So there's only a couple of things that you can do to address this. But my point is that the Wi-Fi, given the spectrum availability and the way that we architect these networks, the Wi-Fis are being built for that curve, for that upper curve. So if we combine these networks, can we establish relationships where each of these can benefit from that growth and that capacity? When you look at Wi-Fi, there's a reason that Wi-Fi is able to get so much traffic through the network. One is because it's got so much spectrum. Right, and we're now looking at allocating in Europe. They've allocated the lower 6 gigahertz. In the US, they've allocated the full 1200 megahertz. So there's just a lot of spectrum that you can use. Two is what I call reuse factor. So the fact that Wi-Fi has a short range means that Wi-Fi is deployed very dense. Now, how do you get more out of a 5G network? Well, there's only a couple ways. What you can do is you can improve layer 1. You can do new codecs and things like that. The other way that you can do it is you can add more spectrum. Now, I think all of us understand that getting more spectrum is hard. It's hard. Most spectrum is occupied. You have to move other things out, or you have to share it, which is what we're actually doing in 6 gigahertz. The other way that you do it is you densify. You put in more cells. Now, what's the problem with putting in more cells? Cells cost money. CapEx, OpEx, right? Now, is your user base really going up? So there's more demand on the network, but they're not actually getting huge increases in users, and so the revenue stream is staying pretty much the same. So it's requiring all this cost, right? So what I would propose is you have these big cells, you got 5G, and then what do you have? 600 million hotspots, typically strategically placed where people do their work, where they live, where they play, where they learn. And so we need to converge these. Now, can I get from this hotspot to this hotspot without 5G? Nope. Both of the technologies are critical. Right? And we want to tie them together. This is some of the strategy behind open roaming and why we need to make this simple. We need to make it secure, and we need to make it easy for these networks to join so that we can use these IDPs. So with that, I think that's my last slide. And I'll just say, open roaming, I got a new slogan for you, connecting our digital future. Diego.
Thank you, Matt. Couple of questions. We got one question from the audience online. So someone put a question asking, okay, so if we are losing the portals, how can we monetize using open roaming, and with all these extra attachment rates, how can we somehow find a way to monetize without the portal?
It's a really good question, because there's lots of people monetizing off of that portal. But remember, what were we really using portals for? We were using portals for the connectivity at all. We were using it to discover the networks so that we get attached to the networks. Now, the interesting thing about open roaming is we don't need the portal to connect, but you can still do a redirect. So in other words, if you come into a presence of a network and you can automatically connect to that network, any sessions that you have going on, including a voice call or something more rich like a collaboration application, or even if you're doing something like augmented reality, you can maintain that connection. But if you want to do a redirect so that you do that advertising, you can. In fact, we used to do this a lot at Mobile World Congress. We didn't want to nag our users, so you don't put portals up there all the time. But every morning when you came in, even though you were already connected to the network, we could do a redirect and get a portal that's saying, hey, this is the keynotes for the day. And so you can still do these things.
Yeah.
Right? It's still available to you.
And you can push message into the device,
that's right,
notification menu.
The other way that we typically see is that there's a lot of onboarding that's happening through the application itself. And if a user is on the network, then the application becomes more rich and available. And so a lot of your then multi-channel marketing and things like that actually happen through the application.
Sure. I think there is one question over there, if we can have the microphone.
Hi, thank you so much for your presentation. Based on your calculation, you said that as of now, around 60% just connected as a guest, and by doing some calculation, you infer that around 2 or 3%, the utilization would be. But this is just the initializing point, whenever the open roaming hopefully become more spread, then these numbers are not valid, and maybe by positive loop or something like that, they go, exponentially. And maybe even the 10 times over design of the networks even is not enough.
Yeah.
How do you think about
and
this?
Look, the traffic's going to grow. There's just no two ways about it. So I think what's going to happen, in the case that I was showing, I was talking about carpeted enterprise. So I'm not talking about the stadium case or the airport case where the purpose of the network is connectivity for guests, right? Because that's quite a different equation, admittedly. But my point on that particular one was that the second most occupied space to your house where you live is your work. And there's an incredible amount of square footage there where this would not represent a lot of traffic because that network was actually built for the employees, right? Now, will it go up? I think it will. So we'll have to take that into account as we grow. But what I was showing in the overall growth of country traffic, you can see that the Wi-Fi networks are being designed to carry orders of magnitude more, right, than the other.
Okay. Thank you, Matt.
All right, my pleasure.
Thank you. So I would like to invite another good friend of me, Dr. Derek Patterson from Boeing Wireless, CTO and member of the board of WBA. Derek, welcome.
Wow, this is great. Hopefully everybody's having a good time. I got to sit here in the front and I got to listen to a carrier who's one of my customers at most of the venues that I support. I got to listen then to Intel and all the devices. So we have a device ecosystem that we're trying to support at all these locations that I'm supporting. And then we got to listen to a vendor talking about all the challenges and the importance of being able to have these networks to get together and being able to have those networks. And what's interesting, when I sit here and I look at this, I've been to a lot of conferences. I go to, I think all of us, unfortunately, the conferences are back. We're going to a lot of conferences. And I sit with a lot of CIOs across a lot of different industries. And this ecosystem is fragmented. We can see it by just the conversations we just saw by all the different partners. And I just have to say, this is one of the reasons why I became part of the WBA, is because what we heard was we're trying to solve this across a fragmented group of people who are trying to solve this. And at the end, what we're trying to solve is we're trying to connect people and devices and create use cases that ends up reducing friction. You know, one of the things that I do for fun is I like to add friction in my life. So I go race motorcycles in Baja. I go hunting. I go do these, you know, I go run. I go exercise. I do these things. I like friction there. Where I don't want friction is, as Matt said, is when I'm trying to go to the airport, I'm trying to go through there. How can I reduce that friction so that I can make my life better? And the problem is it can't be done by anybody without us fixing this fragmentation across all of these different people that spoke before me. So it's really fun to be there. And that's, for most of you know, I'm with Boingo. I'm hoping a lot of you have heard me speak before, so I don't need to go into who Boingo is. But what Boingo's job, and I think most 3PO's jobs are today, is to try to simplify this complexity. Because it's not just an Intel device that's got smarts in it. It's also an IoT device. It's also multiple different types of devices, biometric devices, cameras, all kinds of things that we're trying to connect, and people and different use cases, and trying to figure out how do you simplify all of that and be able to create that opportunity for that friction to go away so that we can go back and add the friction by ourselves in the things that we want to do. And so I really liked all the conversations. A lot of the things everybody talked about lead in to where I'm going to talk next. And I'm going to talk a little bit about the quality of service and that AI and the capabilities of that. First of all, PassPoint, we launched it in 2014. I had stats like this when I launched every airport back in 2014 for Sprint, T-Mobile, Verizon, and AT&T. And I had stats showing you that attach rate. Did we have to do upgrades because our attach rate went to 10x? You know, we didn't see a 4x attach rate when we did the first PassPoint networks across all the airports. We saw a 10x. And there were upgrades that had to happen. And then we had challenges like 802.11k and V and R, right? So it's supposed to help us so as we go from AP to AP, as I'm walking through the airport, I don't lose a connection. So how many of our devices support K, V, and R today? Does an Android device support K, V, and R? No. Do some of the other devices that we use that perhaps are connecting to Wi-Fi? No. This is part of the challenges that we've come out with these solutions. We end up doing things like, hey, we've got a new solution, KVR, it's going to fix it so that I can walk through the airport, and then the device ecosystem doesn't do it, or some other ecosystem that we have isn't working together. And so that's really what we're trying to focus on. So when I think about all the firsts that we've done in Boingo, one of the reason we do these firsts is to try to figure out what the problem is that we're trying to solve for that healthcare provider, that airport, that stadium. And a lot of times we get stuck. And so then we're like, what are we going to do? And so what's happening in airports now? We're starting to realize I can't rely on your device giving you a boarding pass because I don't know, depending on the device, whether that cellular device is going to be connected. Is the DAS good enough? Is the Wi-Fi good enough? Is it switching? Is it blackholing? So we're starting to say, well, let's go put in a bunch of screens and start using facial recognition to get you on your planes, because I can control that. and I can end up creating all of those, and I can control that and make that airport be more seamless, because that's what the airport wants. It wants to reduce that friction for you now, and that's a good change that we're starting to see. In the past, they didn't care. They're just like, that's a problem for United. I don't care, or your carrier. Now they're realizing that they have to be a part of it as well. So that's the good thing that's happening now. So I wanted to talk about this. Their use cases are what matters. Those experiences are what matters. And so I have an example of 5G, and many of you have heard probably me talk in the past about 5G. And I said 5G, 6G, all this stuff, you know, it's all marketing. At the end of the day, what we're really trying to create is it's a marketing spin saying we want a better connectivity than we had before. So we want the 5th generation. And a lot of people go, well, it's a standard. And I go, yeah, it is a standard. But at the end of the day, what the standard in 5G is trying to say is focus on the use case, focus on the opportunity, focus on removing that friction. And in 6G, it's like, let's take it to that next step. Now let's do it across all of our networks, right? And that's what hopefully we'll get to. So I argue 5G is here. It's at the beginning stages, and it's combining Wi-Fi, cellular networks. It's a convergence of all of these networks that Matt was talking about, and that Ryan was talking about, and that Raid was talking about. It's a convergence of all of this, and looking at it from the perspective of that use case. So a transportation use case I'll go through. So how many of you have been to Newark Airport recently? They just redid Terminal A. Has anybody seen Terminal A? Huge expense by the airport. Finally, the airports are saying, you know what, we're going to spend some money. We're going to actually build a network. They came to us and they said, I want to have a great experience at this on this Newark Airport. I want to use biometrics. I want to have the baggage being tracked from the time it leaves where you check it in, all the way to the plane, and then when it comes off the plane and all the way back, they want to be able to check it. And I'm going to create an app that you can go to and you can see your baggage as it's moving across the airport. And so in Terminal A, we built that for them. It's using Wi-Fi, it's using cellular, it's using some IoT spectrum, it's using all of it to be able to create that kind of environment. And to me, that's what 5G is for. It's to create those kind of frictionless use cases. I've got a bunch of others I could go through. One of the fun ones is this sports and entertainments with robotics. One of the things that happened is there's a young lady who was sick who wanted to be able to go to a soccer game in Austin FC. And so what we ended up doing is we enabled a network for her robot to be able to work seamlessly through both Wi-Fi and cellular network, and she could steer the robot and participate on the sidelines in a game. And these are some of the cool things that you can do when your network is stable and it's secure and it actually works. She was able to control it all herself. And then I've got a couple others. Military is a fun one that we've got up in Whidbey Island, where we've got Wi-Fi, cellular, and all of them working together to be able to do AV and VR technical training for them on that base. So it's a really cool one. Anyhow, the idea is that we want to connect everything. And to be able to do that, it's going to require us to recognize, as Matt said, as others have said, that we have a lot of these different networks available to us. And what we need to do is we need to figure out how to be able to put them all together and then be able to create this great experience for the future. And that requires us thinking about how are we going to converge those networks instead of just doing the EPDG fix, right? And I've gone down the multipath quick and multipath TCP realm with a bunch of different servers that I put in the network over time, and then I ended up eventually going, okay, it's not ready yet, so I had to pull it back out, but we're going to get there. And it starts with the connectivity. We have the way to do it, as Matt said, and then it leads into now recognizing that private networks are just another part of that tool in the toolbox that we also have to integrate. So we've got to figure out how do those actually function in the same pane of glass, have the same security, have the same everything else across that. And so that's another important part of the system. I talked about Newark real quick. Here's some examples of what the challenges that the airport told us that they wanted us to solve. And again, this is in Terminal A. It's our first one we're really proud of because we're doing all of these different things. We have put in a private network that we're starting to use for a lot of cameras and stuff, and we're moving on to now starting to add additional use cases. But all of these solutions are possible today, but it's still fragmented. So every time I'm connecting another device, I have to go, okay, how am I going to connect that device? Am I going to use a public cellular network, and I'm going to use a private cellular network? I'm going to use a public Wi-Fi, I'm going to use a private Wi-Fi, am I going to use a LoRaWAN? What am I going to do to get all this to be able to create this environment? And that's the challenge, and that's one of the great things about being here. I'll just say it again at the WBA, because we're going to solve the connectivity thing. We've got open roaming. We're going to solve the sharing thing. We're talking about open AFC and the opportunity in the future for AFC to move on, to be able to let sharing combine with perhaps the SaaSes that we're used to in the OnGo Alliance, right? But we're going to combine the learnings of the SaaS, combine the learnings of the open AFC, and we're going to make it work in the WBA, because that's what we do, right? We end up figuring out how to make that work. Here's another example, Padres Park. So Padres ended up, I think I've shared this story before, but when OnGo was first launched, it was one of the first private cellular networks we used, and they have incumbents in the US on the CBRS network. And they said all these Navy ships are going to interrupt anything that goes on in San Diego, because there's so many Navy ships in the San Diego harbor. And if you've ever been to Padres Park, it sits right next to the harbor, right next to all these Navy ships. So I went to a partner, again, a CIO partner of ours at Padres Park, and I said, hey, I want to put in a CBRS network at your park. Can I do that? And he goes, okay. And how much will it cost? I said, you know what, we'll do it for free. I just want to see if this is going to work and see if I'm going to have a bunch of problems with people stepping on the spectrum, some of these ships. So we put it in, and we said, oh, great, we're not having any interference. So then we go, okay, now let's start creating use cases for it. So we ended up starting to build use cases. Now what they have is they have this area outside Petco Park. We put up 5 antennas. They've got about 20 iPads that they use. And they took this Gallagher Park, which used to make, I'm not supposed to say the amounts, but let's just say it was a low amount of money, like sub 100,000 a year. And now it's making multiple 6 digits in the 6 figures, okay? Because they were able to end up creating a network that allowed them to connect and be able to create a service that wasn't available in that park area before, selling t-shirts and beers and whatever else they're selling there. But again, it's going to the CIOs, going to the CTOs, going to the venues and saying, what do you need? And I agree with what Matt said. We don't need captive portals. We need landing pages. We need landing pages that want people to come there, experience something, and create those experiences. So if we focus on those experiences, then I start getting into where I'm really going to talk about, and that's we're adapting our networks to be able to support these experiences and these outcomes that we're trying to create. And so we're going to solve the connectivity. We're going to solve some of these things. The next phase is looking at each one of those use cases, understanding each one of those use cases, and then adapting your network for those use cases, which is something we don't do today. We create a network. We say, I've got a network. It has coverage and it has capacity. But we don't sit there and say, what's that camera's need to be able to function correctly? And what's the right network for that camera? And what's the right network for that other device that's trying to connect, or this other use case? So what we need to do is we need to build our networks so they adapt to the use cases that we're putting on them, which means what? We need to understand our our locations, our enterprises, what's going on in those networks, and we need to adapt to it. One of the interesting things that I'll say I've done in my home network, I have a home network. I went and bought a ranch, and I have a backhaul from Starlink. I have a fiber that I just put down my road. I have a point-to-point that I used by one of the partners here between one of the ISPs. So I have 3 different backhaul connections, and I have every single network that you can imagine out there. I've got multiple Wi-Fi networks for multiple providers, multiple cellular networks, private cellular networks for multiple providers, and of course I have a cradle point, and I have multiple different connections in my cradle point from all my different providers that I have out there. And I use these networks to sit there and figure out which traffic is going across them, and what I'll do is I'll actually build an adaptive analytical model to move different traffic across these different networks at different times to see how it works out. That's the next level of this, is trying to figure out how we end up realizing that we're going to go into slicing, and if we're going to create slices, we need to know what's going on in the network. You just don't create a slice and say, that's for you. It's not for you. It's for this use case and this opportunity that we're trying to create. And so it's important as we start thinking about AI and we start thinking about analytical AI, and we also have generative AI, that we end up thinking through that AI that we're creating, and we need to put that as part of the next phase of our WBA work, is identifying traffic, marking traffic, so we know what that traffic is as it's going through in a secure means, right? We can't use the way we do it today is we do DNS, and we end up saying, oh, I've got DNS, but DNS isn't secure, and so it ends up allowing us to have all kinds of problems. We need to secure DNS. So we're going to have to start realizing that we need to mark traffic as it's going through our networks so that we can end up adapting to that traffic and adapting our networks to that traffic as it's coming through. And so that's the next step of understanding and creating this quality of service experience, is to go ahead and think about your connectivity and prioritize that connectivity based on the traffic and based on the use cases and based on those opportunities you're trying to create. And that's going to allow you, by doing that and combining that data and that AI and creating one of these powerful AI engines, you're going to end up creating a better system for the long run that sits across all of these different networks, so you can end up creating that better experience. And of course, a big part of that is going to be the security of that too. We all talk about zero trust. The challenge you have is you take your device and you go connect to that, whatever network it is, that private network or that public Wi-Fi network or whichever network, you need to maintain those security profiles across all of those networks, which means that, again, we have this fragmented system, and we're going to sit there and say, okay, launch a VPN. Well, VPNs are yesterday, right? We shouldn't be doing VPNs anymore. It's like the thing, it's like firewalls. It's like not going to provide us the kind of security we need for the future. So we need to be starting to think about this zero trust architecture, which starts on us understanding the data that's going through, what that data is for which use case, and a lot of times it's multiple different data coming from 7 or 20 different apps on your phone. Each of them has a different security profile, and we're trying to use the same security profile on every single piece of that data. And so instead of doing that, we should be putting that security on each point of that data. So that's my quick forward thought for you about where we're going when we start thinking about connectivity of the future. And I really like what I heard at the beginning, because that quality of experience is where we're going next. Obviously, we can't get there until we get everybody using open roaming and Passpoint and some of these other things. But this is also a vision of the future of where we're going to go. I leave this to you. We've created some ebooks that we started creating these ebooks because we realized, as Tiago said earlier, there's an education that needs to happen in the industry. And so it's on all of us to educate. We're not going to end up being able to tell Matt's wife how to do a DNS refresh, right? But we're also challenged to try to tell a CIO who's operating an airport what the difference is between a private cellular network and a Wi-Fi network and all of these different things. But they do understand what devices they have and what kind of use cases and experiences they're trying to create. So these are some good ebooks that kind of simplify that learning for these different verticals that we take to CIOs. They're available to download, and you can use them. Still feel free to grab them, use them, share them, because I think that that's a big part of what we're focused on right now is educating the future of connectivity. So with that, I'd like to thank you, and I tried to get us back on time. I know we're 20 minutes over, so I spoke very fast. I'm available all day today, so feel free to reach out.
Time just for one question. Anyone has any question to Derek? I have a very short one.
Okay.
You mentioned adaptive AI to orchestrate all these wireless technologies and networks. Do you believe there is a need on the industry to harmonize, standardize those AI capabilities?
Yes. I definitely do. I think we're all playing with it in our own little way. Some of us were sitting at lunch yesterday, and we were talking about what we're doing with adaptive AI. And again, there's two different types, right? There's the analytical part, and then there's the generative part, but both of them are important. But we were talking about it, and we're all playing with it, but the standards around it don't exist.
Yeah.
Right? And that's one of those things that I think is important if we're going to end up creating networks of the future. We need to start having some work items on creating AI for our networks.
Thank you, Derek. We are running late on the agenda, so I propose that we just have a short break, 10 minutes break. We come back at 10 past 11. Thank you.
Hi there. We're going to be starting this track in about 2 to 3 minutes. So please take your seats, recharge your coffee, and I will be back with you and our speakers very shortly indeed. If people could take their seats, we are going to kick off on this. So, excellent. That's me. I'm Dean Bubley. I'm the person who's been sitting near the front asking the annoying questions. If you don't know me, I'm an industry analyst. My Twitter or X alter ego is Disruptive Dean. I occasionally like to stress test ideas by throwing a few rocks at them occasionally, politely, usually. And I'm going to be covering this section. We've got 3 presentations. Originally it was 4, but it's now 3. And then a panel session on 6 gigahertz. And this is going to be fairly technology heavy. We're looking at some interesting future things around 6G. We need to distinguish 6G and 6 gigahertz. Because we've seen this already in the past of Wi-Fi, that people confuse 5G and 5 gigahertz. Let's not do it again. So what we have today is 3 presentations, and we're talking about Wi-Fi 7, we're talking about the role of Wi-Fi in the future in 6G, and also some of the trends around convergence, whether you want to call it offload or something else. And I'll probably be throwing a few curveballs in as we go along. And then the other thing is this panel later on 6 gigahertz. And for people who know 6 gigahertz being used in Wi-Fi 6E and 7, it's also very heavily contested by the mobile industry, who wants access to it. And there's also a bunch of existing users. So we'll come on to that towards the end of this before lunch. But for now, I would like to welcome the first of our speakers to the stage, Maria Cuevas from BT, who's a Network Research Director, and she's looking at the links between Wi-Fi in the 6G era as we get towards it. Maria.
Thank you, Dean. Good morning, everyone. Thanks for being here. I kind of feel a little bit like Derek has stolen my thunder a little bit, because I think a lot of what I'm going to say, but actually I don't see it that way. I see it as being very much aligned with the thinking that Derek has shared with us. But I'm going to put it more in the context of 6G. Which is starting to appear and be discussed. So I will talk a little bit about what's going on in terms of 6G, what we see as the principles and guiding principles of 6G. But before I do all that, I'd like to talk a little bit about myself and why I'm here talking about this topic. So I work in BT. I'm a telecoms engineer. I've been in industry for about 23 years now, and all of it, most of it, spent mostly on mobile, what you might refer to as cellular technologies. So seeing 3G, 4G, 5G, and obviously now discussing 6G. However, throughout my entire career, my vision and my mission has been that technology needs to be serving real customer needs and must be driven by those customer needs, as opposed to my favorite technology, which I happen to be an expert in, or my company obviously owns an awful lot of IPR, or whatever the rationale might be. We all need to, as an industry, make sure that we're using the right tools for the right purpose, as I said, to serve the needs of the customer. And throughout my career, I think I've reinforced, if you like, that learning, in that even if you are a technology expert, or if you happen to be working on a solution in one particular field, you should open up, look at the world, because there is an awful lot of innovation out there that you can leverage as well. And fast forwarding, if you like, you'll be glad to hear, I'm not going to talk about my entire career, but I will give you a couple of data points, if you like. During my days in standards and my very early career, I was involved in the evolution of the mobile voice standards, what's now called IMS, IP Multimedia Subsystem. At the time, we were trying to decide whether it was going to be SIP or H323. So SIP won, but from the very early days of that particular technology, the vision is mobile-centric. It's going to be mobile voice. It's going to be defined to deliver voice as a service to our customers. And to be honest, a bunch of us didn't agree with that view, right? It's why? Voice over IP was also happening. We had peer-to-peer services, and we had Skype, and all those things happening. And it seemed like two completely different worlds. And as I say, us, from the BT perspective, but a number of operators completely disagreed with that view and worked really, really hard in the standards to actually bring those worlds together. And I won't go through the history of how that happened, because we had to take a few steps, if you like, to make IMS comply with non-SIM devices, which in the early days was a no-go, for the cost of solutions to come down to, again, an acceptable level to offer fixed voice services. And if we fast forward to where we are today, effectively IMS is the converged architecture to offer integrated voice solutions, no matter what access network you're using. I'm posing that there as an example because I remember in the early days of IMS, when some of us were talking about the use of IMS in non-mobile, everybody thought we were crazy. It's never going to cost in, it's super complicated, it has to deal with all these mobility events, and you don't need all that for the fixed world, so why would you do it? And here we are now with a very good solution, actually, which can be cost-effective, which can be customized for the needs, obviously, of different customer segments and so on. And I'm posing that as an example because I think we have an opportunity, and I think completely agree with a lot of the points that Derek has been making. We don't necessarily need to wait for 6G to happen. A lot of the tools are already at our disposal. But I do want to explain how we do actually see 6G evolving in a number of areas to make a lot of that a lot more frictionless. Anyway, enough of an introduction, and I'll get started then. Not going to go through the agenda. I just wanted to start with a lot of what you know already, which is mobile generations apparently happen on a per 10-year cycle. Nobody really knows why, or there isn't a single industry-agreed rationale for it. But we believe there are a number of reasons, right? It tends to be the time it takes from research, and in many cases, it might be a new waveform that is created from a research perspective, and obviously taking that through standardization, in this case 3GPP, plus obviously the time it takes to productize and produce solutions that can be deployed. There is another parallel to that, which is the evolution of semiconductors. And this is not just from a device perspective, this is also for the base stations to cope with the processing power required to handle those more complex waveforms and do radio scheduling and all those good things that we know about. And of course, in between all that, there's got to be spectrum allocation and availability of spectrum, and sometimes you have to clean up some bands or refarm spectrum and so on and so forth. I actually think as an industry we should rethink this 10-year cycle, because obviously things don't necessarily have to go the way they went in the past. But the reality is that most people are assuming that 2030-ish is the time frame when 6G will roughly appear. And in the run-up to that, as I said, a lot of conversations, a lot of discussions, and a lot of, actually, in this particular case, I wanted to share the guidelines from the Next Generation Mobile Networks Alliance, which is effectively most mobile operators, but we have vendors and we have an ecosystem, if you like, of key players in this space, defining what we see as the key principles for 6G. Nobody knows what 6G is. But the way I like to put it is that what we should decide is what it isn't, and also actually what are the, again, what is the ambition, what is it that we're trying to achieve. I'm not going to go through everything in this list, but I did want to highlight the ones where I believe Wi-Fi has a very strong role to play. And these are taken straight from that paper, which you can download from the web. It talks about new services and innovation. Surprise, surprise. I mean, that's not a new thing, is it? I mean, in the outset of 5G, we were all talking about enhanced mobile broadband, massive machine communications, and so on and so forth, ultra low latency, all those good things. I think we are still looking to evolve a lot of those features and a lot of those services. But for me, what is very profound here is that any features that we look to develop for the future, we should think about them more broadly than just cellular technology. And again, I think key examples there, for instance, there is an awful lot of work on sensing and location capabilities across both the Wi-Fi and the cellular world. And if my service requires positioning to work throughout, regardless of whether I'm indoors or outdoors or in a rural area, we should be thinking about an industry about how those features come together to provide, effectively, we should be a frictionless service to our customers. That's one key example. They're actually very vocal about seamless integration with satellite and fixed. And of course, when they talk about fixed, they talk about fixed with Wi-Fi, if you like, at the end of it. And that seamless integration, again, coming, and the way I like to define this is completely seamless experience for the customer. I don't need to look at the little icon in the corner of my screen, whether I'm on Wi-Fi or 5G or 4G or who knows. I don't have to turn on and off particular access networks because they're getting annoying. It just works. And that, to me, is what seamless experience should be all about. So again, why can't we use all of the tools at our disposal to make that happen? Network simplification is a really important one. These are operational priorities, the things that we need as a business to continue to operate in a sustainable way. So operational priorities, network simplification, I would actually come back to my IMS example. I think that is the best example of, or one really good example of, I have a single architecture, I have a set of options, of course, in terms of suppliers, solutions, to tailor the needs to my customers, but I can operate them all in a common way, and I don't have a million different technologies to deal with, and I think we should aspire to that. I've always thought that we should actually be running one network. And of course, that network will have complexity, and it will have a set of compute infrastructure, and we will have network functions that we can deploy very dynamically, scale up and down, depending on the needs of each network slice. Some of them might be Wi-Fi only, and may only ever need Wi-Fi as an access technology. Other slices might be cellular only, but I do believe that having a slice that can deal with all of the above in terms of access technologies is actually the way to achieve that network simplification goal. And that goes hand in hand with energy reduction. If I'm able to see all of the access technologies around me and how many options do I have to reach my customer, and I know what my customer wants, I'm able to make the right decision for the right purpose. And when I say I, by the way, it's not necessarily the network operator on its own. I think this is an end-to-end story. I'm going to come back to that later, but I think Derek was talking about devices, right? And having to obviously make sure that the entire ecosystem is actually working together to make that the right decision. We'll come back to that a bit later. This one is a bit of a repeat, but on the guiding principles, you will see again the kind of repetition of we need to serve our customer needs across all of these mobile networks. I think that's a kind of a restatement of the previous point. And backward compatibility, this is a fantastic one, actually. I think the Wi-Fi industry got this right, okay? When I change my access point at home, I don't have to change my printers and all of my devices in the home. And why should we in the cellular network? And of course, we've evolved in that space as well, and we have things like dynamic spectrum sharing. But guess what? It's not very efficient, okay? So if we can get it right this time, in terms of being able to support previous generations, if I deploy a new generation of technology, we should be thinking about backward compatibility from the start, not as an aftermath, which is what happened last time. I'm going to move on. As I said earlier, nobody knows what 6G is. A lot of governments and funding and projects are happening. I'm highlighting these two because they're happening in the UK. BT is involved in both of them. We are actually involved on a third project as well, slightly smaller and more focused on the radio area. And these are led by key universities in the UK, University of Surrey, University of Bristol. And I think the only point I wanted to make here is, well, 2 points actually. You might see on that picture that is effectively what they call a 3D network. And by 3D, what they mean is, again, non-terrestrial, terrestrial, Wi-Fi, and all of the above. So that kind of network of networks, which I will come back to later, is actually the vision that these projects are leading towards. The other key point is the list of companies involved is actually very heterogeneous, and I think that's how you get innovation and how you get the ecosystems working together. So we have academia, we have operators like ourselves, we have small and large vendors, we have innovation institutes, you name it. I mean, the list is huge, and you can actually find them on the web and find out more from our DCIT website. And talking of which, this is the Department of Science for Technology, Innovation and Technology. I'm not going to read all this out, but this is our public policy on UK wireless infrastructure strategy. Network of networks is all over the place. The need to serve our customers wherever they need connectivity for whatever they need it and whenever they need it is effectively all over this paper. They talk about efficient deployment. They talk about indoor all of the time. They talk about cellular and Wi-Fi. And I'm going to come back to some of these points. I just wanted you to know that this is written in black and white by our government in terms of the direction of wireless technology in the UK. And last but not least, this is a BT perspective on why we think this is important, and some of the things that we are already doing and looking at, but more profoundly, the why we think this is important to our customers. I think Derek mentioned EPDGs. That's some nice memories, even before EPDG. Some of you may remember a technology called UMA, which tried to do the same thing. But then at the time, actually, UMA wasn't very successful because devices did not support it at all. I mean, I think we had about 2 devices in the market that supported it. But anyway, coming back to what this means. And again, point I've been making over and over again, we need to provide a reliable service. Reliability is key. Where customers need it, when they need it. So if you are in your household and you either have poor coverage in the center of your house or your basement or wherever it happens to be that your mobile signal isn't reaching your device, you can get phone calls onto your native dialer using this technology. Now, it sounds simple. It really isn't that simple, but it works. It works perfectly well. It actually even keeps your call as you walk out of the house. And customers love it. They absolutely love this service. And simple as it might be, it's actually what customers need, is what customers demand. And we need more solutions like that, where they don't have to think about where they are when they want to make or receive a phone call. They don't even want to. Obviously, what they don't want to is miss a phone call because they happen to be in the wrong place in their household. So this avoids them doing that. Just an example. A lot more to come if we get this right. Second one, which is also something that we've already done, and we tend to refer to it as always best connected. And again, back to the seamless user experience, you don't really need to decide or proactively do anything. This is actually to do with our fixed broadband service. If your fixed broadband line has some sort of failure, you fall back to cellular. And that's completely seamless to the customer. They don't even realize that happened. And we call it unbreakable broadband, because your broadband hasn't broken, and it doesn't break because of the reliability, the additional reliability provided by the mobile service. We have net zero targets, and I think, and I will come back to this a little bit later, efficient delivery of traffic is absolutely key for us. As an industry, we have to get this right. Dealing with things like live TV traffic, mass events, which puts an awful lot of pressure on everybody's networks, and is not very energy efficient, actually. We need to look at ways to do this. We're already innovating in things like multicast. Also, what is the best place and the best technology in the network to do content caching. And I know that this has very little to do with Wi-Fi, but I think it's that kind of full picture of why energy matters, and we need to look at the problem end to end and not in silos. And last but not least, and some of my colleagues will love this picture because we launched last week a service called Global Fabric. And this is available in about 80 countries, but I'm not sure I got that number right. But the reason why, again, this is really, really relevant to this discussion is because it is about bringing new technologies to introduce business model innovation. This is purely a network as a service. Where customers can actually tailor their service, they can boost their performance, they can decide how much they want to consume. It's effectively on demand, and it's available now. We're actively selling it, and we expect a huge success out of it. So again, another example of how innovation can help achieve our business goals. This is my last slide, Dean, so I'm almost there. But I would like to share some of the lessons that I believe as an industry have learned so far and key messages for the future. And I'm really hoping before we get to 6G, actually, we work together to achieve a lot of this. Industry fragmentation is not a good thing for our industry. I think we all get that. We are a volume industry, and if we go with silo innovation, we are very likely to achieve optimal industry economics. Plus, our customers get confused, okay? Because we're telling them two different things with two different people coming through their door on 2 different days of the week. We, as an industry, right? Not obviously as a company. So what we need, and this creates an opportunity for companies who are disruptive, who are not technology-driven, but they are solution-driven, to offer new solutions that bring together different technologies to serve the needs of the customers. It's a pure opportunity, but we need to grab it and go with it. The second one, and I think this has come up in previous conversations, is that these solutions need to work end-to-end. Examples like the energy savings, no single element in the network knows the end-to-end story. You need to bring it all together to have that holistic view and make the right decision at the right point in time for the service, for whatever they need. And here the support from the devices is key. And by the way, I'm not just talking about smartphones here, because 5G and 6G is a lot more than just smartphones. So I think we need to bear that in mind. So the answer to that has to be, it's got to be a win-win. We have to work with the rest of the ecosystem to prove to ourselves and the rest of the partners that there is a definite improvement in customer experience, in end-to-end energy consumption. Whatever the benefits are, need to be there for all parts of the ecosystem, not just for one side, otherwise this is unlikely to happen. And by the way, one point I wanted to make, this industry talks a lot about open networks and open network APIs, and we don't talk a lot about open device architectures. And I think we need an awful lot more openness on the device end, and that's a key message that I tend to repeat over and over again whenever I have an opportunity. Last thing, we need 2 things in our industry. We need to continuously become more efficient, and we need to grow. And even though they might sound incompatible, I really think through technology innovation we can achieve both. How can we? I've said it already. We need to deliver traffic in the most efficient way, and that includes energy consumption as well as many other KPIs. We need all the new features. Any new feature that we implement in our network needs to be business case driven and by software update. And I'm going back to some of the 6G principles that we have outlined in the NGMM paper, but I would like to emphasize that being business case driven is absolutely key. And the last thing, and I've presented examples like Global Fabric and others, business model innovation is the key to our growth. And we can achieve that through open architectures, both on the network and the device, remember, network APIs. And I think a lot of speakers this morning have been talking a lot about the use of APIs, the use of automation, and how we can leverage AI to make that happen. And of course, making sure that that works across multiple access networks, because we truly believe that that is our fuel for growth. And that was me. Thank you very much.
Thank you very much. Thank you very much, Maria. Just about sneak in a couple of questions. I'm going to take moderator's privilege and ask one. New business models, and also this idea of network of networks. Usually when I hear that, the assumption is that if you like, the umbrella or coordinating function is 3GPP and Wi-Fi or satellite as alternative access. How about flipping the model around? Yeah, in the 6G era, can you also envisage a world where, if you like, the cellular part it's not the leading actor, it's part of the supporting cast. Do we need to change APIs or have naked radio driven from a Wi-Fi controller? How would that work?
I agree. I don't believe our industry can afford the attitude of who is the main character in the movie. And for quite some time, there's been feelings even about that, right? I really think, and as you say, you know, the pure term non-3GPP access feels a little bit derogatory, right? But it isn't, to be honest. I think it's more, you know, we are responsible for this domain, and that kind of, you know, whatever is outside our domain, we cannot fully control. I think that I'm trying to justify a little bit the rationale for that. For the future, I totally agree. And I'm seeing signs of that evolving with federation APIs being defined. And what federation, in my mind, is all about is consuming capabilities from each other. And no longer the center of the world. Of course, I want to protect my customers and my customer service and make sure I serve them in the best way. But I can consume capabilities from other players in the ecosystem to make that happen. And whether that is federation between Wi-Fi and cellular, you know, we're seeing examples of that happening. And with all these tools that we're starting to develop, I really think that is the way to go.
Great, thank you. Time for one very, very quick question if someone is brief. Otherwise?
This one at the back?
One at the back, right.
Hey Maria, Mark Grayson, Cisco, so great presentation. I just want to dig into your point on network simplification, because I don't think we've got a good track record. You mentioned IMS. I think we went from like 3 Q931 messages to 23 SIP messages to establish a bearer. In roaming, we went from two map exchanges in 3G to now, I think, 12 REST calls in 5G for roaming. So my question to you is how do we ensure that 6G isn't just another layer of complexity on an already complex 5G?
How long do you have?
4 seconds.
It's a very complex question, and as an industry, we are very good at making things complex. What should I say? But to be honest, you would hope that we've learned from the past. The one thing I would say, because I probably have minus 4 seconds now, is that we need to rethink our tunneling structures. I think a lot of us have talked about EPDGs and, you know, non-3GPP accesses and so on, and they tend to build on each other and create tunnels over tunnels of complexity, which isn't helping anybody. So in some cases, actually, you might want to take a step back and take an alternative approach. I don't have the magic bullet, but I think a lot of that is needed. And you and I can talk about that more later.
Fantastic. Thank you very much,
Thank
and
you,
please give a warm thank you to Maria. Now I'd like to call the next speaker up, Stephen McCann, who's the secretary of the IEEE 802 group, and he's, I believe, talking about Wi-Fi 7, which is not what I've got written down here. So, Stephen, over to you.
Yeah, sure. Good morning, everyone. Can you hear me okay? Right, cool. Okay, so the first thing I have to say is this is a welcome back for me to the WBA. Welcome, you know, good to see many familiar faces. I actually last presented at the WBA in June 2011, if people can remember that long ago. And Tiago's looking at me at the front here because in 2011 I was working for BlackBerry. BlackBerry was probably nearly at the peak of its mobile phone success, and I remember Tiago and other WBA colleagues desperately trying to track me down to see if they could borrow handsets for various tests and things. So I'm sorry it didn't work out, but we've all moved on. And I no longer work for BlackBerry. And for this presentation, I'm actually representing the IEEE, but as it says at the bottom there, I need to make it clear that everything I'm going to say is my individual opinion and does not represent IEEE in any way. It's just something they want me to say. All right, so this is a very tech-laden presentation. I'm not going to go through it all. I think a lot of the things that Maria said are excellent. I've always believed in Wi-Fi to cellular integration and working, and the fact that they are really two solutions for the same market. And I may pick up on that as I go through. So I'm sure that you're all familiar that from a standards point of view, 802.11 is in that strange black circle in the middle there. And it sits in there with Ethernet, basically Bluetooth, Zigbee, the sort of slightly neglected WiMAX, and various other bits and pieces as well. But I'm not going to go through all those for now. So I just want to give an update for what's going on in .11, and I will come back to the question about Wi-Fi 7 in a minute. And what I'm going to probably concentrate on is the projects and the stuff that's hot off the press. You guys have come here to this conference to find out what's the new stuff, what do I need to talk about, what do I need to go home with, what's actually happening in the industry. So that's what I'm going to concentrate on. So just at the sort of beginning of this year, we had BB and BC, Light Communications and Enhanced Broadcast Service. Those projects are finished. I'm not going to talk about those. BD was basically next generation vehicle to anything, V2X, again finished last year. So let's move on to what we're doing now. At the moment, we are working on Wi-Fi 7, otherwise known as 11BE, and I'm sure that you're all very familiar with this one. We're also looking at BF, which is wireless LAN sensing, and that was mentioned also in some of the earlier presentations. We have two projects, BH and BI, which are sort of related to randomized MAC addresses, enhanced data privacy, and basically enhancing privacy for client devices. Those are sort of small projects, and they're very interesting and ongoing at the moment. BK is basically about extending Wi-Fi location and ranging using a 320 megahertz bandwidth. So basically, it's aligning some of the previous work with Wi-Fi location to basically match some of the bandwidths that are being used in BE. And then the one at the bottom hopefully is new for you guys. We have ultra-high reliability. This has now been approved as 11BN. It will meet for the first time in a few weeks during November. And this also has the name of Wi-Fi 8. So the important point here is that the technical work on Wi-Fi 8 will start with an 802.11 in the November timeframe. All right, so I'm just going to jump back a little bit in time now. I just want to recap for Wi-Fi 4, which was 802.11n, Wi-Fi 5, 11AC, and then Wi-Fi 6, and also with the extension into the 6 gigahertz band, 11AX. And I need to remember to say all these 6s clearly so that people don't get confused between Wi-Fi 6, 6E, and also cellular 6 gigahertz. Sorry, cellular 6G, I mean. You see, even I get confused myself. Yeah. All right, so the point about this slide is I just want to show you where BE Wi-Fi 7 sits. At the moment, from a .11 standards point of view, we're hoping to finish and ratify the full 11BE amendment at the end of Q4 2024. As you can see, it's basically an upgrade from 11AX. I think the most significant difference from a technological point of view is the multi-link operation. And again, I have a separate slide on that I'll come to. We're trying to use the 320 megahertz wider channel. The modulation's increased up to 4096, although to some extent that's just natural evolution of what's been going on in the industry anyway. And we hope to have throughput speeds of 30 gigabits per second, 40 gigabits per second, that sort of region, obviously for very, very short distances with a fantastic signal-to-noise ratio and probably a lot of wind behind you as well. All right, I'm not going to go through all this. It's just showing you the features of some of the most recent Wi-Fi amendments. But I think the point is that there are billions of devices which have been deployed in 2022 and ongoing. So if we basically project things forward from Wi-Fi 6, 6E, we can make an estimate that now, Q4 2023, we've got initial infrastructure products for Wi-Fi 7. Next quarter, Q1 2024, probably start to see some initial devices. There are prototypes out there, but I'm sort of talking about things that basically conform to the .11be draft standard with Wi-Fi 7. Again, based on previous experience, I think the market will probably build Q4 2024. Hopefully it's going to be pushed forward by the BE standard being ratified, as I mentioned earlier. And then commercial reality. Well, hopefully commercial reality will be 2025, but please don't ask me exactly what that means. All right, so just going back to BE, again, some of the sort of headline things there are throughput and the spectral efficiency has been improved. As I said at the beginning, we've introduced multi-link operation, where a device can simultaneously use 2 or more radio links and actually use those links simultaneously for data transmission. Another requirement or thought is the low latency. So again, multi-band, multi-channel aggregation, and we want to improve the classification of the streaming services. We also have introduced something called NSEP, which is the US National Security and Emergency Preparedness. In other words, it's preemption on the channel. And we're going to continue the sort of 6 gigahertz enhancements in various ways. And one of those is to try and use GCMP 256 for a higher performance cipher. All right, so on to BN that I mentioned earlier, also known as UHR, Ultra High Reliability. Again, I'll just reiterate, this is going to start probably in a few weeks' time at the next 802.11 meeting. So we don't exactly know what the technology is going to be within the task group, but the way we work in .11 is we have a study group that looks at the issues probably about a year before the task group starts. And within the study group, we have been looking at improving the reliability of Wi-Fi connectivity, again, reduce latency, increase manageability, looking at what happens with different SNR levels. We also have started to look at reducing device-level power consumption, and I think that's been mentioned in some earlier presentations as well. That's a very important issue we need to take seriously and look at. And then, of course, reduce packet loss rate, but again, all technologies want to do that. Now, hopefully, something you may not have heard of, and that is IMMW. It hasn't been assigned any letters yet. This is integrated millimeter wave. This is a new study group, again, meeting for the first time in November. The aim is to specify carrier frequency operation between 42 and 71 gigahertz that leverages MAC-PHY specs in the existing sub-7 gigahertz bands. So basically, what we're looking at here is, can we reuse Wi-Fi 5, 6, 7, and 8, which are all sub-7 gigahertz technologies, can we basically move them into the millimetric bands? You probably know that Wi-Fi does operate in the millimetric bands, but the Phi is completely different from those at the lower frequencies. And the objective of this study group is it possible to reuse basically the existing Wi-Fi radio technologies and move them up? It's not simply a matter of doing an up conversion. That would be easy. People would have done it already. It's a little bit more involved in that. We have to take into account, how do you do beamforming with something like Wi-Fi 6E? There's obviously different regulatory issues we have to look at. What do you do with OFDM, OFDMA, all these sort of things. So it's quite a complex problem. But yeah, I think this could be quite interesting. Okay, there's a couple of other sort of topic groups we're playing with at the moment. And I'm just going to summarize these very quickly. And again, we've touched on this in some earlier presentations. So the first one is AI/ML, in other words, artificial intelligence machine learning. And TIG just means topic interest group. So basically, this group is just looking at research in .11 to see are there any applications for AI in the radio technology. And the main areas that we're looking at are performance improvement selection for things like channel access, link adaptation, contention window sizes, channel usage, power control, and roaming between BSS. And by the way, BSS is a strange term that we basically use for the network. So the outcome of this would probably be to create some sort of API within the .11 standard, and that API would assist sort of upper layer AI models or AI engines to optimize the network, and also possibly optimize on the device client side as well. Another group that is doing future work is basically looking at ambient power. Primarily, this is looking at very low power use of existing Wi-Fi amendments. So the example here is AH, which is the sub 1 gigahertz Wi-Fi amendment. And the idea is, can we have very, very low power devices, and possibly those low power devices are actually powered by energy harvesting. So can we get the power right down? Can we increase the efficiency? There was also some discussion about actually using the Wi-Fi radio waveform itself. So for example, if you think of the waveform within the 2.4 band, can that actually be used to energize very, very small, simple devices? We're sort of going away from that at the moment. We're more sort of looking at very, very low power devices that have either tiny batteries or do energy harvesting through another means themselves. So still a little bit early days in this group. It's just something to watch, and let's see the direction it goes in. Okay, so I just want to talk about the 6 gigahertz band. It's felt within the community that there's great economic value through the development of the 6 gigahertz band for Wi-Fi 6E, Wi-Fi 7, and indeed Wi-Fi 8. We feel this is, a great opportunity for the use cases as shown in the picture. We have the virtual reality and the XR, gaming, all that sort of thing. It's very important for the very, very high data rates over a short distance that the technology will provide. And also we have to consider the AFC, basically the automatic frequency sort of selection mechanism through the infrastructure that will allow true 6 gigahertz operation, at least outdoors anyway. Oh yeah, some countries which are allegedly supporting this. All right, and I'm just coming towards the end. One thing I always like to talk about is the success of Wi-Fi in the second world or even the third world. And I'd just like to point out that in Africa, there's a fantastic initiative called Smart Africa. This is basically just trying to deploy communications to remote areas. And we have some examples here of certain projects in Niger, Rwanda, South Africa, Ghana, Nigeria. And if you have a little bit of time after you've been around this fantastic conference, then please go and have a look at the link that's on this slide that shows some of the community network projects within Africa. All right, thank you. Hopefully I was within my time.
Certainly were.
Excellent, good.
Great. Now I've been live tweeting your slides as we've gone through.
Oh, right,
But we've
fantastic.
actually caught up a couple of minutes, so we're able to take a question or two if you would like. While people are pondering that, I'll fire probably a horrible one that maybe Dorothy may have warned you about, which is,
Sure.
what are the chances of Wi-Fi 9 being a candidate technology for IMT 2030?
Ah, right,
Maybe
brilliant,
rather
brilliant.
than integrating Wi-Fi
Yeah,
and
sure.
6G,
So-
should 6G be Wi-Fi?
So I wasn't warned about this, but I did see one of your blogs where you mentioned this. And my attitude is, yes, I think it should be. I think when we get to Wi-Fi 9 or even Wi-Fi 10, then yeah, let's put it in as a candidate technology for 6G or 7G.
That sounds good, because it struck me that if most people don't know this, but DECT, the cordless technology, is actually a 5G technology. It's part,
Yeah,
so I'm
yeah,
like, if DECT
yeah.
Forum can do it, surely you guys can as
no,
well.
I used to work on DECT going back 15, 20 years ago. In fact, I actually started off in wireless ATM for military aircraft. So yeah, DECT is fine, ATM is fine. No, I think seriously, Wi-Fi 9 could be a candidate. And if I want to be a little bit controversial for a second, we could even have Wi-Fi 9 operating in licensed bands. No, no one's going to throw anything at me? Okay.
Yeah, no, good. I've been suggesting that for a while for local license.
And the other thing about my background in particular is in about 2008, 2010, I was working on the interworking sort of amendment for Wi-Fi, which is an attempt basically to do loose coupling between Wi-Fi and 3G at the time. So I've got some background in this. So yeah,
Interesting.
Excellent question.
Great.
Thank you.
Thank you. All right. We have 30 seconds. Now I've occupied time.
41.
41 seconds. Even better. No? All right. Well, in that case, we'll take back some time. But thank you very much, Stephen, indeed.
Yeah, no, thank you.
Really appreciate it.
Yeah,
Cheers.
Cheers. Thank you. Right.
Okay, and now I would like to welcome to the stage. I've actually got two names down here, so I don't quite know if they're both going to come up on stage at the same time or if it's just going to be like a double act and sequentially. I've got names of Chetan Habale and Jason Lauer, both from Curio. Certainly Chetan, if you want to come to the stage, and I guess Jason will either join you straight up front or secondly. And we're going to be covering more on the convergence topic, I believe. Excellent, thank you. And if you'd like to welcome them. There you go.
Well, good morning, good afternoon. Thank you for having us. I'd like to introduce myself, Jason Lauer. I'm Vice President of Engineering Operations at Curio. My colleague here in just a second, Chetan Habale, Vice President of Products and Network Technology. We're going to be talking to you a bit about what Curio is doing to bring convergence to the market today. So you may know of our parent company, Cable Labs, a not-for-profit membership-based company of 66 network operators internationally. We are a subsidiary of the company focused on bringing products and services to the same industry. We are also joined by another sister company, SCTE, who is focused on standards and training. Together, the combined three companies are working with the broadband industry, academia, government agencies, and software development organizations to bring about new technologies to the market. So a couple facts that you may not know about the influence that Cable Labs has had in the market, specifically around the converging of these technologies. There's over 500 million individuals today, every day, that are using devices that have been influenced in one way or another by the technologies brought about through Cable Labs. Additionally, there's 550 million devices that have actually been tested and certified to Cable Labs specifications and through the testing that my group does in particular. There's a total of $460 billion that have been influenced by the work of Cable Labs, those suppliers and the operators at large. And I'm bringing your attention to the middle metric I'm going to talk about next, and that is the innovation that's going on at Cable Labs today. This number is a bit outdated. There's actually 776 patents that have been awarded by the U.S. Patent Office to Cable Labs in total. And last year, we were actually the largest single entity with 60 patents being awarded in 2022. So really, we're known for DOCSIS in our past, but it's a much larger convergence story, even in the innovation that we're bringing about. As you can see here, over the last 3 years, over half of the patents that have been awarded to Cable Labs have been actually focused in the wireless area. This is both a combination of Wi-Fi, CBRS, and 4G, 5G technologies. But certainly, in addition to the other areas, you can see that it is really a holistic view of the influence and innovation and ideation that's coming out from the Cable Labs company. I got cut off here at the top a bit, so I'll speak a bit about what my group does at Curio. So we're the testing services side of the company. We are focused on passive optical network testing. We're engaged right now in our first 25 gig interoperability project for a large operator in the US. I will give a note out to my peers too. We are starting at Cable Labs 2 working groups just tomorrow actually, focused on some standards work that Cable Labs is doing, both focused on provisioning and operational network maintenance. If anyone's interested, have colleagues interested in any of that, please get in contact with me and I'll help you get connected to that team as those begin their work there through Cable Labs. We just heard from Stephen a bit about the timeline for Wi-Fi 7. We've been preparing for this in our own activities, in our own lab, and looking forward to bringing those services to bear. But we're very active in Wi-Fi 6 and 6 gigahertz testing at Curio, both in our labs as well as a test house, an empirical lab that we have in Colorado. I'll talk a bit in a moment about the Open RAN testing we've been doing in particular over the last 2 years. A lot of research being done last 6-7 years at Cable Labs, something Curio got very involved with on a government project with the U.S. Department of Commerce just last year. We also heard a bit from Howard Watson yesterday about the struggles challenges, I should say, that operators are having with security. That is also a service that Curio provides for a CPE device security testing, something that we do for a number of large operators, and then of course you all know us for DOCSIS. So as the world's only DOCSIS certification test house for DOCSIS, we've been doing that for over 25 years. We also operate certification programs for large operators like Comcast and Charter in the US, where we're testing not only DOCSIS, but Wi-Fi and security of their devices. We've been a long-standing ABL for the Wireless Broadband Alliance, as well as the OnGo Alliance. And then on the 5G side, Open RAN side, we became an open test and integration center through the O-RAN Alliance just over a year ago. This was while we were in our first year of a 2-year 5G challenge through NTIA. This is the National Telecommunications and Information Administration, as a government agency in the US, where they were really focused on bringing about new innovation, combining unknown companies who not previously worked together to develop RU, DU, CU layers of Open RAN, and brought them into our lab in partnership with us on individual test plans that we wrote over the 2-year time span. We just celebrated the contestant winners last month, and looking forward to kind of carrying on that capacity to help the market bring more Open RAN solutions to the market. So at Curio, we really sit at this converged space, this intersection of the industry between service operators, the suppliers, hardware and software that bring those solutions to bear, as well as consumer electronics vendors who are really trying to show and prove quality of service of their products before launch because of the access that we have to operators internationally and the capabilities we have in our lab to be able to help them develop and insert quality into their products early on. But there is a gap that we feel every day between the early innovation work that Cable Labs does and the charter for Curio to bring those products and services to market. I'm going to introduce you again to my partner, Chetan Habale, who's going to talk to you about one of the examples that we're doing at Curio to bring that about.
Thanks, Jason. So, you know, like Jason mentioned, with over 700 patents, that's Cable Labs' job to come up with the research. And we are the rubber meets the road division. So we try to look at that and find out, you know, which of these has a potential for commercial applications, which of these can potentially solve a real-life problem. And so a lot of our problems, really, one of the areas we centered around was convergence. And one of the things you won't find us talk about here is things like ATSSS or EPDG or PDG. I know, Derek, you're laughing because we've been talking about it for 10 years in different conferences. But what you'll find here is we're really taking, you know, what's the problem that the user needs to solve and work backwards from that, right? And really, the user doesn't care about all those standards. This is the problem that we as an industry are presenting to the users. When we open up our phones, depending on how long you've been around, you'll see, you know, we've all been introduced to all of these terms in some fashion or the other. And really, as a user, I don't care about 2.5G or 3G or 4G or even 5G. I care about great service. So really, I want good Gs, right? And if you work backwards from that, we looked at which problems can be solved today and can be solved now. And that led us to really two problems. One is the problem inside the home, and the problem is when you're out and about. So the problem inside the home is what we solve with our hotspot, which is basically saying, if you've got a problem where you've got a WAN link that is down, we all carry 4G devices and now 5G devices in our pockets, but they all sit unused. And except for those of us who are really good at technology, we don't really use those phones as backup connections or an alternate path to the internet. And so our hotspot is really about being very smart, working with the home router, and switching those connections seamlessly between the home router and the internet using 5G as a backup without the user intervention and without these devices getting affected in any way. So that's inside the home. And the framework for doing that really is to look at the technologies that are inside, look at the use of AI and ML on the back end, looking at all sorts of algorithms and heuristics to make that switch seamless. And most importantly, we recognize that none of us live in an isolated domain. So how do we bring APIs and make those APIs available to operators so that you can interlink that with the operators' OSS and BSS systems? So that's sort of our framework for how we think about convergence in the home. And then when you're out and about, as most of us know, and many of us have lived through this, thankfully the industry's moved past this question of, you know, is 5G better than Wi-Fi or Wi-Fi better than 5G? I think that argument is long settled and at least, you know, doesn't come up as much as it used to in the past. So Arc Mobile is another kind of thing where we look at both of these technologies. And while your cell phone does look at things like wireless range and strength and switch between them, often it doesn't really understand quality of experience behind that signal. And so Arc Mobile is a technology that looks at the complete end-to-end picture and gives operators a choice on trying to influence that connection and make that switch in milliseconds so that your Zoom applications or your video applications continue to perform even as you transition between technology domains. A common use case that many operators have shared with us is you're on a Zoom call, you're at work, you get in the car, you drive out to the garage, and your Zoom goes out for, you know, depending on your network, anywhere from 10 to 40 seconds. I see quite a few heads nodding there. So, right, common problem that we all face. And so Arc Mobile really brings that down to about 90% of reduction in time. So as much as 5 seconds, and then the application's buffering takes over, and you have an almost seamless switch between the technologies. Another common use case is an MVNO use case. If you're an MVNO, you're paying for cellular minutes. As a user, I go out of the home, I turn off my Wi-Fi because I'm forcing my phone to go onto the cellular network. But when I come back in, I don't turn my Wi-Fi on manually. And so Arc Mobile can make intelligent decisions to turn that on depending on geofencing, saving the MVNO operators minutes and potentially, a little bit smaller bill of what they pay their MNO for those MVNO minutes. So 2 simple applications, really simple use cases, but takes a lot of work behind the scenes to make that happen in the order of milliseconds. And so this is why we call this presentation, making convergence happen now, because while we're looking at lots of futuristic use cases, we're looking at what technologies do we have in Cable Labs that we can bring to the real world and make a difference to people today. And so both of these technologies are in trials, and hopefully we'll be able to make some public announcements either by the end of the year or sometime in early next year. And lastly, obviously, like a lot of people, we're looking at AI and ML. There's been clearly a lot of AI talk. Of course, computationally, there's still a lot of work to be done on the AI front. These aren't necessarily computationally efficient today, but we're starting to look at those in the labs to see how can we bring those kind of algorithms to the market in a couple of years or maybe in a couple of months, piggybacking on the innovation that's already happening on the computation front. So that's pretty much what we do. If you're interested in this topic, you want to integrate, you want to talk about solutions, a little bit of plug for where we are. We're in the exhibit D9. Please come and talk to us. We'd love to chat with you and understand what you're doing. Thank you. Thank you. I see a question.
I can see there's a question near the back already. So, Jason, if you'd like to come back to the stage as well. I'll get out of the way. I'll stand over there. Hang on a second. If I can ask your name and company, please. Is a microphone working? Yeah.
Simon Belmont, BT. That last use case, does that require any facilities in the network itself, or is it totally UE based?
Oh, you mean the Arc Mobile? Yeah. No, so there are 2 things. Today, that it does require technology at the other end, a server at the other end of the site. And that's how we are able to make those inter-radio access technology changeovers. We're also noodling on an early idea of saying, and this is non-standard, to see if something like the RIC and the Wi-Fi controller can also work together, and if that can help in some kind of coordinated network fashion to make that UE switch intelligently between networks.
Okay. Any other questions?
Just on that last point, sorry, just on the last point that you asked, one of the challenges we're looking at is how do we keep battery usage efficient? And we've made some strides in that area as well, which we'd be happy to talk to you offline.
Thank you. I think there's a next question.
Yeah, thank you. Thank you very much for this very interesting talk. I would like to ask you your opinion on the network functionalities, because, okay, about the radio part, clearly Wi-Fi is really having a very high quality of service compared to the discussion we have, for example, for the future 6G, even 5G. So what is your opinion about the other functionalities like the slicing, the automatic configuration? If you take, for example, Wi-Fi 7 or 8 for industry, 4.0, how can you build the whole like end-to-end, network solution when you look at what is done in 3GPP? What is the place of this zero touch, NFV, SDN? Without talking about the radio part. Thank you.
Thank you. There's a lot of questions in there. So let me see. Let me play it back. Let me see if I understand the gist. I guess the question you have is how do we see the future? How do we see all of these different technologies playing end-to-end, especially in the context of 3GPP and the Wi-Fi standards. Okay, so I'll take a crack and invite the audience or others to join in as well. I think so. This is, in a sense, a little bit of a personal opinion, but also curious opinion that we should stop thinking about these technologies in isolation. For example, if you look at 3GPP standards in the past, they've been looking at it from a very 3GPP perspective to say, how do I deal with it when these connections come in from the outside through my EPDG? You have all sorts of mechanisms on how to do it. Rather, maybe these things should be looked at it from the customer end to say how can a 3GPP network work with a non-3GPP network at a network level, not just at the radio technology level, because that's just the one leap in the whole equation. So that's why I alluded to the fact that maybe could the RIC in the Open RAN and architecture be extended such that maybe it understands non-3GPP technologies. And not just the RIC needn't be a master. Could the RIC coordinate with some other entity that isn't defined in 3GPP today? So my vision for 6G, or Kyrios' vision for 6G, or 7G, or whatever Gs we come after this, is that we stop thinking about it more as 3GPP or IEEE and start to think about like holistic network use cases. And I'll leave it at that because there are probably a ton of solutions that can be designed with that philosophy in mind.
Thank you. A quick one from me. On the Wi-Fi side, does the traffic break out locally or does it go back to the operator core?
In the case of
when you're bonding it together, does the Wi-Fi traffic, does it break out locally on the Wi-Fi in your house or wherever?
Sure.
Or does it go all the way back to the core network?
So the answer is both, depending on the operator's need. The idea is not that you don't necessarily want to mandatorily push everything back to the core. So really you want to take the most optimal path to the internet. But to the extent that you need seamless connectivity today, you might need to have an IP anchor somewhere in that common IP anchor in the network. But if you leave seamless fast switchover, then it really, your flexibility and options open up as well, and you can filter it by devices or by application.
Okay, that's good. I won't ask about VPNs, that's another one. I think there's one last question. Is that Maria? I can't see. Yeah, it is. I've got the light in my eyes. Maria, if we can keep it brief because we're running out of time, please.
Very brief. I think you've mentioned device support, and a number of us have mentioned device support today. Are you doing anything in that space, or do you have any great ideas to share with this room as to how we might bring them on board with this?
Is there anyone from Apple or Google here? Okay, so if that's really the two big elephants in the room, right? And clearly, I think what I've heard from a lot of the people here in the industry is we really should be talking to them collectively. We think there are a number of great things that we could do working in collaboration with them if they could open up more API access and give us more granular information. Now, we do recognize that they've got some good reasons not to do that because there's business reasons and there's probably some good technical reasons. So I think to the extent that if we could all come together and figure out each other's stances and understand what the device is doing, maybe it'd be good for them to hear collectively from this industry how they could meet the operator's need and deliver a better end-to-end subscriber experience. So that's what I would say.
Great. All right. Well, thank you all very much. Thank you for the questions as well. And Chet and Jason, thank you. And I'll ask the audience to show their appreciation as well. Thank you.
Thank you.
Right. Okay. So now we come on to the panel on 6 gigahertz. And I'd like to ask my panelists to come up. Actually, we now have a magical 5th chair, so I can actually run the panel from the sort of fireside position rather than lectern. So I will take a seat here, if you'd like to join me. So 6 gigahertz, you've already heard about today quite a lot in the context of Wi-Fi 7, potentially Wi-Fi 8, but it's worth saying that there's a bunch of issues related to how that spectrum gets regulated that are still ongoing. And so we know that there's 1,200 megahertz of this band between about 5.9 and 7.1 gigahertz. And what's happened in different parts of the world is some countries like the US have allocated, and I'm probably getting the names wrong here. We'll come on to the difference between allocated, identified, and a few other terms here. All 1200 megahertz for unlicensed use, which essentially means Wi-Fi and similar things. Places in Europe have taken the lower 500 meg of that band, and there's now ongoing debate about the upper parts of the band. Other countries like China would like to see that band used for 5G and future 6G. And we have, in about 3 weeks' time, the start of the 4-yearly World Radio Congress run by the ITU taking place in Dubai. And that forms part of the regulatory process about what to think about the band. And I'm going to ask the panel to sort of talk about their companies, who they are, their roles, the role of 6 gigahertz. And also, we'll almost certainly refer to the regulatory side of things. And I'm aware that we've got a mix of people in the room. There will be some regulatory terminology which we need to be quite careful about, and things like no change position and a few things like that. I'll ask panelists hopefully to explain that to an audience which is of mixed background. If not, as far as I can understand it, and I wouldn't profess to be a detailed expert on this, I'll try and interpret things as we go along. But now, I'd like to start with the panel, and I think I'll start at the other end of the panel, actually. I'll start with Andy, and then work my way back. So Andy Gans, if you'd like to introduce yourself, what you do, and just general thoughts on 6 gig at a couple of minutes.
Okay. I'm Andy Gans. I just recently joined Cisco from Ofcom UK. So I was in the middle of all these discussions from a regulator's point of view on the 6 gigahertz band. I was kind of the deputy head of the UK delegation at a lot of the meetings that were discussing these issues. So I was right in the middle of that conversation. And I suppose from my perspective, it shouldn't be a question of Wi-Fi versus 5G technologies. It should be what's best for industry, what's best for the consumer going forward. And I think that's what we need to get to. And a lot of the stuff that we see here today looks at it from a different perspective. It's not a frequency allocating frequency perspective. It's how do you get that connectivity between outdoor, indoor, seamless. And that's maybe where people need to concentrate the effort more on fighting about frequency ranges, because frequency ranges will be regurgitated throughout time. Some will never be regurgitated, maybe some of the military stuff. But there will be frequency ranges out there in the future, because it's a very dynamic market. It does take years to go through the WRC process. It's very slow, but it's not the whole part of the process. It's one part of the process. That's kind of, it's an international treaty that they do, which is part of, part of the UN, and it's basically, it's protecting your borders. That's what it's about. And it's about harmonization as well, on the other side. So if you harmonize frequency ranges and say they all have a primary allocation across the world, or across a region of the world, then that means that you're recognizing that that system, if any new system comes in, has a primary status. Which means a new system comes in and it has to share with that system. So there's already a primary mobile allocation in the 6 gigahertz range. So what the actual discussion about is about identification, which is identifying to a particular technology. Now, in a lot of countries, it doesn't really matter if it's identified or not, because the primary mobile's there and they have that choice of saying it's either Wi-Fi or 3G, 4G technologies, or IMT technologies, which Wi-Fi isn't part of.
Yeah.
So the important thing, I think, of the identification is that some countries basically take what's in the radio legs and put it in their national regulations, literally, which means no other technology can go in that band. And I would say it's mainly countries that are not the westernized countries, let's say. So it's not the big GDP markets, mainly. It's some of the smaller ones. So that's why there's such a big battle going on at the ITU. There'll still be a battle for hearts and minds afterwards on a national or regional basis. So that's where we are at the moment on the ITU side. From my perspective on the consumer side, Wi-Fi is there today. It's in Apple handsets, it's in the Google handsets, it's in Samsung handsets. So basically you're turning off that capability in Europe for that extra spectrum. And I know as a regulator, a European regulator, that basically you're not going to get 5G into European markets for at least 5 years, because they can't share with the fixed links. And the fixed links are there, they're in situ, and there have to be legal processes to go through. I know in the UK, probably 2 years to do a consultation, and then another 5 years to give them warning that they're getting kicked out of the band. So you're looking at 2030. I think even France have said 2030. So there's the kind of two arguments you've got. Do you want to monetize today, or do you want to wait 5 to 7 years to maybe monetize?
Thank you. Thanks very much. And just a bit of context there. First off, this term IMT, if you're not familiar with it, that's the ITU terminology for essentially mobile communications. It stands for International Mobile Telecommunications, all the way back to sort of 2G, 3G, 4G. And you'll sometimes hear it called, you know, IMT 2000, IMT 2020. 6G is going to be IMT 2030. So that's for that. And the other thing is that this 6 gigahertz band is not just about, or is it Wi-Fi, is it cellular? There's a bunch of other stuff there as well. So there's some satellite uplink, there's fixed microwave links for things like utility grids, there's some people using it for scientific observation of oceans, for example, as well. So it's not just this sort of binary choice. Really, there's some other incumbents in the band as well. So now I'd like to move on. Mark Henry, who looks after Spectrum at BT.
Good afternoon, everyone. Yeah, so I'm Director of Network Strategy and Spectrum at BT. It's probably worth mentioning that we operate the largest public and private Wi-Fi network in the UK, and Wi-Fi is really important to us. I'm really pleased to see in Stephen's presentation a really strong roadmap for Wi-Fi. That being said, you know, our position on upper 6 gigahertz is that it should be made available to mobile. In the UK, Ofcom are consulting on shared schemes, but without having defined any of them. But if you look at the studies in CBT, ECC, PT1, hopefully I got that right, most of them say that the compromises in sharing are very problematic. So it's worth studying, we should look at it, but you know, my position with Ofcom is we need a really strong roadmap for spectrum for mobile in the UK, and there isn't one absent upper 6 gigahertz. And probably a good bit of evidence for this is basically my team does the forecasting for the fixed and mobile network. Mobile traffic's growing faster than fixed traffic. So the bottleneck is coming to mobile.
Okay, I'm going to push back a little bit on that. I probably will anyway.
I
thought you might. First off, of that growth in mobile traffic, how much of the growth is accounted by fixed wireless access and also for indoor use, rather than macro outdoor use?
Let's just say 80% of the mobile use comes from indoors.
Right.
And that will continue to grow, but we will continue to serve it from mobile.
Because certainly the data I've seen from Ericsson suggests that a lot of the incremental traffic, certainly in Europe on mobile, between now and, say, 2030, actually a lot of the growth is coming from people using fixed wireless access, because 5G fixed wireless access normally has about 20x the data traffic of a mobile user, probably on a smartphone.
Yeah, that's not the case in our network.
Okay, right.
BT's building fiber across the whole country. We're at 11 million premises already. A big believer in Wi-Fi and fiber for access, and it's much more energy efficient to carry traffic in Wi-Fi and fiber. I agree with that. We will still continue to serve traffic indoors because no one's going to put Wi-Fi in car parks. No one's going to put Wi-Fi in many, many environments that carry traffic from mobile network.
We'll come back to that in a minute. So I realise I'm being a little bit unfair on you, but I'll be pushing back on some of the other views as well.
I had some training on this last week with the Ofcom panel. So.
I couldn't make that call, unfortunately. Next up, Detlef Führer from HPE Aruba. Go ahead.
Thank you. Thank you, Dean. Yes, so my name is Detlef Führer. I'm with HPE Aruba Networking. I'm in charge of the regulatory matters and spectrum management, etc., for HPE Aruba in EMEA. Okay, just to set things straight, I mean, we are a major provider of enterprise networking solutions, so we are not a Wi-Fi company. We have Wi-Fi and 5G, excuse me, We have both Wi-Fi and 5G IMT in our portfolio because I think we heard that earlier. What counts actually is what serves the customer needs best. It's not about Wi-Fi versus IMT, 5G. Of course, I mean, our interest is also to use the spectrum most efficiently that is available. And if we look at the 6 gigahertz band, for instance, in our view, it is much more, would be much more effective to open the entire 6 gigahertz band for Wi-Fi, as it's done in many other countries already, as we saw before, in all 3 ITUR regions actually. And for the 5G, and particularly our interest is in private 5G, there are other bands. If you look, for instance, at the 3.8 to 4.2 gigahertz band, we think that's a prime band, and there is activities in Europe going on, studies. There's a European Commission mandate to study the use of that band for low and medium power private networks. And for that band, the chances of harmonization for that purpose are very good, I would say. The prospects are very good. On the other hand, for Wi-Fi, harmonizing the entire 6 gigahertz band, this is a very realistic perspective, looking at how many countries already opened that band. For IMT in the upper 6 gigahertz band, on the contrary, there is no chance of harmonization, I would say. So that's why we are very much in favor of opening the upper 6 gigahertz band for Wi-Fi globally. And that's a very important band from the enterprise point of view. I mean, HP Aruba is very strong in high density deployments in stadiums, for instance, hospitals, other big public ventures. And for that, we definitely need the number of channels available in the entire 6 gigahertz band, and also the variety of channel widths from 20 to 160 and eventually 320 megahertz channels. And we are not a consumer company, so we're not catering to the consumer market. But obviously, if you look at all the plans and programs and initiatives on a political level that are going on, like in Europe, the digital decade and the objectives to cover each and every household with at least 1 gigabit per second fiber by 2030, well, it's obvious that you need to have some local connectivity solution which is adequate to actually bring gigabit speeds to the users. It doesn't make any sense, in my view, to put fiber to the doorstep and then it's there and people cannot use it. Thank you.
Thank you. Yeah, I mean, the last point you made, I agree. I mean, to some extent, almost for a politician, it's easy to go from talking about, so, oh, we need to have gigabit to the home to gigabit to the room. Might be a politics-friendly soundbite. So, yeah.
But Wi-Fi 6E does 9.6 gigabits per second.
Yeah. Yeah, I'm not debating that. I'm just saying, if there's any aspiring policymakers in the room, there's your next platform for the next election. Final speaker, our panelist, is Ted Kaplan from RKF Engineering. Ted.
Thank you. I'm the co-founder, CEO, and chief system engineer for the company. And since you probably don't know who we are, I'll give you a little background. We are a communication systems engineering company, design and architecture for both satellite and terrestrial systems. We do regulatory spectrum management, and we do advocacy and software engineering. And we, for the last 5 years, we've been working for the Wireless Coalition. The Wireless Coalition is made up of the big tech companies, Cisco, Broadcom, HP, Apple, Google, everyone out there pretty much, right? So we help them notably, I think we're instrumental in getting the 1.2 gigahertz of spectrum allocated to Wi-Fi in the FCC. We did the technical studies, and those reports were quoted 31 times in the rulemaking in the US, and then we've been committed to working with the Wireless Coalition to get global harmonization of the bands. And in addition to that, we wrote the OpenAFC code. OpenAFC, we were funded originally by Facebook and then by Broadcom and Cisco, and Broadcom and Cisco host that on their tip. And that's available to all people who want to run in AFC, the AFC will, of course, allow the standard power devices to enter into the market. And so they wanted to make sure that was expedient, so they wanted an open source code that everyone could use. So that's where that came from. In terms of the regulatory environment, I'd like to just point out how the paradigm has changed so much from when I was began in this industry. Originally, you weren't allowed to cause more than 10% or 25% increase in noise levels. That's harmful interference, and if you can't do that, you go to another band. And back in WARC 2000 with NGSO satellites going into the geo band, things started to change. They realized there's no spectrum left, and there's got to be a new paradigm to sharing. So it got sort of crazy in this last WARC period because they were looking at some bands, we're looking at extremely high power radar sharing with IMT. I mean, I don't understand that. But this band, the 6 gigahertz, there's some opportunity here, and there may need to be some changes in how we do sharing, in which case the AFC is one of those. The US decided to preempt the WARC 23 by allocating 1.2 gigahertz of spectrum for Wi-Fi. If you look at, there was a resolution out of WARC 19 to study the upper 6 gigahertz band, the upper 700 megahertz that we're talking about at the WARC for IMT, for licensed cellular. And the US decided we're going for, we're not sure, IMT sharing with fixed service microwave systems that are high power and high power macro cells doesn't make as much sense as indoor Wi-Fi, which, protected by penetration loss of the buildings. So it's a much better sharing regime. So we're going to preempt what they're doing at the WARC and make that decision. And they had a lot of people in Region 2 following suit. And like we said, Europe is, and other countries are decided just to do the lower 500 megahertz that's not being discussed at the WARC and wait to see what happens at the WARC. But from what I can tell from Europe, they're going to vote no change, not because they believe Wi-Fi is the better choice, but because they're not sure of that IMT, high-powered macro cells, can actually protect the incumbents. But then BT wants to even go further and say, can we share in the same frequency band Wi-Fi and IMT, which completely have different protocol structures and different power levels? Very interesting stuff going on.
So, thank you for that. So I want to sort of talk a little bit more about what to expect from the World Radio Congress and what it means. So first off, for the audience here, there are 3 global regions. Which are sort of, that you could argue maybe there should be more, maybe there should be individual countries. I'm not going to talk about the ITU internal processes here. Some countries have already released all 1200 megahertz, including the upper part of the band. Europe has this position of no change, but with some conditions of this, there may be some opportunities for IMT if they fulfill a set of criteria. What does actually any of this mean? Everyone's going to look at the results of this in mid-December. How do we know, oh, that's a good result, or not a good result? What should we be looking for? How do we interpret the outputs? I'll ask Andy. So.
Oh, thanks.
Yeah.
Well, there's so many outcomes that could come out of this. My interpretation is whatever comes out of it, as I said, there's still going to be a battle for hearts and minds afterwards. Whether there's an identification for IMT in Region 1. In the lower band, the top 100 megahertz.
Region 1 is?
Yeah, Region 1 is the biggest chunk of spectrum that's been
discussed. What is Region 1?
So Region 1 is basically EMEA, basically.
Right, Europe, Middle East, Africa.
And Russia as well. And a lot of the ex-Russian states. I think one of them is actually one of the RCC countries. So there's 4 regional organizations in Region 1. There's the African, the Middle East organization, CPT, and there's RCC, which is the Russian states. So they've all got different positions. So they'll spend 4 weeks negotiating that with the Region 2, which has only got one organization, and Region 3, which has only got one organization as well. They'll spend 4 weeks negotiating where they can find some common ground. And if they find common ground, they'll find a solution.
Okay.
But the outcome of those solutions could be any number of solutions. It could be a country footnote, which basically the countries who want to do IMT identify it individually. So you could have a footnote in the radio regs with 50 countries in it. You could have a Region 1 allocation a Region 1 identification for IMT. You could have no change, which means it's still mobile allocation, which means countries can still implement IMT if they want to, and still have all the protection rights of a primary allocation. The other regions, there's a primary mobile allocation already, so they're in the same situation. So the identification thing is really something that came from China and the Middle Eastern countries originally in the last WRC to try and, I suppose, halt the momentum of Wi-Fi in that band, really. That's what it's all about. It started off that way. And gradually over time, the operators weren't really interested at the start of the process, but have only really got more interested, I would say, probably in the last year or so.
I mean, everyone talks about sub-6 gigahertz. No, sorry, we meant sub-7.
Yeah. So things have changed over time. So people's positions change. It's quite fluid. There's a lot of politics involved, as you can imagine, in today's world. But ultimately, as I said, at the start of this process, from a company like Cisco's perspective, who again are like HP, we have both markets that we're interested in. You know, we're not interested in one technology, we're interested in both. We think we could monetize the upper 6 gigahertz band now, and that's because everything's available now. They could share with the systems that are in there already, with Wi-Fi indoor. And AFC may give a solution actually for some of the small cell stuff that maybe can do some of the capacity issues that the operators have got to address maybe in the next 5 years, because they're not going to get access to 6 gigahertz in the next 5 to 7 years.
I think that we're going to have more sharing, spectrum sharing, whether whatever happens, and certainly in the 6th year. Mark, coming to you. I mean, we know that in the UK, Ofcom is talking about this sort of hybrid sharing model. We know that Ofcom is talking about no change, and CPT seems to be. From your perspective, what does that mean in terms of what you'd like to see at World Radio Congress, and then what if you like, the roadmap? In an ideal scenario, how do we get to this? Assuming we can define what this hybrid sharing model is, when do you see it being switched off, and what are the things that we'd need to do from a regulatory point of view to get there?
Just to be clear, I'm not in favour of hybrid sharing because I don't see a way for it to work, which is why I say we should study it, but most of the proposals that we've seen so far don't work because it's the worst of both worlds, right? You just suffer interference on both systems. So, I mean, the roadmap would be identification for mobile, development in standards, then products become available in a timely fashion. That's what we want to see. We want harmonization for the rest of the world so that there's an ecosystem that supports that development. And then that gives us a roadmap for mobile, which we're lacking. And I saw a story yesterday on Light Reading where operators in the US are trying to open up the debate again about upper 6 gigahertz with the FCC. The FCC said absolutely not, but so that's our kind of view on development and roadmap for it.
So drill into that. So at the moment, CPT certainly has had this sort of no change, but then a bunch of other things. So are you sort of looking for the other bits of Region 1 and then also other regions to sort of collectively move towards mobile in Dubai? I'm still trying to sort of piece together, what would come out of this, and you'd be like, oh, that's a good result, and what the steps to get there might be.
Yeah, I think it's just identification for mobile as a secondary user of the band. Right. With the protections for the incumbents, but not, specifically, as I said to Ofcom, not assuming the worst case deployment scenario for protecting incumbent users. That deployment scenario, or the one that I've seen, suggests we'll deploy in every base station, and therefore the protection for incumbents should be X, and that's completely unrealistic.
Okay. Thank you. Detlef, your views of sort of what should we be looking for over the next couple of months, or?
Well, some of the things that.
I'm sorry. Ted, if you ask briefly and then come back to Detlef.
Yeah, let me get back to your question on the outcome of WRC. I mean, our view, no change would be the preferred outcome, of course, because as Andy already said, there is already a mobile allocation for that 6 gigahertz band, which would allow administrations to deploy whatever IMT or Wi-Fi. So there's no need actually for an IMT identification. And what we are being told all the time, well, it doesn't mean anything. If you have an IMT identification, it doesn't mean anything. So that's why we want it. That's what the IMT component says. But if it doesn't mean anything, why are you so eager to get this IMT identification? Again, what happens in reality after an IMT identification, and again, I have to echo what Andy said already, is then this band which is identified will effectively be blocked. I don't think there's ever been a case where a new technology or different technology than IMT has been introduced in a band that had been identified for IMT. So there's no need for IMT identification. And again, no change would give administrations the most flexibility to decide what to do with that band in the future. So that would be, let's say, our preferred outcome. And if you look at the positions of the different regional groups, CPT is for no change, and you mentioned there are a couple of conditions. If all of those are completely fulfilled, then CPT could accept, I would say, an IMT identification and not actively proposing or supporting it. But even other regions, the Arab states, ASMG, ATU, there was no unanimous decision for an IMT identification. There are always countries that are, let's say, against that. They are for no change. So we have to see what happens with WRC. So it's not all set in stone there. Yeah.
Just one thing I would say. I agree with what Mark said about that they need a roadmap. But the problem with this roadmap probably has been skewed more towards Wi-Fi, I would say, because you look at the countries that have opened up the band.
It's sort of facts on the
ground. I
ground.
can't see the US changing their decision on IMT because they've got over 100,000 fixed links in their country. It's kind of impossible for them to change that, probably, I would say, in the next 10 years. So IMT need a big enough market so that these guys don't have to subsidize handsets. If it's only a small market, they're going to have subsidize the handset manufacturers to put the band in there.
Yeah. Okay.
So it's not a viable alternative if they don't have a big enough market. So that's what, I think Mark's right in term, that's why it's at the WRC, is to try and harmonize enough markets.
Okay, so actually a quick question. I've got two vendors here that you've got exposure in Cisco in the US and in Europe, and so does HPE. Are you seeing actually any difference at the moment in your existing current deployments and tests between places that have got the whole band and places that have just got the lower 500? I mean, are you saying, do you have engineers here who go, I wish we'd had that, we could do what they're doing over there?
I think you could probably see that there's going to be a change. In the enterprise market, there's not going to be as much spectrum available. The other thing that we've got to deal with is some disruptive technologies coming into the band. Like Bluetooth's going to come into the band.
Okay.
They've already got a plan, and actually I was on a meeting today, before I came here on the phone, discussing how Bluetooth and kind of frequency hopping type technologies can come into the lower band in Europe. There's already an allocation that allows them to do that as part of the European regulations, but how are they going to do it in the least disruptive way? And then there's other things like peer-to-peer communications that come into for an enterprise company like we are, we've got deterministic networks, and that comes in, and that determinism can be blown out of the water. So you need enough spectrum there to be able to cope with all that.
Just one very brief thing. Stephen said earlier, Wi-Fi could operate in licensed, and you can. And if you want deterministic networks and spectrum certainty, go and use the 3.8 to 4.2, which is available on a lightly licensed basis in the UK. It will give you spectrum certainty in a localized area. Because even if you get the upper 6 gigahertz, Bluetooth may then go and operate in the upper 6 gigahertz, so you've still got the same problem.
But that's where you have to argue in the regulations at that point. You know, and AFC is something that Europe haven't even debated yet, to be honest. That's another important factor, I think, that for an outdoor kind of environment, which we also want to address. You know, and I think even the operators can use that as well.
Potentially, yeah. Ted, sorry, I cut you off before, so coming back to sort of, in terms of the process from here on, what are you expecting? What would be a win from your point of view?
Well, I think Wi-Fi is what I'm representing in harmonization, global harmonization, so obviously no change is the best thing. I think it is interesting that there is a proposal or the position of the APT in Region 3 that they want to license IMT only in the 100 megahertz at the top of the 6 gigahertz band. Everything else would be open. That's sort of a compromise, maybe. Wouldn't be unreasonable.
Okay, all right. So coming back to this, 320 megahertz channels, in theory, 160 and 320 sound great, but are there any real uses of it? I mean, that seems to be at the core of this, we want to have all 1200 unlicensed, is, well, we're going to do something clever with 160 and 320 megahertz channels. Do we know what they are? I'll find out one of you.
Well, I mean, for the enterprise side, I would say it's probably a bit too early to see what you could actually do with 320 megahertz wide channels and that. I mean, we see clearly benefits for having multiple 80 and 160 megahertz channels for dense deployments, as I said, for giving very high data rates. So like we have these famous high-profile deployments in the US. And there's also links back to your previous question. Do you see things that can be done in countries like the US that open the entire 1200 megahertz versus regions like Europe, which don't have them? So the University of Michigan, for instance, so I think now 17,000 Wi-Fi 6E access points are in operation there. So, and there, of course, you have these use cases in a classroom where you have dozens, 50 or more students on AR/VR, so you need a large number of high bandwidth channels. So that's a typical example for that. But again, 320 megahertz is probably a bit further away. So
I was going to say, but can that school in Michigan, is there going to be a school here in Paris that looks enviously, because their Wi-Fi engineer at the school here can't have the 50 people with AR headsets, whereas their counterpart in Michigan can?
Well, we get inquiries from customers asking when the full band will be available, and also whether high power or standard power will be available and when, because there's clearly a need in Europe, but also in other parts of Region 1 where they want to do that. Yes.
Okay. Actually, Mark, quick question: where would you imagine, in an ideal world, BT deploying 6 gigahertz? What would be the use cases?
Can I just make a comment on the use cases first?
Yeah.
I think it's not sufficient to say AR and gaming is required for 320 megahertz channels. There's no way that streamed immersive experience will be using a 1 gigabit flow across the network in the foreseeable future. But I get the point on capacity if you need 50 AR headsets in one room. But what Wi-Fi has is a huge amount of frequency reuse. 17,000 hotspots is a huge amount of frequency reuse. So you can put lots of capacity in a small area.
There certainly isn't lots of capacity in this room. I did a speed test before and I got 4 meg. Although to be fair, at another conference I was at last week, I was like closer to 200. So it's more the
I think
venue.
France is one of the countries that have probably the least amount of spectrum available for Wi-Fi in
or
Europe.
how it's deployed.
Yes, I think it's probably more, yeah.
We're gonna after this panel, we're going to have a look at what they've done. So then on how we would deploy upper 6 gigahertz, probably in the same footprint that we deploy 3 gigahertz in today, so very high capacity. These would be massive MIMO radios. We expect improvements in beamforming that will get us to equivalent coverage of 3 gigahertz within the deployment timeframe.
But coming back to what you said, we know most of the use is indoors, so surely even if you throw 100-way MIMO at it, isn't that just going to be heating up bricks and concrete mostly?
Capacity in the mobile network is a layer cake, and we're adding a layer that won't go deep in building and it won't capture all of the traffic, but it's offloading the top layer, and that leaves more resources for the lower layers. And we have a good distribution in our network across the bands. And to be honest, I would love more sub-1 gigahertz. Can I have some 600 megahertz Ofcom? Is another thing we're asking for. But that doesn't mean we don't need high capacity bands, which this is perfectly suitable for.
So I'm not quite sure what the, is it people walking down the street? Is it vehicles? What's...
It's everything, Dean. Let's say it's 80% indoors. Those are areas that aren't covered by Wi-Fi, or for whatever reason, the customer isn't using the Wi-Fi. Maybe it's a personal device and they can't connect it to the corporate LAN, which means if there was some sharing scheme, that user is then an interferer for the 6 gigahertz Wi-Fi indoors. So that's a problem for sharing. And then it's everything. It's indoor users, outdoor users, everything everyone uses a mobile device for.
But maybe if the indoor network was better at kind of taking the traffic away from the mobile networks, then you would have more spectrum outdoor.
Yeah.
Or more capacity, sorry.
One of the
your
challenges
outdoor
for indoor is, I speak to a lot of people who do small cells, who do DAS systems, all the rest of it. I asked a couple of DAS vendors last week, what would make your sales director happy in terms of number of systems sold per year? And they were like, to be honest, it's 1,000, let's say. But if I look at a country even like the UK or France, there's 20,000 hotels, there's 3,000 or 5,000 big retail sites, 500 million square foot of office space in the UK, all this sort of thing, which means if you're a medium-sized building and you say, can I have a dedicated indoor system, even if it was available at 6 gigahertz, it's like, oh, I'm number 3,482, and they say they'll get to me in the year 2037. Yeah, it's sort of, there's not enough people.
Most hotels have Wi-Fi already.
Wi-Fi they will, but it's not an indoor cellular for 6 gig.
Yeah, absolutely.
Okay.
But, most hotels have Wi-Fi today.
Oh, God, yeah.
We're not serving that traffic because people will connect to it already, unless they're in the lobby or making a phone call in the lift or whatever. But we're still seeing massive traffic growth. So it's all the other areas that, Wi-Fi is taking huge amounts of traffic already.
Fair enough. I'm going to throw it open to the floor. Are there questions here, or I think there's people online as well? Have a think about it. If you've got questions immediately, otherwise I'll carry on for a minute or so. I've got a bright light in my face, so I'm trying to struggle to see any hands. Not at the moment. Okay. All right then. Let's go back to the incumbents and say, look, it's not just Wi-Fi and IMT or even Bluetooth. There are all these fixed links and some satellite and the Earth observation. What do we do with them? My understanding is they don't particularly like having anyone else in the band, but they probably view Wi-Fi as less bad than high-power cellular.
Well, you say probably, do they?
Well, certainly satellite people do.
Well, according to the responses to the Ofcom consultation, I would say probably they do.
Ted, what do you
also, just they want future-proofing as well. They want to be able to develop their service, and it's worth remembering that needs to be protected as well.
Ted, what are you seeing and hearing?
Well, I mean, let's look at the incumbents and how AFC and the ecosystem's working out, I think. So, like you said, you have fixed service microwave stations, high-powered, 35-kilometer type links for public safety, for utilities, for cellular backhauling, a lot of it. And you have the fixed satellite service, which is receivers, it's uplink, so it's the receivers on the satellite that are getting interfered with. You have sections of the band that have mobile news gathering. You have passive sensors making measurements over the earth, over the ocean, and a small section over the earth of bandwidth. And then you have radio astronomy, and you have some NGSO global star Earth stations around. But having said that, the issue with IMT, if you want to do a global deployment, is that it has very high power. It's outdoor macro cells. And we did a study that was submitted recently to the European ECC, demonstrating that you really couldn't share high-powered macro cells even with indoor Wi-Fi, let alone with other fixed service systems. So, and also they have problems with the passive sensors over the oceans, the high power from the macro cells. They bleed into the radiometric measurements that they're making. So there are issues with that. In terms of the Wi-Fi, the thought is that the low power indoor units that are being sold massively right now, I think there's over 100 million access points that were sold, are not much of a problem for fixed service. It's certainly not a problem for the satellites. The total amount of power from all the Wi-Fi, even though there's tremendous amounts of them, is small. It's like a 0.1 dB increase in the noise. And so the low power, again, there's not a lot of worry about that. So then they came up with for higher power, they want these standard power devices. So these will have 18 dB, or approximately 63 times more power than the low power indoor units. And they can be used outdoor or for enterprise, for better coverage, for better quality service. And what we're seeing with the rules are showing, at least for the FCC, they're the only ones who have really put forth rules on this stuff at this point, is that they don't want them to share with the ENGs. So if you know anything about the 6 gigahertz band, Uni 5 is the 5 megahertz, then I got to go faster.
Yeah, we go
Uni 6, 7, 8. So the high-powered ones would only have the 700 megahertz in Uni 5 and Uni 7. They would be they could be indoor or outdoor. The outdoor ones are especially worrisome because they don't have the building penetration loss, so relative to the LPI, they're about 10,000 times more interference power. So the AFC, what it does is it will put a map together for every access point, telling them what powers they can use in any of the channels that are available to them. Constrain them so that they don't interfere with any of the fixed service stations. And then I just wanted to mention VLP quickly.
Okay, yeah.
Because the FCC has just on Thursday is going to allow VLPs in the band. They're very low power, on-body networks, AirTags, smartphones, smart watches, Google Glasses, all that. The restriction is that they have to have a power density very low, -5 dBm per megahertz, or they have to use geofencing when they get near an incumbent. There's a big push for the geofencing in wind forum. They're standing up a group, but it's unlikely, I think, that will get adopted. They'll probably just stick with the very low power.
Just one thing I add on the 320 megahertz. The idea is probably more for that type of system where they want to get on the channel, send data very quickly and get off the channel. And they want to provide it in very, very low latency. So
Right.
that's the whole...
So it's low power, wide channel.
320 megahertz argument. The argument from our side is frequency reuse. And having enough frequency to reuse to plan a good network and a good service.
So the use case is temporarily needing very high bandwidth in a location for AFC, so you make an application to use the spectrum.
No, I'm talking about the 320 megahertz is for the VLP type thing, where they need to provide quite low latency, and they need to provide a link between the handset
in a local area, like a body area network.
Peer-to-peer sort of thing.
And then the need that we have is to be able to provide a good enough network to carry the traffic, a bit like yourself. The other thing is, I think, from your perspective, you're only talking about being able to roll out maybe 1% of the geographical area in a country to provide that 6G or 5G network. Otherwise, the satellites would probably be interfered with. So there's kind of, that's the trade-off. And that's why regulators are looking at the hybrid model, which I've not really said anything about at the moment. It's probably not good for the enterprise case because we don't know when a mobile operator would come in. Maybe AFC could help some of that. Maybe some of the Wi-Fi 7 stuff that's, the adaptive links the different bands, and also being able to minimise the channel we use if we get interference. We could cut the channel down. So that's the type of thing that, you know, may be looked at, and I think that's what Ofcom and others will look at.
already rules in the UK. Anywhere we're not using spectrum for 3 years, anyone can go and use it. Right?
Yeah.
So there's already mechanisms.
Although there's only been 40 licenses because it's not particularly easy to get a shared access license, but local access license, sorry. Right, unfortunately, I've just had the sign that we're out of time, so I'm sure this will probably carry on over lunch and probably over the next 2 months.
Carry on over the next year or two.
Yeah, and beyond that as well. But I'd like you to show your appreciation for the panel session, and Mark, I appreciate that you're sort of coming in here. You're the sort of fox in the chicken coop here a bit, but I appreciate you. Good sport for doing that as well. Thank you all very much. Cheers.
Cheers. Thanks, guys.
Well done, Dean, as well.
Thank you.
You did very well too.
Oh, thank you very much. Right, and I think we have some lunch.
Okay. Okay, well, welcome back, everybody. We hope you all had a good lunch and are nicely refreshed for the next hour or so. So I'm Steve Namasurveyan. I'll be your session moderator for the next hour. I work for the Wireless Broadband Alliance, and I'm in charge of our industry alliances and our members program as well. Okay. So for this session, we have 3 speakers. We're going to be talking about the role of enterprise Wi-Fi and also smart transportation in cities. I'm going to get straight into things. I'm going to ask our first speaker to come to the stage. So we have Mital Parekh from CommScope Ruckus. He'll be coming up to talk about the role of AI in delivering the best enterprise Wi-Fi experience. So Mital, please to the stage.
Can you hear me okay? All right. Okay, so I have the most difficult job keeping you guys awake after this nice lunch. I'm going to try my best. I am Mital Parekh. I am responsible for everything marketing at Ruckus Networks within CommScope. And today we are going to talk about the role of AI in delivering the best end-user experience in your enterprise. So here's the thing. Entire morning you have been listening to speakers telling you all the good things about 6 gigahertz, all standards level stuff and what have you. My goal is by the end of this presentation, you will walk away with insights on how, what, why, and when of AI in enterprise networking. So you will know exactly what to do, how to benefit from it, right? This is not going to be a theoretical talk. So that's my promise to you. Okay, so let's start, if I can get the clicker doing. Okay, so look, this is not new to you or me. We are part of the same industry, that the new era of networking is upon us. Right? Modern networks are getting more complex. Previously, it was just Wi-Fi, or every access network was treated in its silo. You had Wi-Fi, you had switching, 5G came along, fancy IoT, door locks, smoke detectors, so on and so forth. Everybody had their own swim lane. Gone are those days. Now everything is melting into one. Okay. IT is getting leaner. If you are in the industry, if you are an enterprise, have you ever heard that your IT got more people? I don't think so, right? There's always, if IT is doing well, reduce some more, right? It's a cost center always. You know, once upon a time, IT was all about if it is working, if Wi-Fi is available, we are okay. Now everybody is on a notice. It's all SLA, service level agreement. Even IT is being asked to deliver. Everybody is accountable. What does it mean? Now, whoever is managing your Wi-Fi or switching or IoT or 5G, private 5G, they all have some numbers to meet. Okay? Service level disruptions are getting costlier. We used to let go if Zoom didn't work or some application went down. Now, I know I have personal knowledge of enterprises where they have cost of doing business if one application goes down or there is a latency introduced into an application. So everything is getting costlier. Do you know how much does it cost to maintain an help desk? One person on help desk, whether they are managing chat or help desk ticket via a computer, right? It is getting more and more expensive, right? We have numbers to prove that. And last but not the least, specialists are getting more and more costlier. As in, go and find a Wi-Fi. Okay, so I ran a poll at Mobile World Congress on how many of your IT people are RF engineers. So go to my Twitter and see what they replied. Few of them laughed at me. They do not have RF engineers as their, so they have subject matter experts, and they are super expensive. What does that mean? So now let's pause. We heard about 6 gigahertz all day long, all morning long, right? From 2.4 to 6, in 2.4, if we can generally say there were 3 non-overlapping channels. So you could do your channel plan with pencil and a paper. I invite you to do the same thing with 6 gigahertz. You will retire, your kids will retire, and you will still have interference in your network. Okay? I think you are getting to the point, we are getting to the point by now, that artificial intelligence is not a band-aid, it's not lip service, it's pretty much mandatory. So At the same time, if you see how AI is evolving, the costs are going down as more and more players, or rather big 3, big 4 players are adding more and more infrastructure. If I could give you numbers on this one, you are going to be surprised that AI is ready for mass adoption. It's not just a fancy buzzword to create those avatars or metaverse or so on and so forth. It is ripe, and the time is now for bringing it to enterprise networks. So these are 2 charts, one from OpenAI and one from ARK Investment. If you see this, look at this closely. On the left side, what you see is pre-AI era, and on the right side of this one is, since 2010, is post-AI era. If you see what this chart shows you is without going into technical details, is petaflops dash s per day. I can give you more detailed definition. It just means that AI is getting more pervasive because of the amount of traffic that's crossing those servers. On the right, what you are looking at is ChatGPT 3.5 type of training, how costly it was once upon a time, just 3.5 years ago, and how it is going down. So think about it. So I started by saying that new era of networking is upon us. AI is getting pervasive. It's getting cheaper and cheaper. This is the time when both these things are coming together. So if I can summarize for you, right, this is the time for AI-driven networking solutions. Now, it's not magic, and I'm going to tell you now a little bit of a, I would say, shameless plug as well in how we do this at Ruckus. Okay? So at Ruckus Networks, we adopted AI many, many years ago, even when it was not called AI. It was pretty advanced at the time. There was no mention of artificial intelligence, but when we started with our BeamFlex Plus, and I'm not going to go into the technical details of that, but that itself was smart in its days. And from that day onwards, we are bringing more and more of AI and ML algorithms. And we can go into, considering the time here, I wouldn't want to, but if you see how we are deploying graph AI, how we are deploying plain statistical analysis, I wouldn't call it AI and ML. And lastly, but the most important one on machine learning algorithms, right, it is now reflected in every product that we have. So let's talk about how AI has grown within what we are doing. So a couple of years, just 3.5 years ago, it was pretty nascent, right? We were doing very, very simple things. As we went, as you go from left to right, we are now bringing NLP, natural language processing. We are bringing graph AI into the core of managing our networks, right? And so the reason I give you this grounding is that when I show you the next slide, everything is going to come together. And what's happening now, going forward in 2023 and 24 onwards, we are talking about deploying artificial intelligence at not just central cloud layer, but bringing it all the way to the edge. As you know, we are one of the best ones in when it comes to Wi-Fi and switching to start with, and those are Wi-Fi APs are on the edge. Think about bringing AI into the edge. So it's now in a hybrid mode, working from edge all the way to the cloud and everything in between. So that's what we're going to talk about. So let's talk about network efficiency, right? I want you to take a pause and think about, if you are in the industry, how, when something goes wrong in your network, how do you, or who debugs it, or when a customer or end customer calls or an employee calls, my Wi-Fi is not working, right? Right from experiencing an incident, how do you find out what to work on? Is it because Mithil called 7 times and his iPad is not functioning, versus somebody who is managing an entire lab called just once, but she happens to be very polite? Who are you going to help first? So the whole thing I'm getting at is identifying incidents and prioritizing those, right? That's the first step in which, where we bring AI to service. And it's working right now with Ruckus AI technology. So pre-prioritization of incidents. Now I'm going to pause. This is worth absorbing for a moment, right? And ask, if you are evaluating vendors, it's like, things are going to go wrong in my network. How do you identify what should IT work on first, or what should specialists work on first, right? So assigning P1, P2, P3, P4, or priority 1 to whatever, I've heard all sorts of answers. Well, I believe AI is the best suited for technology for doing something like that. Once you have identified P1, P2, what have you, who is going to determine how to find that needle in the haystack? Ask this question of your IT. How do they do it, right? They are going to tell you about Excel spreadsheets, using grep functions, so on and so forth, just to identify what caused it. Now, what about converged networks? When multiple access networks come together, this task is getting exponentially difficult. I used to be an engineer once upon a time, so I can tell you that it is true. Let's let AI do this. If AI found that needle in the haystack, so it gave you root cause analysis, you probably would feel much better than depending on or relying on the best IT person you have in your team. Should he or she get hit by bus or take a vacation, how do you find root cause analysis, right? Last but not the least on that line of thought, how are you going to fix it, right? Experienced talent is expensive. I mentioned to you, subject matter experts. What about, or how about, letting AI give you the answer? Follow step 1, 2, 3, and that will be fixed. And then AI will ask you a question. Did that really fix your problem? You know why? Because when you say yes, it is going to build a model that is robust than what it was yesterday. So now you can rest assured, when you deploy AI, when AI is part of your network management, you can pretty much have your incident from becoming service affecting. Because I told you that it is getting increasingly expensive to take a downtime, okay? Talk about, let's switch gears, day 2 operation, okay? Once your network is all set up, you are very happy, you want to tweak it, or you want to try something new, you want to change it. Ask this question, how do your IT people do it? They'll say, oh, we'll try somewhere and see if it sticks. If it doesn't, remain awake, roll it back, so on and so forth. Have you thought about letting AI do that for you? So that's like tweak all your parameters all day long, let AI find out, fast forward, give you analysis of if you did this, this will happen. Or let AI do it in a small silo and give you an answer, and then give you a choice. Do you want me to roll this out, considering that these are your SLAs, and this is how your SLAs are going to be affected? Mostly positively. Can your IT do that right now? I bet if you ask them, they probably will give you basically, potentially, I think so, all the variations thereof. Let AI do that, right? How about this? Last but the most important one. Ask your IT how often they optimize their network. Really, this is worth asking. You probably will get the best laughter out of them. You know why? Because they say, if it is not broken, I'm not going to touch it. If that's the case, how are you ensuring that every single day you are getting maximum value out of your network? No, I'm not even joking. Ask this question. How do you, and how often do you tweak your network? Look, here's the thing. Again, a shameless plug. With Ruckus, we do this every night. So every night, your network is going to send you recommendations. So when IT comes along and they says, I have 5 recommendations, and they are laying it out there, pros and cons of every single SLAs that matter to me. So it will show you that I scanned your network, and these are the 5 opportunities, or 7, or 10, or 2, to improve your network, and your SLAs are going to be improved to this degree, or to this percentage. And then it's smart, so then we pause, right? We don't want to be driving that car for them. This is not about taking that IT job away. This is arming them with more things so that they can do better things downstream, right? So we are what we call semi-autonomous network. Basically, what that means is we provide recommendations and we pause. We let them accept it. Once they accept it, we keep a close eye on the entire network and match projected versus actual. Look, I'll tell you one thing. It's technology at the end of the day. Things will go wrong. There are times when AI is going to go wrong, and it does go wrong. We have seen that, right? And in a couple of weeks' time, we will ourselves roll back, right? It's like a very silent apology. We roll back those changes because it didn't work out the way it was planned. So we are very transparent in the role of AI, how and where it brings you goods, and when it cannot, we are going to very lovingly roll it back to what it was, so no loss to you. Now, one last thing is the whole day we have been talking about 6 gigahertz, right? And I alluded to the fact that there were 3 non-overlapping channels in 2.4. In 6, answer is it depends. How about let's put AI to work, identify, give the whole network, entire network, not just one pod or node or what have you, and give you the answer, the channel plan for your entire network. Let AI do that one. So everything I just mentioned up till now, each and everything from here is deployed at this time with Ruckus installations. And I'll share with you one use case, how we are bringing changes in their network and to what extent. So let's discuss one thing. I wanted to give you one single visual, is that this is how it goes down in a typical network. So what you see on the left side is an incident pops up. IT comes to work at 5 a.m. or 6 a.m. or 7 a.m. They see something. On the right side, what you see in number 2 is root cause analysis. This is exactly how we show them that this is why it is happening, RCA. And on the bottom here, we are going to show them how do you fix it, recommended remediation actions. Okay? So you can see everything in one single. All you do is accept this recommendation. This is how you deal with AI. This is how you incorporate AI into your day-to-day network operations, right? So this is not pie in the sky. You can do this today. That's important. That's the key takeaway here. So let's talk about AI from operational efficiency. So if IT ops, AI ops, ML ops, mumbo jumbo, all types of ops, if that's your gig, then AI happens to be in every single cog of this machinery, right? They call it observe, act, and engage. At each step of the way, if you are able to infuse AI, the whole machinery works like a charm, right? And we have seen this working. I can go touch upon each of these. I'm cognizant of our time together, but idea is very simple, is that AI is not just a lip service where you put a gloss and feel happy. Right from when you deploy your network to daily management, when you automate your management. This AI ops is all about how much of this can you automate. Now imagine bringing AI into this wheels of automation. You are now doing work of higher order. You are doing all those projects that you couldn't do ever because your time was spent fixing bugs or fixing those tickets. So one study from McKinsey, a little bit stale, but it still applies. 60+% of IT time goes into fixing those incident tickets or help desk tickets. If 60% of the time is going into fixing what is broken, how and when are they going to bring you to 2023? Then we all go and complain that my IT doesn't do anything or we have ancient systems. Well, time to bring AI. So let's talk about one thing. This is going to heat up, and that's why this deserves a slide of its own, and that is radio resource management. What I'm showing here is AI-driven cloud RRM. So I'm sure when you talk to other vendors or many vendors, almost everybody talks about artificial intelligence. Ask them how do they incorporate that into your channel plan. Because 6E got us started on, or Wi-Fi 6E, I know the confusion here. Wi-Fi 6E got us started on 6 gigahertz. Wi-Fi 7, now it has made it mainstream, and I am proud to tell you that just earlier this month, we launched Ruckus R770, our very first enterprise-grade Wi-Fi AP that is AI-driven end-to-end. And you can read our press release. Now, we have customers lined up. Now, if that's the case, right, this takes center stage. What you are looking at here is we are now able to take the entire 6 gigahertz spectrum, upper band, lower band, whatever you want to call it, and we optimize on channel width, and transmit power. I will tell you right now, if you saw the entire model, this is a 5 to 6 dimension chess that you are playing here. You can't do this with a piece of paper and a pen. You can't, right? You are going to see is you, with this AI-driven radio resource management, you will be able to eke out what we have observed, and I'll show you in the next slide, 10 to 18% more capacity out of your Wi-Fi technology. That itself should pay for the investment that you will put into bringing AI into your enterprise networks. Here's the proof. So this is about 18% boost in your Wi-Fi capacity on the heels of deploying AI. What this tells you is very simple. If you had done it by yourself, and fingers crossed, you probably got it right. You are the smartest, you got it right. And it's still, the difference is with AI, you're getting 18% more. Now that itself, again, would pay for your investment in AI technologies, right? So another word that you are going to hear again and again and again is what we call it digital twin. So IT in enterprises or service providers or managed service providers, they are very scared of doing anything with their network once they deploy it, right? Touch it? No, we are not. It's working, right? It's not even about optimization. They just don't want to touch it, right? So they are not, trying anything new first answer is no, de facto answer is no. So now a new paradigm has come up, that's what we call it digital twin. Let's create a model of your entire network, right? That is essentially a dummy. You are basically creating an E-model of simulating it, so to speak, on a computer and try out scenarios and then put it in your network. Maintaining those two swim lanes is not very easy. First thing. Second one is creating that entire model of your whole network, what we call digital twin, that is increasingly getting difficult as we talk about converged networks. So why don't we let AI do that? What you see here is on the left side, we had what we show is before network, and you say, I would like to make these changes. So AI is going to adjust everything that you asked for and show you before you touch your network. You don't have to do anything as far as it has scanned your network once. So this brings up a good point. Our AI engine is like a 24/7/365 CT scan of your network. It keeps an eye on your entire network at every given moment. It sucks up so many data points at great interval, rather shortest interval. Nope, I'm not going to give you those details, but it is sufficient to say that we can give you, at any given point, real view of your network. Let AI do what we call digital twin, right? And last but not the least, very, very important, we don't, our AI does not keep it hidden. We don't want to keep it a voodoo magic, what we call explainable AI, as in we will not only put AI to work, but we'll tell you what we are doing, how we are doing, and why we are doing. So we don't treat IT as dumb personnel. We want to empower them, right? You are going to hear a lot about explainable AI, and we have it at this point right now with Ruckus in deployed technologies. So Here are the examples of benefits that our customers are already reaping. On the right side, what you see is one of the managed service providers, Vector Technologies, Vector Tech, and these are the benefits they are reaping on the heels of our AI that they have put in place. And on the left side, there's a third-party industry analyst, Packet 6. They compared our AI technology against our competitors. And this is how we stacked for mean time to identification. That's the time it takes to find what's wrong with your system when an incident gets filed. So, and everything is now coming together on our AI-driven cloud platform, what we call it Ruckus One. So if anybody is interested, I'm floating around, ask me questions. As I mentioned, I did want to put a plug on this one, our R770 AI-driven Wi-Fi 7 AP. Want to learn more? Hit me up. I think my time's up, but I hope you enjoyed this.
Thank you. So congratulations on the launch of the R770. So I want to ask, we're going to see if there's any questions from the audience, but I want to start things off. I want to ask about the capabilities. So the technology is there for AI-driven network management. You showed a case study at the end. So how are we going to get IT departments to embrace it and use it?
So the simplest thing is to put it in perspective. People see IT has a built-in fear that, or rather all of us, I would say, so even from my job perspective, is AI going to take away my job, right? But its idea is to make me or IT smarter on the heels of AI. It's not about taking job of IT away. So if you ask a simple IT person, it's like, what's in your pipeline? And they say, if I get through all these fixing tickets or helping this or helping that, then I would like to go and do those 3 special projects, right? This just accelerates the timeline. And from line of business, or this is the run-of-the-mill IT people, right? If you talk to people who have IT dollars to spend, for them it is very, very simple. Is they look at various different KPIs like payback period or ROI, so on and so forth, because they are responsible for delivering SLAs. They are accountable to get your organization to certain IT sophistication level. And right now everybody is struggling. So AI comes to help there.
Okay. Any questions? So, Najati?
Yeah, thank you very much. It is a great presentation.
Thanks.
We appreciate all the details that you provided. One thing that I'd like to bring to the attention of the folks over here, that within WBA, we are starting the work item on end-to-end AI ML for end-to-end Wi-Fi deployments and Wi-Fi cases. This work is going to be basically collaborative work. All the interested parties, please come and join us so that we look at the business opportunities, market needs and challenges, and as well as the gap items that we need to address by working on that, because there are parts over there currently, folks are doing that within their own space, but there is also standard-related work that we need to address in terms of how do you really exchange the information in between different elements so that we can get better benefit from what we already have.
Thank you. So that's on our radar. Mark Hamilton right here. He is keeping a very close eye on exactly what you just mentioned. Believe me, half an hour ago we exchanged information on that one. So we are all in. Thank you.
Looking forward to it. Just come and join us, please.
Our pleasure. Anybody else?
Okay.
All right.
Okay.
Thank you, folks.
Thank you, Mita. Okay. Thank you. Okay, so I think we're going to move things forward. Next, I'd like to invite Blaise Vapedic from Galgus to the stage. So Blaise is responsible for business development and partnerships, and his presentation is all about putting the smart in cities and transportation. Over to you.
All right. So first things first, the audio works. We're happy. Second thing, this session's sponsored by Red Bull for everybody who's coming back from lunch and needs a little kick. So we're gonna try to keep it fun here a little bit. But the topic today, we're gonna back it up a little bit, and I appreciate the previous presentation regarding AI, because you'll see how that weaves into kind of some of the applications here around smart cities and smart transportation, right? Things change quickly. AI is pretty much the only way to keep up, and that becomes pretty obvious as we go through. So just kind of, looking at smart cities and transportation to start with, and we see this a lot. You come to somebody, they say, we're going to do wireless infrastructure through the city, we're going to make it a smart city. They start talking about deploying and collecting data and just measuring everything, and starting from no particular objective. What they end up with is about a huge Amazon bill and not a lot of intelligence, right? Not a lot of smarts out of that. And so it's really kind of, these observations are around what we see and how we talk to customers about their approach to this, so they get to the result that they want, okay? So knowing what you want to achieve going in, right, is probably the first thing. If I'm going to make the investment, if I'm going to, pursue smart cities or smart transportation, specifically, what is it that I'm looking to improve? What operational efficiency from the previous presentation am I looking to achieve as I invest here, right? Those use cases are going to fall out pretty quickly. They'll make pretty much sense. Then it's the scope of, what's the scope of that I'm trying to cover here? From the overwhelming slide, there's a million opportunities, so let me pick specifically within one particular mode, one particular type of an application, excuse me, that we're going to attack first here to get a result. Know what outcomes you're after. You should know going in what's going to represent success in your mind for a smart implementation, and then how am I going to measure it? Right? What do I need to do to know that I made those outcomes or achieved those outcomes, right? So one of the first and most obvious is operational efficiency, right? If you're going for smart, it's going to feel good to the passenger, the guest, the resident, the audience, generally speaking. Smart is going to be something that the people within it appreciate, because it's taking the friction out. But from a network owner or a network operator perspective, you start to get to the types of things that represent the friction to the audience, right? If it's events or public safety staffing, and this is something that's, as we get into smart city applications and location analytics, we didn't necessarily go in thinking about this, but the response that we started getting was, hey, I'm having a big event, or I'm having, a congregation of people coming together. I need to know, from a public safety perspective, where the vests need to be. I need to know where the people are, how long they're there, where they're coming from, so I can start to move resources into the right places to properly support the event. Some of the obvious ones, right? Venue density and capacity. COVID brought this one front and center, right? Not a huge secret here. Footfall patterns. We see from there's a venue optimization. Where are people queuing? Where's the density? What should I do differently the next time to move payment stations around to spaces that are open and available? Letting my location analytics drive me to that decision, as opposed to some anecdotal observation of where people are standing through the event. Let the data tell you. Same sort of thing with queue depths and wait times. And then another interesting one that we came across here is intrusion detection. Not in the way that we all traditionally think of intrusion detection, but if you're trying to clear a mall at the end of the day, and you're security, and you're sweeping the building, it's pretty easy to just go look and see if your Wi-Fi network is picking up devices in the network reliably. Where would I see people moving that probably shouldn't be there, right? And so intrusion detection, not in a malicious way, but just, hey, have I achieved my goal of getting people out of here so we can lock up for the night, right? And if you look at my little graphic over here, which is essentially something that people feel. If you're efficient, it's reliable, the service is what you expect, because you've done things underneath that take the friction out, you just have, generally speaking, a better experience for the people passing through your system, right? The second kind of objective that we see a lot is audience engagement, right? This is some sort of combination of getting the right message or the pertinent message to the right people at the right time. And so the contexts change constantly, obviously. But in the example here, you know, what's relevant to the folks here are what the schedules are, if there's any disruption. You know, let the data coming back through the network talk about, you know, inform the folks in near real time what's going on. A super popular one, and one we like on buses and trains, is the ability for the onboard Wi-Fi to forecast the available seats or capacity of the bus or the train car, or where those seats are in a train set, to the people who are on the platform ahead. So we get people into the right places, queuing in the right places, so boarding is more efficient, and you're not walking up and down the train trying to find a seat. So general things like that, where if you can forecast ahead and say, listen, boarding position A has roughly 25 seats. Boarding position D has no seats. So skip that one, right? These are the types of look-aheads that are helpful to the people waiting to get on the bus, or even to the transportation operator who says, the bus is full. I've got these many people at the station, or at the shelter, bus shelter here. They're gonna, let them know that the bus is full. I would rather know and give me the option to do something different if I so choose, or I wait it out, or I make a phone call, or whatever. But that is an example of feeling the smart of it. I'm not frustrated by the fact that I'm 12th in line and there are only 10 seats when the bus comes, right? A use case with a really good number on it: digital out-of-home advertising and the ability to attribute eyeballs to ads on a screen, right? If you're doing a really good job of people counting and detecting devices and presence of people, and you correlate that with the impressions that are on the display, and there are companies that do it, we partner with them, the advertisers pay more and the advertising inventory owners get paid more. So everybody's happy. The advertisers are happier to pay for ad placement in places where they have some sense for what the actual pull-through or attribution of eyeballs on that ad are, right? Not something that we necessarily went into this with from a location analytics perspective, but something one of our partners came and said, listen, I can dictate the media playlist on these screens. Can you tell me who's present and how long they're there? And the answer is sure, absolutely. So we start putting that together. They start driving the media playlist in response to the presence, the audience presence. They also start aggregating this presence data with other types of analytics that they have to start to build a demographic profile of the user, so the advertisers are even more interested, right, in what's going on here. But being able to reliably people count, it starts there. If you can just tell me the number of eyeballs that saw my stuff, and you can prove it, we're happy to pay more for this. Upcoming events, public safety announcements, just, again, the right message to the right people at the right place and time, right? You have to have the data set to do it. If you try to do it on a weak or erroneous data set, it doesn't look very smart, right? You're better off not doing it. And then kind of the last use case here is the one that I think we all know about, right? Audience connectivity. If I'm deploying a Wi-Fi network and I have a pervasive deployment of Wi-Fi across my smart city, I'm connecting passengers, guests, loyalty members at hotels, ticket holders for a venue, employees in an office building, right? These are the typical, connectivity applications of the smart city and smart transportation deployment. So this is the kind of physical aspect of this. If you're an operator and you're deploying this, you start to fill in the gaps of your macro network coverage with small cell Wi-Fi coverage in places where it's far easier to get to, and using Passpoint and similar technologies, able to deliver the right type of experience, the connected experience to your subscribers, right? So not just in the, kind of in the static venues, right? If you start looking at the modes of transportation, every new deployment, and I came from APTA last week, the Public Transit Association show in Orlando, Florida. The two big things, every vehicle of any sort had its wireless and Wi-Fi communication featured as part of its, part of the set. And the vendors who were there were all talking about people counting. But the kind of the point out of all this is you can't even imagine that new transportation systems are being deployed without Wi-Fi on them, right? This is happening, and if the existing systems don't have it, it's not because they didn't want it. It's because they're 15 years old, the budget doesn't exist, et cetera, et cetera. But at this point, we have the opportunity to essentially blanket the user journey with Wi-Fi. So Wi-Fi is at this point everywhere, especially in the cities, right? You can't walk 2 feet without picking up your phone, looking at a scan list and seeing 50 networks. Different problem in some regards, but certainly pervasive Wi-Fi, right? It's everywhere. It gets deployed by more partners. It gets deployed by, filling out the density. It continues to grow. We need to get more from it, and there's an opportunity to get more from it, to make these cities smarter, to leverage the investment in Wi-Fi infrastructure that you're making anyway. So let's enable it to tell us something about the environment. Let it give us the intelligence that we need to make the decisions that make us smart. Right? Kind of moving on to what you want out of this, the expected results, and how to measure it. Right? Going in, we ask customers, we want to do this. We say, okay, what represents success? Right? Let's go to a POC. We want to test this. Okay, what are your expected results? How much are we improving? What's going to constitute operational efficiency? What do you need to know to measure it? So we have the data itself, but what KPIs do we need to actually compare the AI-driven implementation to previous results, right? Know how to measure going in so you know what success looks like. Right? It's a much easier conversation from a vendor perspective to know going in, or a service provider perspective, to know going in what constitutes success so you're not surprised at the end. Right? A lot of customers go into these things without a great definition. You get to the end, you're like, hey, this looked great. We're not going forward. Did we not achieve the result? Why aren't we going? We're not going forward. So we're trying to get ahead of this by coaching customers and through channels to, really understand what we're trying to achieve so that we don't get into these types of projects and engagements of deploying resources into things that eventually are nice and yield a pretty report, but really don't ever result in any real business, right? So if you've got, my graph here, if you know that you need a better understanding of the environment here, you need to know that you need better connectivity for customers who are engaging with the digital engagement, QR codes and these sorts of things, right? I want to know that I had visibility into how many people were present in this location, how many people saw this ad, how many people tried to engage with the QR code, and did they have the connectivity to do it, right? The complete cycle of digital engagement here, and when it works, it feels right. I didn't have to futz with my phone for 10 minutes and be frustrated that I couldn't get connected, right? An even more frustrating use case, similar, I get to the gate at the airport, I know my boarding pass is on my phone. Loading, 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 loading. We've got to get those types of situations, figure those types of use cases out, and that would be a very measurable thing. Average time to load a passenger through the gate there. Excuse me. So if I know what I want to achieve, I know what the scope of it is, specifically then, what do I need to measure and how do I need to measure it to get there, right? So if I'm taking up a use case that has super dynamic conditions, things change constantly, I need to measure constantly, right? I need the results of that constantly. I need probably to use AI-driven responses to that, because by the time I present that data to a human, even, I put a light on the dashboard in the NOC, or I trigger some sort of alert and I wait for somebody to respond and analyze and react, conditions changed, response really not valid, right? So knowing what your use cases are, knowing what's relevant in response kind of helps you calibrate, how am I going to be successful in this case? What's the accuracy of this data? Is a rough sample good? Is a 20% margin of error okay? 50% margin of error okay? At that point, I'm really just sampling and probably not very well, right? I would suggest that if we're talking about AI-driven operational efficiency, the level of accuracy needs to be high. So this applies, kind of to the people counting case and all of those use cases that come from venue density and guest traffic, visitor traffic, audience presence, these sorts of things. But when you apply, that doesn't look nearly as good. I apologize for those who might be bothered by that. I am. It looked better on a small screen. When you're measuring the RF environment, and we got a little bit of this in the previous presentation, when you're measuring the RF environment, you're measuring the load on the network, you're measuring channel utilization, you're measuring external influence on the network, and arming the network with AI to factor all of those things in. I think we said six-dimensional algorithm, right? It's kind of one of those things where power, transmission power, channel assignment, load balancing, these sorts of things. Every AP does that, right? You have to take all of those things together across the full suite of radio resources available in the network to really achieve maximum performance, right? Shameless plug for my employer. This is where we focus our energy, is really understanding the environment, both people and objects within the environment, but more importantly, the radio and spectral situation in that same network, right? Am I getting measurement in the right places? Am I getting measurement in the right amount of time? Am I getting it with accuracy? Again, not samples or estimates, real data, pretty much continuously, allowing the network to make those optimizations so we don't get yellow lights or red lights in the NOC. We don't get a queue of people in the help desk calling because the experience is bad. Maybe the network and the QoS is telling you everything's good, still people are calling, right? We need the network to take care of itself at the edge so that it can read and react as a unit, as an army of radio resources at the edge of the network to the conditions and circumstances of the network. Okay? When this works, when this is optimized, when people just do what they expect to do and are connected without the frustration of a really horrible user journey or failed connectivity, that feels smart, right? So kind of just, when we're looking at our use cases, thinking about what's relevant to my use case, how dynamic is the environment determines how rapidly I need to measure, right? If it's if it's a highly dynamic environment, it's a continuous measurement, it's an AI-driven response. What's the scope? How broad of coverage do I need to capture and really do service to the use case that I'm interested in? What's my accuracy? How quickly? And this is an important one. We see as a variety of technologies get used in smart cities, cellular networks, overlay networks, Wi-Fi networks, access to the actual telemetry is sometimes a barrier. So I may need data from one of these systems or a partnering system to make really good decisions, but I have to subscribe to it, I have to retrieve it, it's not mine to begin with, sometimes there's a cost. So really accurate first-party data, where my system, my network is generating my data and I have immediate access to it, creates a great opportunity for me to start to do interesting things. And how economical, right? Do I own it or do I have to buy it, right? And then each use case has a kind of a spectrum of what's acceptable for these types of things, right? Wi-Fi sees everything all the time, right? With high frequency, devices are probing, the APs are beaconing. There's a transmission there to be tracked. Wi-Fi networks are more or less ubiquitous at this point. Let's leverage that. It's probably the most economical sensor network you could deploy throughout transportation or smart cities. You're doing it anyway, so let's turn it up to do what we want it to do. How accurate does that need to be? And not all Wi-Fi is created equal here, right? We have MAC randomization that kicked in several years back. Every year it gets a little bit more pervasive. We're pretty much at a point now where anything that relies on MAC address to determine location of devices present has an error rate of like 50% or more, right? You're either throwing out random MACs, which leaves a miserable undersample, or you're counting every MAC you see, which leaves a miserable oversample. And if your network isn't doing this, I know a guy, so you should maybe see me after, right? But this is, when you're doing Wi-Fi-based location analytics, we need to have this level of accuracy, right? Your network, your data, nearly immediately, right? You're deploying them anyway. Let's take full advantage. Related to these technologies, and this is the last slide, things that I'm, kind of have my eyes on from a technology perspective. What makes location better? What gives us better efficacy in the data? What gives us better accuracy in the, in the counts or positions? So 802.11az, relatively new in the grand scheme of things, but a great technology to be investigated to help with precision, right? If you're getting down to 10 centimeters of accuracy on location, I'd say that pretty much covers it, right? You're pretty good there unless you're doing surgery or something, I don't know, right? Halo as a technology, Wi-Fi Halo down at the sub-gig spectrum, a much broader blanket of Wi-Fi coverage, some opportunities to recognize Halo devices, IoT devices and sensors maybe that are moving. Not that there aren't other technologies down here to do this, but if you're already managing a Wi-Fi network and you have the opportunity to add this technology to it, which manages nearly the same as consumer Wi-Fi in 2, 4, 5, and 6, right? That's really efficient. If you can use the same tools, the same skill sets, all of the things that you already have in-house and just add this 802.11 technology to it, there's some opportunity here for, for efficiency. We're looking at this from the standpoint of IoT, even in like managed MDU, right? Multi-dwelling, where they're deploying doors, thermostats, other things. They're usually deploying some overlay network with it. Those networks fall out of sync. The tools that you use to understand if the Zigbee and Z-Wave network is healthy are really not in the same place that your Wi-Fi network tools are. So there's an opportunity here. We like this technology, keeping an eye on this, waiting for the device ecosystem to kind of mature and allow that to be viable. 6 gigahertz, not so much Wi-Fi 6 or Wi-Fi 7, but 6 gigahertz and the opportunity to go standard power or very low power, just the freedom to leverage Wi-Fi technology for these different use cases, right? Again, I'm staying in the theme of I have an investment in 802.11 Wi-Fi management tools and other things. If my use cases allow me to use the technology to do it, the most effective and efficient way to do it is to just get there, not deploy some other technology over the top and you have to manage that deal with that from a network operating expense perspective, right? And then finally, within the WBA, right, we have working groups that are focused on all kinds of facets of this topic. Maybe the most relevant here, Wi-Fi experience for moving networks, kind of evolved out of the airplane use case, and how do you deal with that type of a situation, but it applies equally to trains, buses, anything that's in motion, especially as it relates to calculation of location and these sorts of things. And then finally, venue requirements for user engagement. Seamless is good a lot of times, but if you're deploying a Wi-Fi network with the intent of engaging your users or your community, your audience, seamless isn't that great, right? Maybe you can derive the value from the analytics of having people connect automatically and have a great experience, and that customer satisfaction score is good enough for you, right? Because that's clearly the best user experience. But as a venue owner, venue operator who's invested in this infrastructure, you know, it's not always the best thing to defer, you know, or ignore the engagement opportunity with your audience. So super high level, right? But it is a look just at Wi-Fi and the opportunity to leverage this technology in a broad range of use cases, the way to think about it, the way to approach it, so that you would have the opportunity to succeed. That's it.
So we're going to move. It's a fantastic presentation, Blaise. I had
you,
one
Steve.
question lined up, but that last slide said it all about key technology enablers. So you must have read my mind as well. So
Which one? This? Can I
the
go
one just
backwards?
before, yeah. So that's a perfect slide there.
There's not even any sexy graphics.
That's fine. So we're going to have to move forward, I'm afraid, because we're running a bit short on time. But thank you for that. Cheers. Okay, I'll keep the clicker. Cheers. Cheers. Yeah, thank you. Cheers. Okay, so we have our last presentation. So Mark Molini, I'd like to invite you to the stage. Mark's Business Development Director from JT Decor. I was fortunate last year. Mark hosted me at their magnificent headquarters here in Paris. So just to go and actually experience and see what JT Decor is like in real life and their buildings and the fantastic architecture was a great experience for me as well. So Mark, over to you.
Okay, 1 minute to do everything will be a bit short, but try to do my best to make it interesting. So my role in the company is quite simple. It's trying to develop business around connectivity based on our existing assets and existing services. JT Decor was created almost 60 years ago based on a very simple idea from our founder, Jean-Claude Decor, who went to see a city and told them, okay, guys, you have ugly street furniture. The deal I provide you is to replace all your street furniture with new ones, great looking, and I will operate this free of charge for you in exchange of the right to do advertising in the streets. And this business model has been running for 60 years. Over 60 years, the bus shelters in Paris have slightly changed, look better now than in the beginning. And we are now leading this industry, present in more than 80 countries, more than 3,500 cities, delivering the same services, delivering an audience of over 850 million eyeballs, pair of eyeballs, in fact, every day. So this is our main business, is providing eyeballs to the advertisers. And with always from the start, an ESG commitment that is very important for the company, and that is quite important in the world we're living today. So I will run through some use cases that we have, and just make it short, over 60 years, we've created different services. So we started with the bus shelter, and very short after, we have to create new services for a very single reason. Bus shelters has an advantage, which is being present where you have buses, but it's also an issue. It's not present everywhere else. So if you want to do advertising in the city and then have a dense presence, we needed to have standalone panels. So we offered the city what we call the city information panel, which is an advertising panel, where the city is using the panel for its own communication. This way we can have a dense presence within the city. Then we start developing more complex services, self-clinic toilets, I can tell you that the self-cleaning toilets that we have in Paris will be very busy for the Olympics and will be renewed by that time. And the one we have in the Eiffel Tower is working that long. So it's very important to have a system that works. Delivering also bike sharing system was something very new for us, where we have to deliver the electronics, the software that make it run, and having a robust business model to make it run. Because when we were running this in Paris, we were providing the service for free to the city and giving them all the income from the subscription. And we have to finance all this based on the advertising we had on the traditional assets that we have on the street. So this is something that the company's been doing. It's developing new services and developing the business model that goes with it, always based on advertising. Then, as mentioned by Blas before, the digital was one big change for this company, because we needed to have, of course, locations to have screens, but also starting to collect data to be able to monetize an audience. Not anymore a place, but the audience in front of the screen. And that was a change also in 2014 when we started doing connectivity. And now we are also focusing a lot on data solutions that we're using for advertisers and also for the cities as services. And to just give you a very small figure, 5 years ago there was only a few people taking care of data. Now we have a team of almost 100 people taking care only of data in the company. And this is because it's crucial for us for the advertising and also for the services we're delivering to cities. So now I'll run through a few use cases we have and to illustrate what we provided. One of the first case we have for connectivity was in Düsseldorf in Germany, where we delivered a service that was based on Wi-Fi, mobile application, and interactive screens. So we have interactive screens in bus shelters. We had Wi-Fi on thin informational panels. And with this, we could deliver services that goes beyond just connectivity. The idea was to provide a communication channel to the city and to provide services to the users. Footprint was limited. We have only 50 access points in the city, but that was enough to start collecting data and provide some mapping to the city about where people were moving during the day. And this gave us the opportunity to create new services for city and also to use this data for the advertising. But here, one limitation we see is the scale of the service, because if you have only 50 assets at the scale of a city like Düsseldorf, this is very limited. Also on connectivity, and a drastically different model was the opportunity we had in 2014 to densify the 4G network of Vodafone in Amsterdam. The idea for them was to provide a better network. And at that time, one of the issues they were facing is that to install one single rooftop site, it took them more than 2 years. So the idea for them was to use existing assets, and we have hundreds, more than even thousands of bus shelters in Amsterdam. The idea was to add that very ugly box on the top, to install a small cell to densify the network. So we did that in 12 months' time, 200 of those sites, and clearly this was a way for them to improve the network, and they had very good figures with that. And two things were important for us out of this project. One of them was to understand that it was accepted by the citizens. It's an issue in many cities to have people accepting antennas on their rooftops. When it's visible, people may be afraid of radio waves. And on that case, they have it just on their head when they were waiting for the bus. And we had no problem with this. Nothing was broken. It's been running for 10 years now and still up and running. So that was one of the key learning. Then the second one was the issue with the technology that we have from the vendors at that time. The radio came with an integrated antenna. That makes that you have a shoebox that you must have on the top for one single operator. And when you look at the cost of bringing fiber to the site, it's not efficient. So if you take that, I don't have a picture here, but you can imagine now we can do the same. You remove the box on the top, or you have a cylinder that is 20% that size, and we can host 6 radios instead of 1, because we're putting all the radios inside the advertising casing, and we just have the radios on the top. So this is something we've been developing for over 10 years now. We're present in 12 countries doing this business, and clearly we're acting as a software company. Now, this one is, I would say, a combination of all the services we can provide. This is the way we're transforming public phones in the UK. So about 6-8 years ago, we bought a company called InFocus that was providing public phones in the streets. And something particular in the UK, it's mainly made for advertising. It's not to provide the public phone services. No one is taking care about it. It's only an advertising box, and that's it. Why a lot of people acquire these kind of companies? Because there is a regulation that makes that you don't need to share the money with the city on the advertising, which is not the case when you're doing on bus shelters. And you have a specific right to install your assets. So the idea was to transform those assets into a digital asset where you have services for the city anyway, because there is free Wi-Fi, there is free phone services, there is wayfinding on an interactive screen, there is a defibrillator on each site, and we have already rolled out 400 of those, and providing free Wi-Fi. And we're also trying to take more benefit of the Wi-Fi, because the other side of this is, of course, an advertising panel, a digital one. We're also using the Wi-Fi to create interactive campaigns so that advertisers can engage customers through the Wi-Fi close to the asset. And this is a way to transform both the services we're delivering to the city and the way we're doing advertising on the streets. I like this one because this one is very simple. When you compare the bus shelter here, it's very basic, okay, compared to what we had before. But this one is just delivering Wi-Fi in Guayaquil, Ecuador. We have, remember, it's 450 of those, 350 of those, connected to the fiber and delivering Wi-Fi. In a city where Guayaquil's mayor already wanted to have free Wi-Fi for the people. So they have hundreds, thousands of sites providing free Wi-Fi, and we're just extending that service to the transit for users. And clearly, it's only connectivity. So of course, we deliver them information about the transit when is the bus coming on the portal, but the idea is mainly to provide connectivity. And with a use difference that is maybe not obvious to everyone, when we're offering Wi-Fi in Europe, the usage is quite limited, I would say. Most of the people can have a quite cheap data, mobile data connectivity, so it's not an issue. It's an issue in Latin America where most of the people are having prepaid phones and they don't have connectivity or limited connectivity. So you're providing connectivity for people that really need it. And here the usage is strong because we have over 1 million monthly connections on this network. And what was surprising us is the focus on users. When you look at most of the users are male between 18 and 35. So really a targeting part of the population is using this kind of service. And based on this experience, we're moving further now in Bogota, in Colombia, where we're supporting a model that's going to be at the larger scale because we're rolling out 3,000 bus shelters in Bogota, starting this year. And now we're offering the interactive services in the bus shelter, so you have the interactive screens, all the wayfinding information, you have free Wi-Fi, you have digital advertising, and we have embedded also 4G connectivity in the asset. And what is changing the scale is by deploying this project for a duration of 15 years, we have enough time to monetize the infrastructure. And so we're bringing fiber to each and every site. And having fiber gives us the opportunity to develop a lot of services. And this is a way for us to transform the services we're providing, both to the cities, because we can provide more services once we get fiber to the site. We can leverage on the infrastructure to generate additional revenues, because by offering small cells to the operators, we can generate additional revenue that will pay for the infrastructure. And then offering also more data for the advertisers on the assets that we're providing on the street. So it's been quite a long journey from the first bus shelters that we installed 50 years ago, but we're providing still the same basic service in the streets. For the city, the model remained the same. They don't have to pay for the infrastructure. We pay for the infrastructure. It's based mainly on advertising. But by integrating connectivity services, now we can deliver more services to commuters because they have the wayfinding, they have the free Wi-Fi, and we're providing also 4G and 5G connectivity on this. So this is being a way for us to integrate this technology and to enhance the services and improve the business that we're offering to our customers. That's it. I made it short.
Thank you.
I think we can take a few questions. We'll go to the audience first if there are any questions. Otherwise, I can go. So, some interesting projects, Mark, in Bogota and Guayaquil. So, I'm interested in the technology, the Wi-Fi technology that's being deployed. So, in Bogota, it's 3,000 bus shelters.
Yep.
So, what did you do? Did you go? Is it Wi-Fi 5, Wi-Fi 6, or are you looking forward? What's the?
Honestly, we don't care. It's funny because we always like to talk about the last technology. In that case, we just want the users to be able to use it.
Right.
So the technology we're using, it should be whatever their cell phone is able to connect to. And
Right.
then one thing that is important is the limitation we have on the backhaul that we have. We will not have hundreds of people connected at the same time wanting to have a high bandwidth. We need to provide them connectivity every time they need to connect. And clearly, Wi-Fi 5, 6 are not necessary today because most of the people are not supporting them on their assets.
Okay. In some of these, I guess that they're not quite.
But in reality, we have the ability to provide the Wi-Fi 5 and 6.
Yeah.
It's not useful, but we can do it.
Okay. And do you see, I guess, people congregating towards these locations for the connectivity, but actually not for the service? So are they coming there for the connectivity?
Not yet. We don't have this feedback yet because we don't have the full footprint yet to see how it will be. One of the issues we found from the start with Wi-Fi on the street is that it's not obvious that Wi-Fi is present in the air. You need to have signage. People must associate Wi-Fi to a position, to an object. Otherwise, they're just wondering why should there be Wi-Fi in the streets. So the idea is that people, by knowing that each and every bus shelter will provide Wi-Fi, then they will come to connect.
Okay.
Because they will know it's present there.
Okay. Thank you. Okay. If there are any questions, otherwise I think we are heading into a coffee break. But if that's the case, then thank you, Mark.
Thank you.
Thank you. Thank you. Okay. Yep. No coffee break. Sorry, guys. Yep, we're going to continue. I see.
Well, that was a good start for you to really support me, wasn't it? No coffee break. Thank you. We're towards the end of the day after this session, which is really taking us right back to the beginning, which is about the home, about customers, very customer-centric series of presentations and a panel. For those who don't know me, my name's Steve Andrews. I have been in the industry some while, and my executive career with BT was over 30 years. It was my team who were part of the founding group of the WBA way back in 2003. We were very passionate at BT about Wi-Fi, and we knew that if you're going to influence an industry, you needed friends. And you, therefore, are all friends. So we always felt, right from chip level through to software devices, that you really needed energy, momentum, and most importantly, which I think Rid said this morning, is a focus on the customer, and then work backwards about what you really can deliver. So, without any further ado, I left BT, and I'm now chairman of a data center company in Iceland and Finland. You will see me titled as chairman of Luminet Wireless Networks. We sold Luminet Wireless Networks Friday, so no longer does that apply. But one of my most important roles, as you'd expect, is an advisor to the Wireless Broadband Alliance board, and I'm still, after all these years, hugely passionate about Wi-Fi. So what we've got is an agenda which takes us through a series of presentations. You have double your money's worth, actually, because we've got two fine fellows here who are going to double act in a presentation very much about consumer needs, expectations for the future. I'd like to introduce to the stage Brian Meekum. And Brian is VP Device Technology at Verizon. As you can imagine, Verizon has a huge number of devices. Brian tracks those both for Verizon and the industry, looks at the evolution and looks at what is important for customers for Verizon. Now, I've got to tell you this. You will want to know Brian, because Brian's closely linked with the NFL, NHL, NBA in his role as linking on sports tech. So that's fantastic. Also, Tobin Richardson is President and CEO of Connectivity Standards Alliance. We've all talked many times about how, when you've got a proliferation of devices, IoT devices, how do you manage that ecosystem? How do you get a level of standardization? And Tobin is at the forefront of that, and he is also chairing World Economic Forum Council on Connected World, which means that we should have a really interesting presentation from the two gentlemen. Welcome to the stage, gents. Thank you very much. Go for it.
Lovely. Yeah, all right. So thanks for that lovely introduction. Whenever I'm in Europe, I always say there's one other sports league that we work with closely, and that tends to get you guys off the couch, and that's F1. So any F1 fans in the audience? Yeah, all right, there you go, all 5 of you, great. Okay, so we're here to talk about, finally, I think there's something that's going to bring us all together. And I'm so excited that Tobin's here on stage with us, because having the big Silicon Valley people and then getting the carriers together to talk about a standard alliance for connectivity in the home, we're finally going to have things in the home that just work. And so I'm very excited to be here to talk to you about that. We'll take questions a little bit later. I know we're running a little late, so Tobin and I will be brief on our comments. But I'm excited to be here with you guys today. Tobin.
Yeah, thanks very much, Brian. As Brian said, it's about time that we get things working in the home. Many different companies and different organizations come at it from different angles, but I think we all know that consumers have been suffering for a long time in terms of all the complexity of devices, and they just want things to work. So some folks have done a great job of proving that there is value in the smart home, proving that there is a need that wants to be met by customers, but how do you do that in a way that scales? How do you do it in a way that companies can capture value along that process, but also harmonizes that all together so that we get a great customer experience?
Yeah, absolutely. So we'll take a look here at our first slide. One of the things that we want to talk about is how the future of home connectivity, you can read down there at the bottom, it's all these things that consumers want. There's got to be a trust factor, so security's got to be there. There's absolutely got to be reliability. Integration is key. It's got to be super simple. And then just a desire for speed. I was watching one of the presentations yesterday, and as a human race, we used to be able to focus for 20 seconds. It's now gone down to 8 seconds. That's the reason that we have to do things faster. People have only 8 seconds, which is sadly shorter than a goldfish, I learned. So anyway, what do we want to talk about here, Tobin, that you want to jump in as we go to introduce the Connectivity Standards Alliance?
Yeah, I think it is about that simplicity and that expectation. Brian talked about the human attention span. It's also in 2 other metrics which are really interesting. The time it takes when you click a button and expect the light to turn off, and you click that button again. And that's
Absolutely.
measured in milliseconds, it's not measured in seconds.
Yeah,
that's one. And that's the level of expectation that we have with consumers of how we're going to actually get this all to work. So battling that means you have to actually make all that complexity in the background work a lot easier. And that's where organizations like ours come together, help harmonize standards and make that easier and more possible for consumers.
For sure. So we're going to take a look at the next slide and actually jump into some use cases and then jump into some questions with all y'all. So as we take a look here, there's things that post-COVID that we want to just make easier and faster, and the expectations, the bar is higher. We have less attention span, but also we're working differently, and we have a different expectation, I think, with regard to healthcare and how we can care for our loved ones at home. So tell us a little bit, Tobin, about what you see up here: innovation, healthcare and telemedicine, and remote working.
So this is a great use case as we look at beyond smart home or into smart home and how that can be useful. But taking a step back, that doesn't happen unless you have virtually every part of the value chain, every region, as well as every major and medium and small company engaged. And fortunately and unfortunately, that's what it takes in order to create this kind of simple experience for consumers. And that's what the Connectivity Standards Alliance is all about. We've been around for more than 20 years. Started off as the Zigbee Alliance, transformed to the Connectivity Standards Alliance a couple of years ago with Matter. And Matter is really that unified application layer or application language standard that allows and enables that work. Today we have nearly 700 companies participating, building products. Just earlier this week, Matter celebrated its 1-year anniversary. We did that by releasing version 1.2 that added 9 different device types. Why is that important to these use cases? That enables more products to engage, starts getting us on that path to ambient living where things just work in the background for consumers. On the medical and medical side, we have a full group looking at health and wellness. What they're looking at is looking at all the devices that are already in the home that are maybe talking different specific languages to each other, but instead using a unified language, updating kind of how the device descriptions, the behaviors of the different devices, and then bringing them onto that common language. The use case that makes a lot of sense there is something like aging in place. What does that mean? It means taking advantage of devices that are already in the home, figuring out ways to use those, create applications and uses such that somebody who is disabled or aging can live longer at home without having to move to a more expensive rest home or have other kinds of services brought in. And so just trying to improve that aging experience so that people can stay home longer. And have a more rich experience. You can do that through sensing devices and many other devices.
Yeah, so one thing I want you guys to take away from this segment here is when we think about the Connectivity Standards Alliance and we think about Matter, what might come to your mind is Thread. And so you might have heard about Thread and Thread integration. You might have heard about how things have to be built with Thread. But Tobin's going to tell us a little bit about how also with backwards compatibility for existing telemedicine and health things in the house, it can work over Wi-Fi as well and still be all those things we listed, secure and safe. Why don't you tell us a little bit about that, Tobin?
Yeah, that's a really important part, right? So Matter, the reason that this is possible is Matter adopts an internet protocol kind of transport approach. So anything that can transport internet protocol can effectively carry Matter messages and Matter devices and Matter networks.
Which are all standard. Everybody's agreed how that's going to work from a secure standpoint. Amazon, Google, Apple, HomeKit, you name it. That's the important part to take away from here.
Exactly. So you've got all these companies that already have billions of devices deployed. When we launched Matter last year, basically overnight, you had more than 1 billion devices able to upgrade to Matter. Of course, there will be new devices. The idea here, again, is just basing all that on IP allows you to do all this on a Wi-Fi network or do it on a Thread network or do it in a mixed network, depending on how you want to kind of attack that. So we know that this is going quickly. It's moving out fast, but also want to make sure that we do that in a way that provides good stability. So we're doing updated stability releases to Matter, as well as what Brian talked about with an increased and improved security at that application layer, as well as making sure that all these devices have a nice stable place to work. And the other part I think I would talk about is within the Alliance, we have actual new working groups focused both on product security as well as data privacy. And that's really kind of looking at this kind of trinity of 3 areas of interoperability, privacy, and security. Consumers, we talk about consumer need here, want and need to have all 3 of those. Sometimes they don't know that they want privacy, but they do, and the governments may speak on their behalf. And so we have work going on with the world's leading companies as well as the world's leading governments, or virtually every government, to ensure that as there are different regulations and requirements, whether it's in Europe, the United States, Singapore, the UK, if you're coming in through the CSA and you effectively work on a product security harmonization here, that's going to work in all those different regulatory areas.
Absolutely. So just to give you some perspective, as a Tier 1 carrier in the United States, Verizon next year will be rolling out Matter compliance on all of our routers. And so our intent is to use standards-based to make this easy so that we're not dictating what home assistant you're going to use. We're trying to make it so that you just have all those things that you saw listed up there. So I'm excited for it. I know our company is. It's exciting to see other companies. I hear other carriers and operators doing the same thing. Why? Because it makes sense. Because it's easier. Because it just works. And that's the way the home should be. So That's about what I want to talk about. Anything else before we open it up?
No, I think, we talked about harmonization. I will just call out that we have, the world's leading companies, and that is from chip to ODM to retailers to ecosystems, and that's great. But you don't have that harmonization unless you work with other organizations. So we have great working relationships with a number of other standards organizations. I'll call out my good friend and colleague, Kevin Robinson from the Wi-Fi Alliance in the back there. And we really appreciate that kind of open work that we have with those organizations. We know that group will continue. That's the only way that we do that, and we're really excited about newer initiatives in open source like Purple.
Yeah, very nice. Absolutely. So, all right, any questions? What do you think? Go ahead, right there. Do you have to get a microphone? All right, hold on one second. We've got a rover coming over the mic. Maybe she could run faster. Just kidding.
Hi, thanks for the speed dating presentation there.
Absolutely.
I have a naive question to ask you. I mean, currently, Matter, requires, if I've got an iOS device, I have to buy an Apple device, and I may or may not want to act as a hub. Same thing with the Google. I may have to buy a Nest device. Then there's this whole thing with thread routers and whatnot. When do you see it really becoming plug and play, where it's agnostic? The customer doesn't have to figure out some of these complications, and that, maybe something you referred to a few minutes ago, can reside on the router, and you don't have to worry about all these other things that you have to buy or interact with in order to control your devices. Secondly, as a other plan, that when do you foresee it perhaps being radio frequency or radio technology agnostic as well, to incorporate things like Z-Wave and, some of the sub-gigahertz bands that are used in home security?
Yeah, I'm going to toss that over to Tobin, let him take that one first.
I appreciate the speed dating route point as well, moving fast. So the first point is, when will it be, effectively agnostic to the ecosystem? By the definition of the specification, it's there today, but it really only matters when companies actually build products to do that. So that will really depend on when companies decide to bring those products into the market, different apps, controllers, and then have that available. So long as they're carrying the Matter mark, they'll interact the way that they're expected to. And I think, what was your second question?
I think you...
RF, different. So today it's supported by Wi-Fi and Thread. And we talked about Purple. We're talking to a lot of other organizations that want to look to carry Matter over different transports, including things like LoRa, DECT, choose your favorite sub-gigahertz radio and region, so long as they're supporting IP. It's a fairly straightforward process, but it's a process. So it will depend on the number of companies. The way that we work, we're member-driven. If 3 companies want to come together, define a spec, and define an exchange, that's how that will happen. The second part, you talked about Z-Wave, as well as the first component of when will this be available in the devices that we know and love. We are taking kind of a gateway approach so that you don't necessarily have to throw away everything. That's not a good message. It's also not good for the environment. And there's plenty of good utility from all the billions of devices that are deployed today. So we've actually, companies will develop these gateways, but we've also done a standardized gateway for Zigbee, and we'll do that, I expect, for other protocols too.
I think, too, let me answer your question from a carrier perspective. So today I have my personal experience. I have 5 different gateways for different things, cameras and lights, and it's a lot, and I don't like it. And my family doesn't like all the different apps, so in essence, they don't engage it. When we have our routers with Matter compliance rolled out, we will be rolling out on Purple. That was referenced earlier. And that is 2024. So both our in-home for our product called Fios, through our traditional internet service provider backhaul, as well as through our fixed wireless over 5G, those will be Matter compliant. You buy something that's Matter compliant, a door lock, a thermostat, whatever, it will just work. So I think in answer to your question, there's the backwards compatibility that we have to satisfy, but also moving forward, you just have to have the software on the home router. Then you don't need those gateways anymore. So that's kind of the promise of getting away from my house scenario. Do you have a question, or you want us to sit down? Yep, I just got the, you need to sit down. Super. And I felt like we went fast. Okay. Yeah. Well, any one last question before we go? Yeah, go ahead. Talk loud.
I think I heard the question. They're battling the air up there. Wi-Fi Halo? I don't know on that one. I'll point to Kevin in the background, but in terms of
the guy holding his
whether or
hands
not
up,
we'll support,
Kevin, you take questions afterwards.
I stand by the earlier comment. If it's IP-based, then it should work. In terms of the integration, I couldn't tell you today, but yeah. Good question for Kevin. Really appreciates me pointing at him. I'm sure.
All righty.
Yeah,
well,
right.
thank you very much.
you.
Yeah.
Appreciate it.
Thank you very
We're getting the
much.
hook.
All right. Thank you.
Thanks, everybody.
Tobin, that was fantastic. Thank you. Brian?
Appreciate it. Yep.
Brilliant. Well, thank you, Jane. It's made me redundant. Perfect. Took all the questions, took everything rolling. Fantastic. And I got to say, 8-second snapshots to align with what Brian was telling us is the average mental capacity now of everybody is even better. We're going to move on now, and it's a delight to welcome a colleague from Korea Telecom. It is Mr. Chang. Mr. Chang is going to talk about consumer experience, and particularly it's about, the ISP and creating value, which is very important. Back to how do we create value from consumer requirements. So over to you, Mr. Chang. Thank you for joining us.
Okay, I'm Ha-Wook Chang. I'm a project manager and team leader of Korea Telecom. And also, I'm in the device business department, so I am involved with developing and commercializing KT's Wi-Fi device. Today, I'm going to introduce KT's Wi-Fi 7 product and Wi-Fi strategy to create customer value. Okay. KT is the #1 internet service provider in South Korea. In 2022, the number of KT's internet service subscribers is more than 9.7 million subscribers. And among this number, more than 7 million subscribers are using KT's Wi-Fi router, and we just call it Wi-Fi Home AP. Okay. These products are KT's Wi-Fi Home APs. As you see, KT has developed and launched many Wi-Fi APs since 2015. And during this time, KT actively promoted its Giga Internet Service and the Giga Wi-Fi brand. Especially in 2019, KT commercialized the first carrier's Wi-Fi 6 Home AP, Giga Wi-Fi Premium 2.4. Its speed is up to 2.4 gigabps. And then KT released the more cost-effective Wi-Fi 6 Home AP, Giga Wi-Fi Home AX in 2020, and Giga Wi-Fi Buddy AX in 2021. So they allowed customers to experience Wi-Fi 6 technology and high internet speed at affordable prices. After that, KT developed Giga Wi-Fi Premium 7 in the beginning of this year. So we did many tests on Wi-Fi 7 technology, and we completed a few technical verification. However, Giga Wi-Fi Premium 7 was not commercialized, but KT plans to officially launch Wi-Fi 7 Home AP with a new product design next year. Okay. As you know, Wi-Fi 7 technology provides a higher speed based on 6 gigahertz frequency and 320 megahertz bandwidth. In addition, it offers enhanced QoS, multi-link operation, and bandwidth puncturing. Today, customers want always connected, reliable, and fast Wi-Fi connection for many applications, such as remote video meeting, remote wireless office, VR, AR, 8K video, and real-time games. So this kind of more demanding applications are driving demand for Wi-Fi 7 technology because of high speed and broadband. Giga Wi-Fi Premium 7. This is the first carrier's Wi-Fi 7 home AP in Korea, and it supports maximize the reliable Wi-Fi performance on with Wi-Fi 7 enabled device connection. KT developed two types of Giga Wi-Fi Premium 7. One is external antenna type, and the other is internal antenna type. Giga Wi-Fi Premium 7, its speed is up to 11.5 gigabps speed with 320 megahertz bandwidth on Wi-Fi 7. And it supports 6 gigahertz frequency, OFDMA, MU-MIMO, and IPTV over wireless LAN. IPTV over wireless LAN is KT's specific requirements for KT IPTV service. Other features are multiple concurrent connections, reliable speed, QoS, and so on. This speed test result was demonstrated using Giga Wi-Fi Premium 7 and Intel laptop at MWC in Spain. And also, KT showed KT's own delivery robots and any other solution. Furthermore, we announced the MOU with Intel to cooperate Wi-Fi 7 AP launching for the first time. Korean customers generally use IPTV set-top box, AI speaker, and Wi-Fi home AP at home. However, these products take up physical space at home and sometimes spoils the home interiors. So KT launched the Genie TV all-in-one soundbar on April this year. This product supports Wi-Fi, IPTV, and AI speaker functions at once. The big difference from another set-top box is design and technology. This product won a world-famous design award, and we focused on interoperation between Wi-Fi AP and IPTV set-top box. So more than 10,000 customers apply for this product every month. When we monitor users' online reviews, we realized that they are satisfied with non-master LAN cables and easy Wi-Fi connection using QR code on TV screen. Yeah. High order service. This is KT's special service package for small business customer. Recently, table ordering and serving robots have become very popular in Korea. This is because stores owners do not want to pay more money to run their stores. And when KT provides a high order service, our engineers install Giga Wi-Fi home APs with other equipment. Giga Wi-Fi home APs are connected with EasyMesh so that they can manage even big space store. As I told you, KT has developed and released the Wi-Fi APs, including KT's own technology and design. So this is the last one. Please keep watching KT's challenge for Wi-Fi 7. Thank you very much.
Thank you, Mr. Chang.
Thank you.
Very much appreciated.
Okay.
Whoop. Thank you. So Mr. Chang said he'd be very happy to take any questions. He is around at the conference. Please feel free to do so. Thank you for a very insightful background to what you've done in Korea. Korea Telecom has always been at the forefront on innovation. And I know through my career that we were always looking to KT to what they were doing. So thank you, Mr. Chang. Our next guest, Patrick Rubadier, hope I've pronounced that right, Patrick, is Senior Director of Product Management at Qualcomm. Now, we're going to focus now on the future of broadband in a Wi-Fi 7 era. And Patrick has more than 20 years engineering and customer experience on leading-edge wireless, which is absolutely fantastic, both in Wi-Fi and cellular. And it is our pleasure to hear what's happening. Always from the chip level to the top, as we said earlier, it's important what you're doing. Thank you. Welcome.
Thank you so much. I appreciate it. Good afternoon, you all. I hope everything's fine so far. So my name is Patrick Ribardier. I work in technical product marketing for Qualcomm. And I will be presenting some of our thoughts about the future of the broadband services in the Wi-Fi 7 era. First, I'm going to start my presentation with few words about Wi-Fi 7. Okay, I know you guys have probably heard about Wi-Fi 7 a lot so far, but you're still going to get some more. And then I'm going to peel the onion and go into what it means holistically for the next generation gateways. Let's get started. So yes, the Wi-Fi 7 era is here. Today, with our Wi-Fi 7 portfolio, we have more than 350 in design or productions. You know, looking at our clients, the Fast Connect 7800, we have had more than 190 design. This device has been in production for more than a year now. And looking at the Wi-Fi infrastructure, right? You may have seen recently some retail leading brands announcing their Wi-Fi 7 devices, you know, based on our solutions. Some enterprise customers also have launched Wi-Fi 7 using our solution as well. Thank you for that. But more importantly, the service providers are also launching Wi-Fi 7. You may have seen also some more press releases. I'm sorry, a lot of press releases. You know, from a leading service provider in the UK and in the US, announcing that they will be using Wi-Fi 7, you know, using our solution, rolling it out to their subscribers beginning of next year. But so the question is, why is everybody rushing to Wi-Fi 7? It is because with customer application, you know, changing and our environment changing, namely work from home, you know, high-resolution videos, more and more appearing to more devices, more gaming, XR devices, the mixed reality world, you know, coming in. We need a broader and more comprehensive approach on Wi-Fi, and this is what Wi-Fi 7 is offering. So Wi-Fi 7. Wi-Fi 7 has been defined from the ground up to manage global wireless spectrum variation. What does that mean? As you know, Wi-Fi spectrum, you know, varies between continents, sometimes between countries. Wi-Fi 7 standardized 6 GHz with up to 220 MHz bandwidth and enable multi-link. I'm sure you guys have heard of multi-link so far. And multi-link is enabled with 6 GHz in order to make sure that various regulatory allocation in 5 or 6 GHz do not prevent and cannot act as a barrier to high-speed, low-latency performance. And you know, our previous speaker was already speaking about this. Those are the key for the Wi-Fi 7 era. But what does that mean for me, right? You know, in my home, in my business, or in my school, right? Multi-link efficiency will make a much better management of congested environment. But let me take an example, right? You're at home. You're in a call, a team call, a Zoom call, you know, all those nice video calls that we all do in this hybrid world with my boss's boss. So it's kind of an important call, right? I don't want to miss that one. And then my neighbors, who is operating on the same channel or where I'm operating, decides for whatever reason to start downloading a very large file. Immediate result, my bandwidth will drop. Now with multi-link, and Wi-Fi 7, my router will immediately detect this drop in bandwidth and switch, to, the other band, 60 gigahertz in this particular example. That is one example. Another example is, let's say now I've done my call, I'm relaxing, I'm happy, it was a good call, maybe I got a promotion, why not? And I'm on my couch streaming football, right? Real-time TV, I'm streaming, everything's good. And at the same time, my router detects an interference on 5 gigahertz. Let's say a DFS event. Those pesky radar events that happen? In Wi-Fi today, what you have to do is you have to enable a channel change. Channel change is a protocol, it's very well defined, takes several milliseconds, hundreds of milliseconds, sometimes a minute. And during that time, poof, that's it, no more Wi-Fi. Fortunately, that was at the time where the goal was going to happen, right? Now with Wi-Fi 7 and adaptive puncturing, you're going to be able to carve out, the little blip inside your channel and still be able to deliver the high resolution video that you're looking at. Where you are able to see this decisive goal on that game. But more than managing today's existing issues with Wi-Fi 7, and it does that, it's really about enabling the next generation application. And it was touched upon by the previous speaker. It's about video-based collaboration. We all do that. Rich and immersive gaming. Mixed reality opportunities. All of those, they require wire-like latency and speed. And this is just not, once in a while. It's a recurrent theme that is going to happen with all those new applications. So you need reliable, consistent, deterministic, connectivity that is always on, because those cases will be simultaneous. So that's what Wi-Fi 7 will offer, to you. But then, if we widen the lens a little bit, if we start thinking, okay, I have this Wi-Fi 7 is going to give me, great experience, much more capability than I had before, I also need to make changes on my gateway. What does that mean? We believe that the industry needs to transition from a home gateway platform to a full delivery platform. And why is that? Because the connectivity platform today, their main role, they really have one function, right? It's to connect to high-speed broadband, take that high-speed broadband, deliver it via Wi-Fi to the devices that are in your home. And it's fine, doing it well, it's great. But the new home gateway is going to have to manage intelligent service. It's going to have to be a delivery platform. It's going to have to be able to prioritize between all those streams, prioritize between all those new services that the service provider are going to propose. And for that, it will need to focus on a new service, which is what we call the user experience. So user experience, of course, starts with high-performance connectivity, right? But on top, it also means managing this connectivity to drive those immersive services that we're talking about. And it has to unlock its full potential by having a flexible software and be able to push some software innovation, be the vehicle for continuous service updates. So, we were talking about quality of experience, quality of services, right? So far, to enable quality of service, we are using two systems, two processes. The first one is WMM, standard-based, right, where you're pretty much enabling weights to your Wi-Fi packets to increase the priority of a flow compared to another one. And the other one is to use what we call managed Wi-Fi, which are, when you have a mesh system and when you're managing it from the outside, looking in, saying, okay, I'm going to do a band steering or I'm going to do something else. When it's fine, it's working, right? It's working. But for the next generation Wi-Fi, we're going to need to do a little bit more. What we're going to need to do is we're going to need to think about What is the unique profile of those user applications and services? How do we provide real-time connectivity optimization in the Wi-Fi? How are we going to enhance the performances of all those devices in the home, regardless of the generation of the device and the type of the device you're dealing with? And finally, how do you make sure that the carrier who is providing all of this package is able to harness these capabilities to orchestrate those services from end to end, from the distribution cabinet to the end device, right? Because those are why, by which the new the user satisfaction is going to be defined. And all of this has to run into the gateway software. So this gateway software is going to need to evolve at the same time. You're going to need full programmability on your gateway, through open APIs, new middleware ecosystem, and open source platform OS. Those are things that are actually taking place as we speak, with the service providers. You're going to need to include the building blocks to streamline development, to accelerate deployment of new services. And you're going to need to abstract the complexity of the service provisioning, of the monitoring, of the orchestration, so that developers and users can fully use the potential of this home gateway. That's quite a bit of changes, right? Because in addition of what the carriers are delivering today, they're going to be required to provide premium optimized services. They're going to be required to have an increased service insurance, and all of this in an increased smart home app ecosystem. And that's how we think this, the world is going to shape, in the near future. And to get ready for this, we in Qualcomm, we've been working really hard to develop our new 10G fiber gateway platform. So this platform, which is available now, is going to give you superior connectivity, right, from a 10G PON, 1 BBF247 interrupt-proven solution, packaged with a quad-core ARM solution, coupled with our Wi-Fi 7, we've discussed earlier, as all the features requires and is in production as well today. And the whole thing, packaged to deliver an exceptional user experience thanks to our new software called Qualcomm Service-Defined Wi-Fi. This software bringing a solution that allows you to orchestrate, classify, prioritize, and schedule at flow level from the optical entrance to the Wi-Fi end, and better understand what is going on in your customer's home. And of course, because we mentioned how new software was needed in the gateway, this platform supports all the new middleware that are being developed today to ensure fast and easy integration by our customers. Okay, I hope I did not bore you too much. And now I'm going to finish just with some numbers, few things for you to remember. This is what we can do already today with our Qualcomm 10G platform solution, right? Exceptional experience, that means no lag, no buffering, no glitches. And today we're able to measure 85% latency reduction for your XR experience, 75 jitter reduction on your 4K live video, 75% loss burst reduction in your HD video call, and 95% reduction when gaming. I want to thank you again for your time. I'm looking forward to further discussion with each and every one of you. Thank you so much.
Thank you, Patrick.
Of course. Thank you.
Very good presentation.
Thank you so much.
I'm going to suggest if you have questions for Patrick, he's joined us on the panel, so do throw questions to the panel. I'm sure he'll pick up on things from his presentation. So we move on, and it's a great delight that we have the next topic of beyond connectivity, how Wi-Fi sensing is shaping modern homes. And this is a really, really interesting topic that is evolving. If we'd have been 5 years ago, you probably wouldn't have had this topic in any great depth. But Joseph Valencia, Chief Product Officer of Origin Wireless AI, is going to come and talk to us now. Joseph is Chief Product Officer at Origin AI, where he leads the definition and delivery of a portfolio of innovative Wi-Fi sensing solutions. So we truly do have the expert in Joseph, and it's a delight for you to share with us all that experience and knowledge. Thank you, Joseph.
Thank you.
Good to see you.
All right, can you guys hear me okay? Yes? Awesome. So once again, my name is Joe Valencia. I'm the Chief Product Officer at Origin, and I'm so excited to be here today to talk to you about Wi-Fi sensing and the value-added services that we can create, that we can power, and that will transform how people inhabit their homes, their spaces, and their businesses. And we're going to do this in two sort of groups. There are going to be two sections to my talk today. First, I'm going to talk to you about Origin, who we are and what we do. And then we'll go ahead and talk about Wi-Fi sensing and its applicability to the smart home. So let's go ahead and dive in. So this is me, you can tell because the picture up there matches. So I've spent 20 years working in technology and telecom. I've had a lot of different roles with a lot of leading companies that you see there. But in my last role, I was working on smart home platform for Verizon, and that's when I first came into contact with Wi-Fi sensing. And I was completely blown away by the potential of Wi-Fi sensing to create these incredible new scenarios, these incredible new services. And after almost a year of begging my current boss, the current CEO, he finally brought me aboard, and now I lead product. And for those of you who are unfamiliar with Origin, we'll just talk a little bit about that. Our company is the inventor of Wi-Fi sensing, and I'll talk about that a little more in the next slide. But what I want to impress upon you here is that we're not just the inventor, we're also the leader. We're the fastest growing company in this space. By the end of this year, we will have 25 million devices running our software globally. And the reason we're able to sustain that kind of growth is because of the incredible roadmap that we've built on this really strong foundation of intellectual property, right? You can see the numbers up here, 60 patents, 140 more that we filed for. What is it? It's Wednesday, so maybe there were a few more in the last couple of days, I don't know, but these are the most current numbers we have. And all those patents, all that intellectual property that we have is really attributable to this man, our CTO, founder and chairman. This is the person who invented Wi-Fi sensing. This is Dr. Ray Liu. He's had an incredibly distinguished career, not just in academia, but he's also been recognized as part of IEEE. Last year, he was the president, and he's been honored by them in the past as well for all of his achievements. Now, it's a really interesting story how Ray invented Wi-Fi sensing. He was actually doing a project for the US Department of Defense, and they asked him, they said, Ray, can you help us figure out how to do high-quality wireless communications within a submarine? And so this is obviously a very difficult problem. A submarine has all these metallic surfaces, lots of bulkheads, lots of doors, lots of reflections. And Ray did solve that problem. But the other thing that happened is he had this epiphany. He had this insight. He realized that Wi-Fi can do more than just communication. It can also be used to do things like presence sensing and motion sensing. And literally, this is the idea that the company was founded on, that Wi-Fi can do more. When I leave the stage, you'll see it on the back of my shirt. So this is not just our marketing slogan, though. This is also the mantra that we live by. And that mantra has really transformed into our mission. And what is our mission? If you go into the halls of our headquarters in Rockville, Maryland, and ask anyone what it is that we're there to do, it's to leave a legacy. It's to leave a legacy where we are improving people's lives. And we believe we can improve people's lives in three ways. We can make it easier for them to inhabit their spaces. We can make it safer for them to live their lives, and we can make their homes more secure. Not just their homes, but the people they love and their possessions. So that's really what Origin is all about. So let's move on. Wi-Fi sensing. So, like Stephen said, 5 years ago, we couldn't have had this conversation because Wi-Fi sensing was a relatively new technology, or it didn't really exist. But fundamentally, what Wi-Fi sensing does is it uses the dozens of devices that we all have in our homes. I think in the US, the current number is about 16 devices on average using Wi-Fi. What we're able to do is use the Wi-Fi signals from those devices. We can interpret the disturbances that people make as they move through them. One of my favorite sayings when I talk to our PhDs is that, we're just big bags of water, right? So, as radio waves move through them, we change the signal. So our fundamental innovation here is to take those disturbances, process them through our AI engines, and really understand what's happening in a space. So whether that's presence sensing, which you saw on the previous slide, or using these insights to do things like control lighting, control energy usage for heating and cooling. These are the kinds of things that Wi-Fi sensing can enable. So how do we take these insights, this intelligence, this context, this knowledge, and how do we use that to enable these services? Well, at Origin, we use what we call our true presence sensing data layer. And this is really just a way for us to take these insights, the understanding of the context, and allow our customers and partners to understand the true state of presence in any space. And what I'll say is, Wi-Fi sensing does this better than any other technology out there. So if you look at what's in the market today, things like passive IR sensors, anyone here who has an alarm system probably has one of these sensors. And really, it's just looking for differences in temperature. So this is like 50, 60-year-old technology. And this obviously has a lot of problems. It's only line of sight. So if you're on the other side of a wall, or if an intruder is on the other side of a wall, or the vision is blocked, you won't see them. The other challenge with passive IR sensors is they don't provide any context. All they do is tell you whether or not there was motion. It doesn't tell you what caused that motion. If it was a person, if it was a pet, or if it was a machine. So it's a very sort of primitive way to do presence sensing. And then another technology is, of course, video cameras. We always hear, what about video? And while video cameras are great, the challenge is, for privacy reasons, no one really wants them pointing inward, right? People are very happy to have doorbells with cameras from Ring and whomever else. They're very happy to have Arlo cameras on the perimeter of their house. But the minute you start pointing them inside, it's a non-starter. So, while video can do great things, it's not really appropriate for the kinds of scenarios we're talking about. And, for those who do have cameras inside, you're still limited by the line of sight nature. Right? So obviously cameras can't see through walls. But I'll tell you what, Wi-Fi sensing can. So just like wireless communications can permeate your home, reach every corner of it, as long as you have good coverage, Wi-Fi sensing can too. We can provide whole home understanding of context. And this is really a game changer. And it's a game changer specifically for two different verticals. And these are the areas where we're actually seeing the most interest. The first is intrusion detection. So intrusion detection, this is really interesting to security companies. It's interesting to ISPs who want to get into security. And I'll explain why. So if you talk to anyone who works in the security business, they'll tell you that 94 or 95% of all the alerts that go from a home security system to the security provider's monitoring center, 95 of those are false alarms, meaning a sensor was tripped, but there really is no threat. So think about that for a second. Nearly every signal that a security provider relies on to keep your family safe, to keep my family safe, is wrong. So this has obvious implications, not just from a consumer experience standpoint, but also for the security provider themselves. You know, it's an incredible cost for them to bear, to have to try and triage all these false signals that are coming in. It's a really difficult problem for them. So by being able to give them, you know, a very high confidence view of the present state of a space is incredible. It's a game changer for them. It will improve their bottom line, it'll improve their performance, it'll improve their net promoter score. So they are incredibly excited about this. Now, the other space where we're seeing a lot of traction is in occupancy. And when we think about occupancy, we think about energy, right? We think about energy usage and the cost of energy. And I'm sure everyone in this room in the past couple of years has been impacted one way or another, whether it's extreme weather events, hurricanes, tsunamis, you know, the incredible heat that was here in Europe this past summer, or impacts to your pocketbook. The increasing demand for energy, the increasing costs to produce energy is being felt by everyone. And so what we can do with occupancy is help our partners understand, is the space actually occupied? And from there, our partners, our customers, smart thermostat makers can then make more intelligent decisions about whether or not to activate their system. So, you know, current smart thermostats, they do this today, but the way they do it is often with passive IR sensors, and we just talked about the problems with those, right? So in my home, my thermostat is in the dining room, but my office is upstairs. So if I happen to work from home one day that I'm not supposed to, you know, I'll have to go downstairs, wave my hand in front of the thermostat for it to work. Now with Wi-Fi sensing, that's not going to be necessary. Again, we're able to provide whole home coverage, whole home understanding of presence. All right. So now that we've sort of baselined you on who Origin is, how Wi-Fi sensing works, we're going to talk a little bit about how Wi-Fi sensing and these services are impacting and influencing how we're all going to inhabit our spaces today and into the future. So our goal at Origin is very simple. We want to use these data layers to redefine the experience of the home occupier. So that's me, that's you, it's owners, it's renters. And what we want to do is transform that experience. We want to evolve from smart homes to intelligent homes. And when we make that distinction at Origin, it's not just about understanding the state of a space, it's being able to anticipate what our customers need and being able to deliver that. And we do that through partnerships. So, you know, when I give this talk, sometimes I hear people say, well, you know, we already have smart home devices. But let's talk a little bit about some of the challenges. So, you know, for several decades, we've been promised a home that will automatically understand what we want, that will automatically deliver it, automatically change and adapt, right? And this is true from, I think this is from the 30s, right? So the first half of last century, it's even mid last century. So this was, I think this is GE at one of the World's Fairs talking about, hey, you know, there's this concept of these intelligent homes, right? So this is a concept that's been around a long time, but it's never been delivered. So it seems like now, since the beginning of the century, we finally have all the pieces we need. We have blazing fast broadband. We have a plethora of smart devices in the home. We have unlimited computing power in the cloud. So it seems like finally, right, we're able to achieve smart home nirvana, right? We all want to sit there at home, just have our house anticipate what we want and deliver it to us, right? But unfortunately, instead of that, we get this. So smart home today, as anyone can tell you, can be an often frustrating experience. Your smart lock doesn't talk to your smart lights, doesn't talk to your smart thermostat. And none of these things necessarily have a common understanding of what's going on in the home, whether you're there, how many people are there, you know, what you're currently doing. And because of this, you know, like that's not my wife, but my wife, for example, would oftentimes yell at Google or Alexa because she's not getting what she needs. You know, she walks into the room, lights don't come on, full of groceries in her hands, and just yells at Alexa. So anyway, so this is oftentimes what happens. But you know, the question here really is what's missing. And what's missing is context, right? What's missing is that real understanding of the presence status of the space. So what we believe at Origin is that we can really deliver on that promise, that smart home promise, the intelligent home promise we talked about. And we actually believe that together we can solve this. And when I say together, it's not just Origin, it's everyone in this room from every part of the ecosystem. So it includes us, it includes our application provider partners, our silicon partners, OEMs, operators, everyone. If we all come together and we coalesce around this, we think we can really transform the smart home experience. And to be specific, what we're talking about is a home that's always ready. It's always ready to serve you. It's always connected. It's connected to all the devices in your home. It's also connected to the cloud. And it's fast, right? It can respond instantly. Someone else earlier mentioned light bulbs. So a light bulb has to turn on within 500 milliseconds, right? So that's really what's necessary in order to deliver on the promise. And what we want to do is evolve beyond just asking to just being. In order to get that smart home experience, all you have to do is just be there in your space. You just have to do what you're already doing. Essentially, you just need to be yourself. And that's the power of Wi-Fi sensing. This is what we'll be able to do with our partners, deliver that promise. And you know, ultimately, sensing is going to be a transformative way to interact with your home, right? And that's what we want to deliver. Now, a little bit about the actual scenarios themselves. You know, I talked about a home that can anticipate your needs. So this is a home where you don't even have to ask. Sensing will just know. It will know what's going on. Sensing will know when you come home. You know, in the US, it will know when we pull into the garage and open the garage door. It will know when you come in the door. And once it knows you're there, in this example, it can do something like turn the light on. Okay? Now, turning the light on might seem very simple, but you know, I'm sure everyone in this audience has had the experience when you walk into an office, right? A little office cubicle, and the light comes on, right? Because of that passive IR sensor is there. But what happens after 10 minutes if you're just sitting there typing? It goes off, right? So it goes off, so you're in the dark. And you're sitting there waving your hand around like a madman trying to get it to come on, right? And that's because passive IRs are not good for presence sensing. But with Wi-Fi sensing, we'll know you're still there. We will know you're there whatever you're doing. If you're typing, if you're reading, if you're sitting on the couch watching TV, we will be able to provide that definitive marker of presence. And our ability to understand presence also expands, not just to lighting, but it also is for climate control and thermostats. So in this example, let's say your child falls asleep on the couch. You want your kid to be comfortable. And with Wi-Fi sensing, we'll be able to understand not just the gross movements of walking around, we'll also be able to understand the minute movements that you make when you sleep, all the way down to understanding the movement of someone's chest when they breathe. And by working with our partners, we'll ensure that this child is comfortable, while also making sure that when he gets up to go to his room, the climate in that room can be adjusted back down to a reasonable level. Sensing also knows about a very important portion of our population. So it should be no surprise to anyone that in the developed world, especially, our population is getting older. In Japan, 30% of people are of senior age. In Western Europe, in France, Italy, Germany, Finland, Portugal, Greece, 20% of the population is of senior age. In the United States, 10,000 people turn 65 every day. So you can call this whatever you want, the silver wave, the silver tsunami, but what's happening is our population is getting older. And as they get older, this is a huge burden, a huge challenge, frankly, for all of us to take better care of them, to make sure they're healthy and safe. And with Wi-Fi sensing, we can do this. We can understand what time mom got up. We can understand how much time she spent moving around the house. We can understand when she went out for her walk. And we can do all of this because we know with a very high confidence level whether or not there's someone in the space. And it's not just about understanding in that moment what mom is doing. It's also about understanding what the pattern is over time. And then, even more importantly, understanding when there are anomalies, right? So if, mom usually gets up at 7:30 a.m., but now she's started to get up at 9 a.m., this could be a leading indicator of a problem. So, by identifying these anomalies, our partners will enable people like me, people like you, to reach out to our loved ones and see if everything's okay. So this is really powerful, and this is actually one that's near and dear to my heart. These are my parents. My mom is 82 years old, so now she lives alone in the house that she inhabited with my father. So one of the reasons I was so passionate about joining Origin was because I'm going to be a customer. So I'm incredibly excited about what we can do in this space. And finally, we talked a little bit about this before, so sensing knows if there's an intruder in your space. We'll be able to tell definitively, is it a person or something else causing the motion? And the reason this is important, in the US, if there's a verified alarm, meaning an alarm where we know there's someone there, the police will come within 6 minutes. Okay, but if it's an unverified alarm, that can be 40 minutes plus. So there's obviously a true performance gain here in terms of the security experience and the outcomes for us as end users. And finally, what I want to leave you with here is, Wi-Fi sensing has the power to really transform how we live and inhabit our spaces. We believe that by working together with all of you, we will be able to deliver on that promise, right? We'll be able to make people's lives easier, safer, and more secure. So if you're interested in continuing this conversation, if you want to go on this journey with us, please don't hesitate to reach out. Thank you.
Joe, we've got time for a question or two. Is that okay?
Okay.
So any questions for Joe on this intriguing topic? Don't tell me, Joe, you've told them it all.
I think I've said it all.
Joe, I got one question.
Yes.
People talk about sensing and they talk about the location-based sensing and how far that can go. How close can you get to particular things in distance through Wi-Fi sensing?
So, there's the answer that my PhDs will give you. There's the answer I'll give you. So really what we're focused on and what I'm focused on as a product leader are the capabilities, the scenarios, the value propositions that we think will really have traction in the marketplace. And frankly, for what we talked about up here, intrusion, occupancy, at this point, it's not really necessary to go down to a very granular level of detail. So for example, if someone breaks into my home, I don't care if they're in the garage, if they're in the bedroom, or in the third bathroom. I don't have 3 bathrooms, but say I did, in the bathroom. I don't care. I just want to know that someone's there and there will be a response.
Good.
Okay.
Thank you.
All right.
Really
You're welcome.
appreciate you coming along and sharing all that knowledge.
No worries. Thank you.
Great to meet you. Okay, we're moving to the panel now, which is an interactive session, hoping we can really get you engaged in asking questions of the panel. I'm going to invite to the stage, and they'll introduce themselves on the stage as well. So Metin Taskin from Airties, Oscar Gallego from Vodafone, Willem van Kempen from Liberty Global, and Patrick, who you've met before. So do join me, folks, and we'll have a session on the home. Nice to meet you. Do take any chair you like. Any chair you like, folks. I'll go on the end.
I'll slide in there.
Yeah.
Okay. Hi, nice to see you.
Good to see you.
Good to see you.
Steve, good to see you.
Good to see you.
Good to see you.
You won't get all the questions
No,
just because
okay.
you're next to me.
I take the last see if
Thanks,
I may
Riyad.
not get any questions.
Right, welcome. This is the Brains Trust. That's the way I'm introducing everybody. Now, if I can ask each of you, and we'll start at the end, to just explain very briefly who you are, what you do, be grateful.
I'm Metin Taskin. I'm the founder and co-CEO of AirTies. My background is Wi-Fi engineering, and I'm dealing with the technology and product part of the company.
Terrific, welcome. Patrick is known to you all already.
Exactly.
Yeah.
Oscar Gallego, I work for Vodafone and I take care of all the technology aspects for our consumer home technologies.
Willem Verkempen, Liberty Global, not in the technology side, but on the product side for in-home connectivity, tying our CPEs together to our customers with all the fancy middleware in between, making a great experience for our customers.
Fantastic. So the topic's very much customer-centric. I'm really keen we get to the heart of what does the technology actually do? So you'll see a number of these questions, much more related to, so what does it mean for the family? What does it mean? I thought it was a picture of my daughter actually on the last presentation with her hands in the air looking at the Wi-Fi. But this is important, and I welcome anybody just to kick off, to give me, what are the features, particularly in an environment where we've got Wi-Fi 6, 6E, and potentially 7 all in the same home? What is it that's going to make my daughter say, wow, this is different? Open to the floor.
I thought I was going to be the last, but I'm keep being the first.
Interesting. Then
I've just posed it to the floor. You can all.
Yeah, I was trying to stay a little bit far, but what people expect from Wi-Fi is they want it to just work. They don't care what the speed is. They don't care what the latency we are always talking about. All they want is their applications to work. And like, if it works today, will it work tomorrow? There is an issue of usage changing, usage patterns changing, and what the applications require from Wi-Fi is changing. So my daughters, for example, if Wi-Fi is cut at home, there will be a revolt at home. It's going to be a big trouble. And what do they do with it? They're talking to their friends, they're studying, they're watching, and it's getting more and more demanding. I think we are yet to see the AR/VR effect, the headsets and interactivity of those devices. It's all going to demand even more performance from Wi-Fi. So they will understand if it is Wi-Fi 5, 6, 7, or 8 in the future. What they want is it needs to work reliability, and it needs to deliver what the application demands from Wi-Fi.
Yeah.
It's not anymore what laptop demands or what phone demands. It's what application you run on that laptop or phone or headset demands.
So I would rejoin, up to a point, right? I mean, I have a good friend. He works in the CTO organization of a big tier 1 carrier in Europe. And he told me the other day, it is not, Wi-Fi connecting or not connecting anymore that is a problem. It's the Wi-Fi not delivering the experience that my customer need at the right time on the right device. So it is true that we need Wi-Fi to work. I mean, that's, Metin, you're doing a great job there.
That's opening.
But at the same time, we as enabler, we as, the one providing the box, providing everything for the end user, we got to make sure that we plan for the future. We plan so that the new applications, the new generations, the new revenue creation, potentially for some carriers, is done right, using the potentially new generation of Wi-Fi, but also, as I indicated earlier, making sure that in the gateway, we have the right software, we enable things properly, and we make it flexible so that, when situation evolve, the device can evolve with it.
I think what makes us humans to thrive in this world is adaptability. So we have touched upon reliability, but adaptability is a very, very important aspect. Adaptability means to make sure that the Wi-Fi works at its best, independently of what the situation you have at home, number of devices, who is using the network, etc. And adaptability is, to some sense, that the Wi-Fi is not an entity which is completely independent from the applications that are using it, but that there is a way to communicate the capabilities of that better to the applications that are being used, so we can extract the best of it. And I'm going to put an example. If I'm gaming in one room, and in the other room I'm having an application which is doing streaming, and the application with the streaming can have buffering, but the game is very, no high bandwidth, but very latency dependent, what I would like is that anybody expects some magic to happen, that both applications are working great. One, bandwidth demanding, but not tolerating latency, but the other one, not tolerating latency and very small bandwidth. And I think do it seamless. That's what you expect, right?
Yeah, absolutely. What is, ironically enough, we have been doing this, or we have been catching up with the customer for the last 15 years, right? I think we're doing a great job for 15 years. But the experience of the customer and the demand of the customer has been constantly evolving, and we have been catching up, passing them, and then caught up again with a great service out there, a great new, be it cloud gaming, be it indeed VR, AR experiences that go to market. Maybe it starts small, but it grows big, quick.
Yeah.
Keeping up year over year over year, increasing the speed, making the stuff smarter, keeping the customer happy effectively is something we're doing, I think, very well over the last years, if you will. Yeah.
So for the excitement of the panel, my daughter told me last week, she said, "Oh, you're an expert in Wi-Fi, Dad. You are supposed to be this advisor to the Broadband Alliance."
It sounds very bad.
"I don't think you've done a very good job." I said, "What do you mean, me?" She said, "No." She said, "My speaker says," and I don't know how she managed to get to this, she said, "it's at 2.4 gigahertz. She said, "It won't connect because it says it should be at 5. And I said, "Let me try and help you." And she said, "I did look this up and it says something about 1.192.168 and I've got to do all these things." So I pose that to you, that there's a lot of people out there who actually are quite willing to go and try and help. And some of you say, "Well, we've done all the software." So what do we do for the world where you don't know 192.168.11?
So first of all, right, I mean, you can tell your daughter very respectfully that, and just going to cite a number, just we in Qualcomm, okay, we have shipped since 2015 7.5 billion Wi-Fi devices. That's more than humans, and that's only us. There are other guys, right? So I have to believe it works a little bit, because it would not be so many devices working all together, right?
I did tell her that.
Good.
She said, "But mine's not."
Yeah.
I think it is one of the biggest challenges we have been facing. Demystifying that Wi-Fi black box, right? Which is very complicated to understand. I think we've done a lot, the industry has done a lot, our tech partners has done a lot to automate a lot of the technology in solving a lot of these problems, making things work. But you're absolutely right. This is a situation which is impossible to properly explain, right? But we need to explain and we need to fix it. So we are doing everything in our power to also bring a lot of technologies together, organize it in such a way with nice experiences, applications, supporting you. In the end, the layering, how we do it is, obviously we try to prevent these type of situations, that's one. If that doesn't work, then we need to automatically find and resolve. If that doesn't work, we need to enable the customer to fix this easily, or we need to explain them, guide them, take them by the hand. And if that doesn't work, you, of course, always need to be able to reach us very quick, very fluent, and within the shortest time possible, an agent or a technician needs to be able to resolve this problem for you. But it is still today a very complex situation.
And I only say it just to give the example, to give just real life customer, and I know what's going on, but I do think it's important with the advent of AI, with the advent of consumers getting more tech savvy, the easier we can make router access, connectivity, now with all the IoT devices. It's really good to hear from an operator's perspective And there are numerous out there. Anyway, I just threw that one out there because I thought it would stimulate some debate on the reality of life. My next question is that with so many frequencies in the home, and it's increasing, the amount of tech innovation, whether it be security alarms that are on different frequencies, how can next generation of our tech navigate what is a very complex environment? Patrick, have you got views on it?
So you're right that we're adding 6 gigahertz up to 320 megahertz channel, which is a lot. You know, it's going to allow for a reduced latency. It's going to allow for more throughput. But somehow, as you mentioned earlier, we cannot have a customer saying, okay, I go 2.4, I go 5, I go 6, and then, you know, there is this other device that is also in this band, and how we're going to manage the whole thing, right? So it has to be seamless. And this is what we try to implement with you know, a feature like MLO in Wi-Fi 7, where effectively the device itself is able to sense what is going on, what is the best channel, and you know, what is the best frequency band, and then just operate and make it work. So that's, I would say, at immediate level, right? That's dealing with the new devices. And for older devices, I mean, you know, we have our colleagues who have done some pretty good job.
Yeah. If I may, what you were telling about the previous question, 192.168.1.1, this is what all of us know, of course, but the end users probably doesn't know. This is what we call Wi-Fi before. Now we have something called smart Wi-Fi. This is why it's, you know, why we are talking about smartness, including user being able to manage its Wi-Fi, being able to see what's going on or make some choices there. That's, you know, what does your daughter know best? Use a mobile application.
Indeed.
They know how to scan a QR code. They scan QR codes so fast. I've seen that. I've done a user test on installing our access points. I was worried about this QR code people doesn't know. They scan very fast. They know how to scan QR codes. They know how to use mobile applications. They know how to, you know, go between menus in mobile applications. This is where the smart Wi-Fi comes into play. We make those things available to the end user. Also, we make tons of tools available to the service providers too. Coming to your second question, you have 3 now with Wi-Fi 7. I think it's going to be very common that we have 2.4, 5, and 6 gigahertz. And Wi-Fi devices have the choice to connect whichever one they like. If it's a newer device, like Patrick says, the newest chip from Qualcomm, it will connect all of them. But all devices can't do that. They can only connect to one, and they typically make wrong choices. So the smart Wi-Fi system is basically making the choice on behalf of them and make sure, this is a technology we call steering, that basically the network decides which band is the best for that device, depending on its signal level, the location, depending on its technology, depending on what it demands. Even we are going deeper down into like what application it's trying to run and what frequency will be best for that application. I'm talking about future now. But this is where we are going. So the network adaptability is number one thing on Wi-Fi, because Wi-Fi can act very differently to different type of devices. But when and how this action should take place, that comes from the smartness of the system.
That's terrific to hear, and I think for the operator colleagues particularly, to hear these steps that are happening means that they too, as I would have done when I was head of products at BT, innovate to make sure I get the next features there. Any questions from the audience? Anybody? One over here. Thank you.
I was intrigued by your daughter's situation. I wondered if, in fact, she probably paid $1.98 for the product, and whether or not we put in redundancy or self-diagnostics or whatever, there's a price point that perhaps it's just time to recycle it and buy something new.
Ah, that's a very, very good point, and it is a topic that came out of a previous presentation, and I pose it because it's one of the biggest challenge, I think, for operators, and was when at the moment, many, many countries' operators bundle the device with the broadband, and the race to the bottom of the price of broadband means you might not have the most innovative, advanced, as Qualcomm described, devices. So she actually did pay a reasonable amount. I've got to say her smartphone device, her smart speaker device was like very advanced, but clearly not enough. So I pose the question, taking your point, of what do we do to make sure that the investment in the smart home router hub of the future can be enough when you're really chasing consumers and it's a pretty tough market out there?
I would like to take the question, or the challenge first. Very good challenge. I mean, the first is that that girl has a father, and the father has a budget. At the end of the day, the budget is not a problem. The problem is the business case. So actually, if we are just thinking that the CPE we have at home is an element to provide connectivity, I can tell you one thing. That business case is raised to the bottom. Okay? If we think that the CPE is an element that is at our customer's heart, at the home, and we are able to provide applications or to reuse the computational capabilities that are available in there for another purposes, to give services, then the paradigm change, because we find ways where that business case is changing, not only monetarily, but customer value and customer appreciation for you as a service provider bringing the latest technology. So let me put an example. There are some technologies we are working in here, Wi-Fi sensing, actually, where I'm very excited. My mom lives alone, back in Spain, unfortunately, and we have a very good way to help those people to understand whether they are okay. My mom is very private. She doesn't like to have cameras in the house. So actually, it's very nice to have a service that you can put to know whether she's okay. For me, as the one which is the IT guy, like all of us in our houses, come on, it's a no-brainer. If that adds value to the customer, then there is the circular economy, gives value to the operator. It can be NPS, it could be an extra subscription. Let's not enter into the detail. Then if I'm able to monetize it, I'm able to invest, and I'm able to get amazing platforms from Qualcomm, Tri-Band, the latest chipsets, MLO, or I can partner with companies like Artice, we actually do, to make sure that your daughter does not need to care what 2.4, 5, 6 it is, because we have a way to self-diagnose. And I don't want to say the word because the hype this year, but I have to say it. AI, that thing that was created this year and didn't exist before, okay, because they didn't exist. Apply to that, allow us to choose the right channels, to understand whether the power levels need to be changed, to understand what band you need to put a device. And you see, that is the concept of circular economy we are doing. What do you think?
Yeah, no, I can only echo that. Yeah, absolutely. I fully agree. And I think on top is understanding indeed those devices. So have a better understanding with these type of AI technologies, understanding exactly that particular speaker in this case. That we're not randomly guess gaming a certain device and maybe it is this or that, but exactly knowing it is this device.
Yeah.
And we know by, we have seen many more of those devices, what actually could resolve the issue. Right?
Yeah.
So again, within a matter of seconds, resolve or explain how to resolve by having a deeper understanding with these type of technologies, what the limitations of a certain device are and how you could resolve certain things. Yeah.
Can I build on this commercial question? Can I build and ask a question? Do we feel at all, particularly in the operator community, that there is a value add service that you might want to buy the base level, cheap device, I suppose, as a router? What about those who want the most advanced, want this technology that we saw on the screen earlier, perhaps cloud in there, etc.? Could you see a model evolving? Even modular routers?
Yes, but it is tough. Because I think, again, going back to what we have been doing over the last 15 years, we have, as part of a retention mechanism, solving these issues for the customer. So the customer is also very much used to giving more speed, giving better technology, solving that speaker problem de facto as part of the service. So in the base, the hygiene is the Wi-Fi, right? And the hygiene maybe is even the intelligence that we're now putting on top, because simply the customer expects us to solve these connectivity issues, right? Because it's a service you deliver. So it's the monetization elements on the Wi-Fi itself are, yes, we do believe in it, but it's a tough nut to crack.
Yeah.
More and more we look in other domains where we potentially see the monetization opportunity on top of the Wi-Fi, right? Maybe sometimes being it some of the smartness elements or the AI, maybe it's in the domain of smart home, automation, etc. But I don't know how you guys see it, but it's...
I just say, I'm not going to mention NPS data, but there is a direct correlation, linear correlation, between the quality of the Wi-Fi and how happy the customer is.
Yep.
So,
quite right.
That's not something that you learn from going to presentations. It's something that every day I sit with a guy called Arnaud back in Germany, and we are crunching the data, and actually we get exactly that correlation. So that is the first thing. People talk about money and so on. At the end of the day, we should not. We should be talking about happy customers, because the moment that your customer trusts you, then you have it. And I think there is a second element. For many years, service providers, we have abandoned, we have no love our CPEs enough, okay? And I think that is changing rapidly, because if you want to give an integrated service, as important as the fixed connection, FWA connection that you are providing, is the end-to-end. And now let's start to think latency, end-to-end services. And that's another paradigm that we need to be working together. And thanks, the technologies that the EBF are bringing, they're amazing. And having this quality of service driven Wi-Fi, following the customer choices, okay, and thinking the possibility that choices can be extended further, pending regulation and pending what we can do within that regulation, it's very exciting, and that's another line we can grow.
Terrific. Any other questions from the audience? Exciting debate at the back.
So with all these devices in the home, how are you going to manage the firmware? Because it's a nightmare today for security updates and all that stuff. You're adding tons of devices.
The firmware of
all
which?
the IoT devices, or all the little devices in your home, they're connected in your smart home. Every manufacturer has different ways of getting it down. Like, how do you manage that? Because today is a nightmare.
I think, I tell you my view. I think the ecosystem is converging, okay? And I think I have a lot of hopes in one particular initiative called Matter. Matter is a layer that not only runs on 802.15, but let's remember it's running over Wi-Fi as well. And I think it's an evolving, I really enjoy going to that discussions, because there are problems that are brought, and then solutions that are brought to solve it. And I think our gateways, our CPEs need to embrace being part of that Matter ecosystem, and because at the end of the day, the underlying mechanism in many of those devices is going to be the Wi-Fi. And if we could assist by making sure that the Matter network can be extracted, and hoping that the standard goes in a way that we can simplify that very process, Matter brings an incredible layer of security. That is one way that I'm thinking, but I don't know, guys. So many intelligent people here, I'm pretty sure.
Yes, so if I can, maybe broaden the scope, right? And coming back to the question about the router, right, or the basic box, I think you have two ways to manage the situation. One is you do the race for the bottom, right? And if you do the race for the bottom, you want to invest as least as you can. You want to keep your devices as long as you can, and do as little as you can. That's not the way we recommend in Qualcomm. Instead, we think it's better to have a device that effectively is future-proof, that can evolve, that can adapt, and that requires a minimum set of capabilities. But that requires also a minimum set of, security, functionalities, maybe things derived from cell phones. We know a little bit about cell phones. And and something that becomes future-proof. And that's where it's complicated, right? Because how do you know future-proof? You know, that's why we are smart people here. But the carriers who are able to future-proof their gateway, who are able to implement, you know, all those, you know, software-defined architecture, you know, having modular blocks, having, you know, built a middleware that allow them to plug and play new devices as they come along and ensure the security around it. They're the one who are going to be able to extract more ARPU. They're the one who are going to be able to have a higher customer satisfaction. They're the one who are going to have a, you know, higher quality of experience to their end customers. And they're the one whom, you know, are going to be able to sell maybe, you know, a smartphone sub or you know, security cameras or some other things that comes with it. But it's a race. I mean, people have to pick their, you know, the direction they want to go.
It is a big challenge because we know that this technology is not just software. It's got hardware, it's got chips,
100%.
Inevitably. And therefore, to keep ahead of the evolution, you always need to be interact between hardware and software. Anyway, I'm going to turn to another interesting topic, and I'm going to please the marketeers in the room, if there are any. So, how important in the home, particularly for router devices, is size, color, shape? Are we in a world where we're in somebody's front room where people make decisions about the color of their walls, but actually we don't give them the choice of the color of their router? Discuss.
Well, mesh multi-node setups, obviously it is inevitable that you end up in more rooms than, for example, in the Netherlands, you end up in your utility cabinet somewhere, right?
Yep.
Or behind your TV cupboard. Which are all horrible places to put your Wi-Fi. So
We're
anyways,
coming
we
to
need
that
to
in a
explain.
minute.
Okay, but so in this case, size does matter. What is important, and specifically, for example, if you now see, but I'm seeing some great and promising things, by the way, here on the stands, is that the customer indeed wants smaller devices. Going into Wi-Fi 7, we are giving them bigger devices, right? People want more eco-friendly, less power-consuming devices. Yeah. We give them maybe a bit more, maybe a bit, pretty significantly more power-consuming devices. I'm happy to see that if we talked about Wi-Fi 7 last year, and if you look at it now, the industry is doing an awesome job in working on that, making it smaller, making it more power efficient. And these are make it more appealing, right? Yeah. Because it needs to be positioned in spots where the Wi-Fi is can radiate in the optimal form. Mm. But the trend on that, getting the size down, getting the energy consumption down, is not a one-day fly. This is here to stay, and we as an industry will keep on pushing on those type of requirements, yes, because they are very important to our customers.
I think in just sustainability, just to finalize on the points, because you were very right, sustainability and personalization. So sustainability, I mean, every single element in your house is becoming a sustainable material, so sustainability is very important. Then the last thing is, I mean, personalization. I mean, at the end of the day, you want to have likable devices. Let's face it, companies have made an amazing job. I mean, you look in the likes of these assistants, the speakers that we have at home, they look lacquer, they look beautiful. So you want to have them in a place which is visible. And I think if we really want to be there, we need to create a design. Now, there is a compromise between that design, thermals, packing a lot of things. It's a complex process, but definitely this part is a very important part.
Yeah. Metin, have you got a view on design, color?
Yeah, so I think when customer is making a decision, design probably plays a little bit role. But I don't believe that anybody is proud of putting a Wi-Fi access point in the middle of the living room, or putting the gateway, look at my new gateway. Only a small percent of the users, you know who I'm talking about. It's not really something that everybody is striving to buy and, you know, show. So I think it's there is a compromise on that, like Oscar says. You cannot make something very small and, all concentrated heat. You have to turn it off if you use it more than half an hour. This kind of games you cannot play. You need to make sure that network works all the time and network provides a service.
Yeah.
It can be hidden. It can be not in the middle and in the corners and things like that. It cannot be very ugly. Of course, you cannot, you cannot put a very ugly device where people live. But I think it needs to be a healthy compromise between the performance and the size and the looks.
I think I remember the very first time we created a BT home hub. The marketing guy didn't know what it was, didn't know anything about Wi-Fi. And he described in the end, he said, right, so you want this device, not for eco reasons, but to be like the fireplace in the room, that people go like this. I said, yeah, I'd rather they went like this, but that's quite right. Yeah. And he had the concept that you needed it in the middle of the room. And we had the tech rationale. So I'm going to come on to that tech rationale. How much do we do to encourage customers to put these devices in the right place? If they're ugly, they will go out of the way. But how much do we do generally so that they understand that it needs to be in the right place?
Right. But so from a semiconductor perspective, okay, the only thing we can do, because we don't control the outside, we provide the inside, we don't control the inside, is to give flexibility to the operator, right? So how do we give them flexibility, right? I mean, that's exactly what has been mentioned before. If you have lots of power, you're stuck with a big radiator. If you have a big radiator, you're stuck with a big box. If you have a big box, that then you have less chances to make it cute and pretty and something that everybody wants to look at. Also, in terms of integration, if you integrate things in together, if it's only a few chips, then that makes it easier to make a small PCB. If you have a small PCB, you can have something which is maybe with more enjoyable shape or something a little bit more creative. So I would say from the inside looking out, the only thing we can do is to do the best we can,
of course,
and to give flexibility to the designer, because make no mistake, something that is ugly, your wife is not going to get it.
No, that's true.
Right? I learned that painfully 25 years ago when I designed my first cell phones. We were designing first cell phone, and we had this great technology. And I wasn't working for Qualcomm at the time. I was working for an OEM maker. We had this great technology. We had the first color screen. We had this nice, setting for the trackball. And we were very, very proud of the technology. We had a bunch of geeks, a bunch of engineers. And we had not so, I can tell it now, we had not so good designers. And they came up with something that wasn't very pretty. Guess what? We had no commercial success. At the end of the day, you got to make something pretty if you want to sell it. Yeah.
Indeed. I thought it was incredible that one of the fastest selling cell phones in the UK was because it was pink.
Yeah.
We've got to keep that in our minds, that life isn't just about the tech, it's about perception.
But I think I'm not in the same opinion. Cell phone is something else than a router.
Of course.
Right? So,
yeah. But it is in the front room, and I know what my wife would do. If it didn't look good, it's in the cupboard.
But there are ways to educate the customer which are not only the aesthetics. And it's very important to take into account. The aesthetics is a tick in the box. The second is to help customers. Going back to your daughter paradigm, I mean, one of the things that we have found in Vodafone most important is when we were working with our guys and we were having our extenders, people didn't know where to put the extenders.
I wanted to say that.
And basically, by creating a program that is actually within your application, making the application compelling and human, making something human, okay, in the world of AI is very important. So simply like move it, keep going to the left, keep going to the right. No AI, AR, VR with glasses. No, just simply go a little bit to the left, go a little bit to the right. You put it in the right place. They understand that is important. So if you put the aesthetics, acceptable aesthetics, or even beautiful aesthetics, together with the fact that the easy of use, which is not only the CPE, but is the compelling application and proposition, then you have a winner formula. And sometimes the aesthetics play a role in the whole customer language that you are lying.
It's what was funny to see is that when we pushed out our into the market our mesh setup, The first thing customers would do, take one out of the box, walk into the room where there was no Wi-Fi coverage, plug it into the wall. Happy days, right? Right? Unfortunately not. The link to the gateway,
Wouldn't work.
It wouldn't work. It was a disaster.
Yeah.
We have invested a lot of time, effort, money in indeed optimizing our flows for our customers, for our agents, to really, again, take them by the hand, because positioning, indeed, is crucial in getting the right quality of experience out. And yeah, we also, let's say, we failed also, and we learned from those failures and evolved over time, but it was a bit of a painful ride at certain points, yeah.
I think it's fantastic, and it would be great. We should get more marketeers to come and speak about how they promote Wi-Fi, because what we hear here is a huge range of features and value add. What you read on the headline sale price is 1 gig.
Yeah.
2 gig. And this is a mismatch, because we talk about value, we talk about paying, and people then just look at it and say 1 gig. And I'd like to come on to that, because the 1 gig is very much in the mind, because it's been fiber-centric or whatever, is in the mind, because people buy Wi-Fi, and we often sell fiber. But the customer says, my Wi-Fi. So this positioning between fiber or wireless and buying Wi-Fi is they thought they were getting 1 gig. What do they get? They might with Wi-Fi 7, but what do they get? And what can we do with our marketeers to bridge this divide? Because it's a gap.
Please help us. Please help us with that, because indeed it is we see that speed became a parameter for quality, if you will, right? Higher speed is probably better, right? Because it's more expensive, so probably the quality is better. But in the end, if you had poor Wi-Fi, I can put 10 gigs in your home.
Yeah.
But if the Wi-Fi is terrible, it's useless, right?
It's very funny that you brought this topic, because we had the same discussion one year ago internally. And can I tell you how we call our packages and how announce our packages in the UK? Zoom, Boom, we call Super Wi-Fi. The 1 gig is a detail that you get underneath. So we try to have customer language that associate experiences to the customer. Super Wi-Fi, what it tells you? Your Wi-Fi is solid. That then it means that you need to have an extender to extend it. Okay, technicalities, but that you get these concepts associated to the emotions of the customer rather than 1 gig, 2 gigs, 10 gigs. By the way, I'm quite scared, because now we have 25 gig and 50 gig. I mean, what are we going to have, a competition to put 50 gig at home? I mean, okay, that's going to be an interesting one.
That is terrific that you're doing that. I was heartened by our friend from Orange who kicked off the conference and talked about the customer language. What are they seeing? What are they trying to do?
Yeah.
Metin, I'm going to let you finish off the conference panel with that topic. That topic of, so what can we do to communicate that? So how do you translate latency and what it does? Because we're all speed. What is it that we can bring about? And should we bring latency into this debate?
It is a very good question, Steve. We always talk about speed, and speed is, okay, everybody understands speed, faster is better. But there is a phenomenon out there that even if you have the gigabit fiber and you have all the speed you need, some applications don't care about the speed, they care about latency. Interactive applications we are talking about. It's basically, an application that requires sending something, getting a response in a short time. So especially in AR/VR domain, this is becoming a very, very demanding need, and latency is not, okay, faster means you have less probability of having a latency problem, but you still have latency problem, and it typically comes from Wi-Fi, by the way. Wi-Fi is the one that can have some unpredictable latency. So there is a lot of work to be done to make sure that for the right application, the application that requires low latency, Wi-Fi will try to provide at least low latency to that application. For Netflix, latency doesn't matter, right? It keeps downloading in a big bandwidth, and then once it fills up its buffers, it just goes on at a lower rate. But for, let's say, for video conferencing, latency is more important. Not as much as the AR/VR, but still, it has some latency limits. But when you come to a headset and you are changing your head, you need to send a packet and you need to get a new video coming back, the latency is like less than 20 milliseconds. 20 milliseconds is, what, 1/50th of a second latency. And that is not easy. It sounds easy, 20 milliseconds, we should be able to do, because when you do a ping, you may see 3-5 millisecond type of numbers. But doing that for every packet, every second that you're receiving video and you're sending something back, it is difficult. So that's where the latency comes into play. We have commissioned a white paper with Omdia. Michael Philpott wrote that. It's available on our website. It's talking about Wi-Fi QA and what affects it and what it means for broadband services, and a lot of things about latency.
Terrific. Gentlemen, thank you for navigating such a different number of topics. And I appreciate all the audience staying and joining in as they did.
Thank you.
And we're going to go to the awards shortly with Thiago, but firstly, a round of applause for our guests here.
Thank you, guys.
Very nice.
Thank you. Thank you very much.
Very nice to meet you.
So, hello everyone. Once more, welcome. I want to thank you, Steve Andrews, for the fantastic moderation of the panel on the smart home. Now is the moment for the WBA Industry Awards. I want to invite my partner in crime, Dr. Derek Patterson, co-chair of WBA and the CTO of Boeing Wireless.
Thank you.
For these awards, we have 8 categories. The team prepared a series of videos. Looks like we'll not have much work to do, but we are here formally to deliver the awards. Let's pass a short video, and then we'll start with the awards. Okay, so I just want to make to reinforce 2 topics. So first of all, a big thank you to our independent panel of judges. You can't imagine the work that is behind the evaluation and revision of dozens of submissions that are made with videos and description and case studies. Is really a significant amount of hours that are invested on that effort. So big thank you to them. And as well to thank you all the applicants and all the submissions, all the companies that have submitted. So it's fantastic to see the number of submissions that are made on our awards. And with this, I want to start with the first category, so the Best Wi-Fi Network Operator Award. Yes. Thank you. Thank you so much. Congratulations.
Thank you very much. It's an honor to receive this award, and also please keep watching KT Change for Wi-Fi 7. Thank you very much, and have a good time in Paris.
Thank you.
Thank you.
And thank you for submitting every year submissions from KT.
I hope so.
Thank you. Okay, so let's move to the second category. That is the Best Wi-Fi Network Technology.
Thanks everybody for this amazing award. We're incredibly happy about our collaboration with everybody in the WBA, and it's my vision that open Wi-Fi be kind of like the Pixel phone of Wi-Fi, where the standards that come from WBA can be implemented quickly and in open source for all to benefit from. Thanks very much.
Thank you. Congratulations. Congratulations. So next category is the Best in-home Wi-Fi network.
So thank you very much. It's an honor again for us. And in Wi-Fi, we are improving everything from the chipset level, from modulations and everything, but we are keeping the spectrum unorganized, and we are tackling this by a mobile application. Thank you very much.
Yeah, I can only say that you guys are doing a great job, that our judges rewarded for the second year in a row as Best in-home Wi-Fi.
Thank you.
Thank you. Fantastic. So next category, best enterprise Wi-Fi network.
Okay, so thank you, Tiago, thank you, WBA, and thank you for the panels who recognize our work and also our product excellence. I believe, as a matter of fact, this may be the second time or the third time we get this important award, so it is really an honor for us to receive this important recognition. Thank you so much.
Thank you. Okay, next category is the best Wi-Fi for social impact.
Thanks again. And obviously, Open Wi-Fi does offer the chance to lower TCO and deploy lots of Wi-Fi networks that could not otherwise be deployed, and we're very proud of that. So thank you very much.
Okay, next category, best Wi-Fi innovation.
Well, thank you, everybody. I think we've lost Metin. I'm not sure where he's gone. I'm standing in. Thank you, everybody at the WBA. Thank you to the judges. This is a great recognition for us. We're very proud of our hybrid cloud edge architecture, and this is what our application here was based on. Thank you for the recognition from everybody.
Congratulations. Okay, next category is the best Wi-Fi customer experience.
Well, I want to thank the WBA, the judges, all our partners. We couldn't have done it without the collaboration of everybody in the industry who's part of the WBA. We've been a long-standing member, participating in the working group sessions and helping drive the standardization and the adoption of Wi-Fi sensing, because it's a truly, truly innovative feature, and proud to represent Cognitive Systems as part of this award ceremony today. Thank you.
Okay, last category, CTO of the Year.
So I was just noticing in the video, I look very serious. Yeah.
Excited.
You know, a CTO is only as good as the team. I love to innovate, but it's even more special when you see the technology implemented. And I think WBA, the innovation and getting it to market, it's been a pleasure to be here. So very much appreciate it.
Thank you. Congratulations, man. So once more, congratulations to all the winners, but as well to all the applicants and all the submissions on the awards. Please follow WBI on the awards. Of course, still a lot of time, but please submit for the next year awards and be part of this ecosystem. I just want to close. Yeah, thank you for your participation. I just want to close the session just to a big thank you to our sponsors that made this event possible. And now I want to hand over here to my colleague, Derek, and to make an invitation. Please, Matt, join us as well. We make an invitation for the drinks reception.
All right, so we survived. Another thing, I did my Vanna job well, right? You didn't ask for a vowel. You were supposed to ask for a vowel back there. No vowel. But anyhow, thanks again for being here. You know, we enjoy hosting people getting drunk, I guess. We've been doing it for quite a few years. So we're going to have the drinks reception now. So please come over, have some fun, talk about some great innovations, talk to the award winners, and what? I have no badges this year.
No,
sorry, no badges. No stinking badges, if you remember that show. But anyhow, please come out and join us.
Let's celebrate the awards. He's right outside the door on the speakers VIP lounge.
Yeah. And I'd just like to say, you know, it was a great day today. You know, it started off great, it ended great, so thanks everybody for coming and being a part of this. We're getting traction, and that's great. With Wi-Fi, we've got a huge year ahead of us, as you've seen, with 24 and 25 with Wi-Fi 7, so it's exciting times. Let's get the word out there and get more people going. So with that, I'm going to hand it over to my partner in crime, Matt. Go ahead.
So I think Derek pretty much said it all.
Yeah, I do. I talk a lot.
I will say this, as we work with the WBA, it's always amazing to me all the new submissions for work groups and the activities that are going on at the WBA, and so we continue to see this expansion, and every time I come out, it's always great to see some of the same faces and the folks that we've been working so hard with, but it's really exciting to see some of the new faces as well. So especially if you're a new face, come on over, have a drink, shake some hands, get to meet the broader team, and really just enjoy the rest of the event.
Yeah, I have one more request. I want to request all the winners to come on stage to have a group photo. So please, ambient tip hours, where are you? Please, let's get a group photo, please.
With the certificate or without?
It can be with the certificate.